That song was so good.
I know. I was ready for it to keep going.
Oh, that's like my theme song in my head always. Okay. So, hey, hello, and welcome to Container Day, everyone. So my name's Adam Keller. I'm a developer advocate here at AWS, and I'm joined by Brent Langston, who is also a fellow developer advocate here at AWS. And if you don't know, we're the hosts of Containers from the Couch. It's a near daily show that we host here on Twitch, and we discuss all things containers. And rest assured, it's not just Brent and I. We oftentimes have engineers, solutions architects join us, partners, customers, and heroes. So if you want to see more of us, check out our YouTube channel. We will be posting that link in the chat. And tune in Monday through Thursday, every Monday through Thursday at 12 p.m. to 1 p.m. Pacific time.
So we're super excited to be hosting Container Day. This is our 4th Container Day and our 2nd virtual Container Day. Our last Container Day in August was predominantly pre-recorded sessions, but for this one, we're glad to announce that it's going to be 100% live. We have a ton of great content planned with a mix of sessions, panels, demos. And in addition to technical content, we have some fun segments planned. We're here for a full day, and it's going to be a long time of sitting. So we're going to bring in Yogi Ali Singer to get us moving with a few stretch breaks. Then during lunch, we're going to have some Boston chefs walk us through making a bourbon apple cake. And then to cap off the day, we're going to be joined by mixologist Kevin Rausch, who's going to show us how to make some Boston-themed cocktails. If we've been able to meet in person, we'd all be together in Boston. And even though we're not together in Boston, we're virtual, we're going to bring Boston to you.
Wow, I like that. So we're starting the day with a keynote from our general manager of Kubernetes and application networking, Bob Weiss. And Bob leads the teams that maintain Amazon EKS, AWS App Mesh, and AWS Cloud Map. And Bob also sits on the governing board of the CNCF. So let's bring Bob up now for some product updates and announcements.
Right on.
Hey, good morning. Thanks for that excellent intro. Let me start, since you mentioned the teams right at the outset, let me say a little bit more about them. Our Kubernetes team works to enable customer success with Kubernetes on AWS, whether that's removing engineering toil with the EKS service or providing images, AMIs, plugins, contributing upstream for our customers, or hosting events like today, where we can talk about Kubernetes and how to succeed in deploying applications. Our application networking team strives to delight customers by making it easier to connect, secure, monitor, debug applications, whether those are containerized applications using ECS or EKS, or using EC2 directly without using the container tool set. We are 100% live today, and you'll notice at the bottom of the screen here is an email for feedback. We got a lot of feedback from folks last time that they really enjoyed the live events. So with any luck, you'll get to see kids and dogs and who knows what else. No second takes today. Please join us on the Slack channel for chat. If you have a question that you don't want to ask in chat, please also use that email. Make sure you catch us at our virtual KubeCon booth. And as the containers from the couch guys said, we have some other fun stuff for today. Also, we're giving away AWS credit codes. Make sure you're registered for this event and send a note to that email address letting us know your favorite session of the day. Here's our schedule for the day. Lots of great content for you. But let's get started talking, of course, about EKS. You'll often hear us talk about security first as a guiding principle for EKS. And starting today, we are going to have a new standard segment for Container Day to talk about security. This is going to be our first deep dive session following the keynote, today presented by Micah. Micah is the AWS representative on the Kubernetes Product Security Committee. It's one of the areas that we contribute upstream. So that's going to be a great talk. So I suggest you stick around for that. We support production workloads across a variety of customer segments, from very small to very large workloads. We love Kubernetes. Our customers love Kubernetes. Using Kubernetes is wonderful. Operating it is serious work and can be some toil. And with EKS, we do that for you. Our customers tell us they love using Kubernetes, and that means they want it just the way it is upstream. They don't want us to fork it. They want us to secure it and run it for them, and that's what we do. We also work to be sure that other AWS services are well integrated into the AWS Kubernetes experience. We have an awesome breadth and depth of services across AWS. We want them to work well with Kubernetes, whether that's EBS drivers, VPC networking drivers, the various open source CNI plugins that we provide, or EC2 with things like managed node groups. We're taking this even further with a system called ACK, which we'll talk a little bit more about here in a bit. Our open source contributions also include the data store for Kubernetes, among other systems. It's called etcd. And wanted to acknowledge that etcd looks like it's close to graduating. It's on track. This is going on right now. We're really excited about it, especially as one of the etcd maintainers, and we're pleased to be supporting the graduation process. Of course, the contributions we do upstream are on behalf of our customers. Here's a few of them. We learn directly from these customers. They guide our product development. They guide the community contributions that we make. And here, let me dive in a little bit deeper. Here's some customer spotlights. Note the breadth of different industries here, from social media to healthcare to finance. And of course, extremely important to so many of us in COVID times, food delivery. So some quick highlights here. 2 million TPS, hundreds of containerized applications, improving delivery velocity, highly sensitive applications from finance and healthcare, and cost optimization, helping our customers save money. Let's look at what we have delivered for these customers and others this year. We delivered quite a lot. Nate Tabor is going to be covering some of this in his session as well. But but let me cut to a few highlights here. Core security for EKS is, of course, one of our most important things, the most important thing. You'll hear Amazon people frequently talk about security as job zero, and that's true for EKS as well as any other service at AWS. But for our customers, we also need to provide them configurable security controls so they can adjust their security to what they need. So continuing to deliver security controls for customers to manage their systems. We've delivered that. We'll continue to deliver these. Close second after security is reliability. We prioritize stability, and our SLA update this year is in recognition of that. Customers that love Kubernetes want to run Kubernetes everywhere. We're committed to having EKS be where customers want it, including outposts, wavelengths, and local zones. One of the things that we heard was customers wanting an increased pace of version support. We've delivered that. And we will continue to deliver on great integrations to all the other awesome AWS services. Things like ACK, networking, storage, or new instance types like Graviton and Inferentia. And just a reminder, customers guide what we deliver through feedback. And one of the key ways we get that feedback is through our public roadmap. If you want to stay up to date on projects and features we're working on at a request, this is where you can do it. Our product management teams constantly monitor this, and the feedback you provide here directly impacts our priorities. Not everything will be here, but it's a great view of what's to come. And we do have some new things coming soon. So what's next? Kubernetes control plane auto-tuning. So this is rolling out now. It will be available without any action on your part. All new clusters have this enabled, and we're rolling this out across existing clusters in the next few weeks. So we will automatically change the provision infrastructure under the covers automatically to support larger clusters and higher demand on the API server. And we talk about consistent performance from small clusters to large clusters. We say from 1 to 5,000 nodes here. And anyone that has worked on Kubernetes scaling will recognize that nodes are really just kind of a shorthand for the size of the cluster. It's possible to have nodes that don't put that much load on the API server on the kind of core Kubernetes control plane. So this is really just a shorthand for clusters that are a lot busier than others. If you want to go beyond the 5,000 node shorthand scaling, which is what the upstream project tests to, contact your account team. We can help you there. And there's no additional cost to run larger clusters. Okay, so let's talk about one of the other dimensions of cluster scaling, which is scaling the cluster up and down. The cluster autoscaler is widely deployed, well understood. We're a contributor to it. It is an opinionated system. It is also widely forked by customers who want to customize how it operates for their applications. And some of the challenges there are pre-scaling and scheduled scaling are a bit complicated. Techniques like scheduling preemptible pods are potentially wasteful. It was not really designed to deal with heterogeneous fleets, and especially, for example, customers using heterogeneous spot have been asking us for some better solutions here. So we've been doing a lot of thinking about how to take a more flexible and extensible approach. And we're introducing Carpenter. We have some ideas we're exploring here. We'd love for you to explore them with us. Metrics-driven node scaling built for Kubernetes means you can use metrics of your choice to drive the scale of the cluster and define fine-grained policies for scaling up and down. We're designing it to optimize for any workload in any environment, including using constant time scaling for queues and schedules or reserved capacity. Reserved capacity is the pending pods approach. We're proposing an extensible architecture to adapt to any metric source. Carpenter is open source, customer driven. This is a AWS Labs project. You can see the link here. But we are building this for any Kubernetes cluster in any environment, and we welcome partnership and contributions and feedback. We've talked about this before, but since it's officially in preview as of yesterday, I wanted to point to this again. Red Hat OpenShift service on AWS is a service operated by Red Hat, jointly supported by AWS. Console listing, pay-as-you-go billing through AWS, single contact for support through AWS. We're very excited to see this coming soon. All right, let us swing our attention to app networking. So let's talk a little bit more about AppMesh to do a review. Let me recap. This is our AppMesh is our Envoy-based service mesh. It is a managed service mesh that provides application networking to make it easy for your services to communicate across multiple types of compute infrastructure. It enhances communication security, communication visibility, failure isolation, protection, provides fine-grained deployment controls. Many of these benefits you'll recognize as benefits of using a service mesh approach. But of course, AppMesh is a managed service that provides the benefits of an Envoy-based mesh without the toil. So we'll help you scale it, make it easy to use. And we have been delivering a lot here this year as well. It's been a busy year. For CloudMap and AppMesh, we've released features to improve security, observability, and traffic management. And of course, notice the AppMesh Kubernetes controller. We also have a public roadmap for AppMesh on GitHub. You can see the link there. And yes, we have new stuff here too to announce today. We're announcing mutual TLS with Spire support coming in the next week or so. We're launching the ability to enforce service-to-service authentication using MTLS with AppMesh. When you enable MTLS, only client services that present a valid certificate will be allowed to establish TLS connections with server services. A very highly desired customer feature. Customers can use Spire to manage certificates or link to their own cert management to present certs in a file-based manner. Again, coming soon in the next couple of weeks. Okay, so we've had a lot of pieces here. How do we tie these pieces together with operational practice? I'm sure you're not surprised that I want to talk about GitOps. So let's do a quick refresher. So again, tip of the hat to Weaveworks as the originator of the GitOps term. And we're pleased to have Weaveworks folks joining us, including Stephen, who's giving a GitOps talk later today, and Cornelia, who's going to be joining us for the panel session in a bit. But in summary, with GitOps, the system is versioned in Git, described declaratively, and the robots do all the work. They do the work to constantly converge the system to the desired state, which is declaratively defined, and ask the humans for help when they don't know what to do. Diving a little deeper on this, it's really critical to not conflate CI and CD. I try hard not to use the phrase CI/CD because they are very different practices. One of the lovely things about the GitOps model is a clean and understandable relationship that is created between CI as a dev practice and CD as an ops practice. I think the notion of the immutable firewall in between them based on Git is really excellent. All right. So if you're going to practice GitOps, You're going to be interested in, of course, using a GitOps approach to configure not just the Kubernetes resources, but things that live outside Kubernetes. I mentioned ACK already as an investment we're making to reduce Kubernetes developer friction to using and managing AWS services. It's a key enabler of GitOps workflows on AWS, although of course highly useful if you're not bought into the GitOps practice. You'll still find it highly useful. So one thing I want to point out here is that ACK is really a collection of things. We don't consider ACK itself to be a monolith. Each ACK supported service is on its own release train and supported by folks from the various service teams. So right now in preview is ECR, DynamoDB, S3, SNS, Elasticache, step functions, and API Gateway v2. And coming soon to preview, EKS, Lambda, and RDS. And it also has a roadmap page here. You can go and see this on GitHub. And especially since these different controllers for different services are kind of each on their own release path here, I think you'll find this one a highly useful one. And we would love to continue to get customer feedback on which services they want to see added next. This is not all we're doing to help developers with GitOps or with dev tooling generally for Kubernetes. So CDKs, YAML is the machine language of Kubernetes configs. If you haven't checked out CDKs yet, would suggest you do so. So this is gotten to be a very popular system for removing the toil from YAML engineering. Okay, so putting it all together, don't miss Say Goodbye to YAML Engineering with CDK for Kubernetes. And the team will be talking about putting all these pieces together. All right, enough about systems for now. Let's talk a little bit more about people. These are our container heroes. Special thanks. The AWS Heroes program recognizes the worldwide group of AWS experts whose enthusiasm for knowledge sharing has real impact on our community. Heroes go above and beyond to share knowledge in a variety of ways, including social media, blog posts, open source contribution, forums, in person at conferences, workshops, user group events. But I'd like to make a few extra shout outs here. Vlad is developing a course on getting up to speed on running containerized workloads in AWS. Casey wrote one of our most popular blogs covering optimizing Kubernetes for cost on AWS. And Liz maintains the KubeBench tool, which can check Kubernetes deployments against the CIS Kubernetes benchmarks. We were happy to contribute the EKS versions of these tests, of course. Liz is also going to be on our panel here in a bit. And I would recommend her session at KubeCon, where she will be talking about an open source project called Starboard that runs security tools as Kubernetes jobs and makes the results available as Kubernetes native resources, which sounds totally awesome. And what else is happening? There's more. So catch us at KubeCon. There's a bunch of sessions here, some of which I've mentioned, but I want to put a special spotlight on everyone is a cloud engineer now. This is being delivered by Leah and Guinevere. These are engineers that I've known from the early days of the Kubernetes project. I think they were among the first 80s, as they call themselves, if not the first, working on Kubernetes. Quick shout out, Deidre, Yenny, not forgetting you. You were there too. We're also very happy to have an AD alum on the EKS team now. We'd encourage anyone to check out ADA Developers Academy in Seattle and keep an eye out for ADCon, conference put on by alums of the Academy that will be happening in early 2021. The conference mission is to strengthen ADA Developers Academy and advance the careers of people in it. It's an opportunity to learn from the network's collective experience gained since entering the tech industry through talks, panels, workshops, and networking. And of course, don't forget reInvent, which will be entirely free and virtual. Please be sure to attend Andy's keynote for a ton of AWS launches. And if you're interested in containers, you will not be disappointed. We have more great stuff coming soon. And with that, I believe Brent wanted to come back and hit me with some questions, perhaps.
Hey. Sorry, hey. Yeah, we were talking about all kinds of awesome stuff, big reveals for today. And one of the things that I noticed you mentioned was we revealed Carpenter open source, and then we also mentioned putting CDKs into donating it to the CNCF as a sandbox project. And I was wondering, what's the difference, or what does being a sandbox project do for you or for the project?
Yeah, so CDK is going through the process of sandbox entry right now. This is based on customer feedback. Customers really want to see projects like this, open for community feedback. Sandbox is one of the ways customers tell us they like to see this project work. And of course, there are a lot of best practices around kind of community organization that when a project starts down the road towards becoming a community-based project, Sandbox is a great place to start.
Awesome. All right. I think that this is going to be a great day. This was an awesome start, and we're going to continue on after a bit of a break. So let's all take a break, stretch our legs, and then we're going to come back with Micah Hausler, and he's going to talk to us about security. So stay tuned, and we'll be right back.
Today starts making breakfast for the family. Doing my secret toast with an omelette. A solutions architect is like a cloud therapist. You need to earn the customer trust. I'm obsessed with data. We focus on infrastructure challenges so our customer can focus on their business challenges. My name is Yahav Biran, and I'm a solutions architect at AWS.
Our job is very simple: secure, efficient, and then enable the heck out of the hundreds of DevOps teams that we have across T-Mobile. AWS has really played a huge role in our modernizing our infrastructure and ecosystem at T-Mobile.
Today we run like 1 billion requests a day on AWS just on our container workloads. So we have used EFS infrequent access. EFS is, as the name suggests, it's elastic. So it can scale up and scale down per demand. We don't have to worry about pre-provisioning a storage. Teams are non-container based workloads. They have access, as long as you have like appropriate tags, you have access to go ahead and provision EFS solutions for you. If you need any extra help on it, we talk with those application teams to configure EFS solutions. The second aspect of self-service is in the container workloads. We enable application teams to use AWS EFS automatically in a Kubernetes cluster. You would just need to write a few lines of code and use a Kubernetes manifest to just go and provision EFS cluster, and you can use it in the PVCs. Our requirement for FSX was primarily on big data analytics. A lot of these teams use FSX solutions to get the reporting data as quickly as possible. So the real good thing about FSX is like it's fully managed, and the performance is much better compared to our solution what we had. We actually optimized in terms of like 50 to 60% of cost. It was pretty straightforward for us to migrate these solutions into FSX. Many of the things what AWS provides, we just go and just use it because it saves a lot of time, saves a lot of cost in many of the cases, and scalability. And most important is the reliability aspects of it.
We're continuously delivering value to our end customers on a daily basis versus monthly basis. And what that's allowed us to do also is we've been able to go to market in go to market in small markets or with a small subset of our population and do A/B testing for our care and retail applications. And what it's really allowed us to do is get a very broad sample size of what's working and what's not working for our frontline and for our customers, and then to iterate on that and quickly get adjustments and different tweaks out to the market very quickly. So a lot of that has been enabled with our kind of cloud native transformation, and a lot of that work is obviously running within AWS as well.
Okay, welcome back. So joining us now is Micah Hausler, and he's going to talk about EKS security best practices. So welcome, Micah. Take it away.
Thanks, guys. Thanks, Bob, for the intro too. As I said, my name is Micah Hausler. I'm a software engineer on the EKS team. I also participate in the Kubernetes community in several of the special interest groups, the SIGs, as well as the Kubernetes Product Security Committee. So I'm involved in a bit of security on the Kubernetes side, as well as the AWS and EKS side. I want to start today. The talk here is about securing your containers on Amazon EKS. And as we start, I want to start with just a question, kind of a seemingly simple question. How are your containers secured? And so
I
yeah,
put them in ECR. I think no one can get to them there.
Yeah, no, that's great. So yeah, I think a lot of people may think of exactly ECR, image scanning, think about maybe, kernel audit log monitoring, things like pod security policies, maybe, Gatekeeper or Open Policy Agent, OPA. You might be thinking about your secure build process, having an audit trail, everything from a Git commit to the CloudTrail logs for the AWS calls to push out your code. And these are all totally part of securing your containers and part of your overall strategy. I want to dig in a little bit into some of the practical things you could do. And then we can kind of zoom out and get a wider picture. So this may be a little bit familiar. If you've been around AWS at all, if you've heard AWS security talks, you've probably heard about this AWS shared security responsibility model. And you can kind of see that there's a lot of parts to this, but there's two big sections we can kind of divide this into. And the headline here is kind of on the left. AWS is responsible for the security of the cloud. And you, the customer, are responsible for the security in the cloud. Your responsibilities for things like, you as the customer, for things like configuring your AWS security groups for network access control, or your AWS IAM roles or access keys for IAM users, that they have permissions scoped appropriately, or for your data that's backed up and encrypted with something like AWS KMS. And AWS's responsibility here is for the security of the cloud. So we maintain the systems that power the services that you use every day to run your mission critical business infrastructure. As Bob pointed out last time, we have tons of customers that use, he had their logos up, that use EKS, and they trust us to have a secure environment for not just Kubernetes, but all of their AWS usage. So we maintain the compliance, the physical security, the hardening of our software and hardware that power the cloud. And so the next kind of natural question is, how do you define the cloud? And while that's kind of a interesting question, I think, because there's so many parts to it. We're all here for Container Day, so let's talk about Kubernetes. what is Kubernetes as in the cloud? Kubernetes, as we know, is an open source project, right? It's open source software. So whose responsibility is it there? I think we can largely divide Kubernetes into two pieces. If you get into Kubernetes and you start reading the documentation, you'll hear about the Kubernetes control plane, the Kubernetes data plane. And the Kubernetes control plane is made up of things like the Kubernetes API server, Kubernetes scheduler, some other components like a control loop, a controller manager. With Amazon EKS, the Kubernetes control plane is managed for you. We are responsible and we take care of patching for CVEs, keeping the images up to date, the scaling, the management of the Kubernetes database, etcd. As Bob pointed out, it's one of the things we help maintain upstream. Just even things that seem sort of boring, like API server certificate rotation. Like, who likes doing cert rotations? That's just something you don't even have to think about. You just get an endpoint for Kubernetes and you get to use it. And then with Amazon EKS, the data plane is EC2 instances in your account. So like that shared security model that we referenced, you're responsible for the packages on your system, the access to the security groups, the SSH keys that you distribute to those systems. With Amazon EKS, the data plane is made up of those EC2 instances in your account, and you're responsible for making sure that those instances are up to date. Now, we help you with that with certain things like EKS managed node groups. But the actual instances and the contents of that are in your account and they're up to you. So we can kind of draw this line in the middle and say, for the purposes, especially here, that the Kubernetes control plane is you're handing off to AWS as secure. Another question I want to ask: how is Kubernetes kept secure? We're talking about the security of the cloud. Let's face it, like, Kubernetes is a complex piece of software. It has a lot of moving pieces. It's a fast-moving project. There's releases every 3 months. Minor releases that have large feature changes that can deprecate things you may be relying on. There is an exciting project to be a part of, but it's complex and it moves fast. So how is Kubernetes kept secure? I'll also say that EKS is because EKS has managed Kubernetes, the security of Kubernetes is very important to us because it's important to our customers. We care a lot about customer data. It's something that we talk a lot about and that we design around and that we think about. I think a short answer to this question is that security of Kubernetes is a community effort. The answer to this actual question of how it's kept secure includes lots of parts that we don't have time to talk about or even mention here. So I don't want to do a disservice to everyone by trying to list everything and say that I have a complete list. But
it's complicated.
It is complicated. It's very complicated. I can say that working on it full time with other people, even coordinating with people from other companies, it's very complicated. There are almost 3,000 contributors to just core Kubernetes, and many, many more throughout the ecosystem when you include things that are Kubernetes CNCF projects, as well as now other projects that have graduated into their own, like Helm, or the ecosystem that's sprung up around Kubernetes, like CDKs. You get people from all kinds of backgrounds, whether they're users, they're operators, contributors to different components of Kubernetes. That a lot of people who originally came into Kubernetes came in through the kind of the DevOps route. That was my background, having experience setting up, trying to, initially clicking through the AWS console, creating EC2 instances, and then writing bash scripts. And, for a lot of people that involve graduating to things like configuration management systems like Puppet, Chef, Ansible, Salt, those kind of things. And when people, especially in the DevOps world, came to Kubernetes and saw, okay, this solves the problems that I have, and that's why it's magical. It's not an overly, not just a complex piece of software that has a ton of bells and whistles. It's actually solving the problems that I have. So without those many people, Kubernetes Kubernetes wouldn't be kept secure. And part of that is these people have formed special interest groups. It's what we call SIGs in Kubernetes. These are SIGs meet regularly, typically a couple times a month. All the SIG meetings are open. You can attend them. They're just typically Zoom links and Zoom meetings, and have an open agenda, have an open mailing list. You can participate, read, see the GitHub issues. SIGs are responsible for the code that goes into Kubernetes. They're the code owners of certain portions. So that might be something like SIG networking, SIG storage, you think about, or SIG nodes. Another one is SIG auth. The code owners in SIGs are responsible for reviewing the code, for approving the merge of the code. And then there's other SIGs that may not have code ownership, but one of the newest SIGs is SIG security. This one, if you're interested in security, I highly encourage you to get involved. There's a GitHub link here, but you can just do a web search for SIG security in Kubernetes. This SIG, while not owning code, is going to be responsible for things like security documentation, better defining the security release process. So we'll talk about that in a second. It's kind of going to be a front door for folks in the security community or other newcomers who are interested in security to get involved in Kubernetes. And one of the other things that it's responsible for is overseeing a recurring third-party security audit of Kubernetes code. There was one that occurred in the last year and produced a ton of really great findings and really hardened Kubernetes in a great way. That's something that the Kubernetes community wants to continue. I think that that's really important for the continued security of Kubernetes. So if that's all interesting to you, please come to SIG Security. It's a great place and a great place to get involved. And then one of the other mechanisms that Kubernetes has to help maintain security of Kubernetes is the Product Security Committee. So similar to SIGs, the Product Security Committee is made up of maintainers that are responsible for helping when things go wrong in a large part. So let's talk about that a little more. As Bob mentioned, I'm a member of the Kubernetes Product Security Committee, or the PSC, and we have a number of different roles. It's not all, it sounds kind of glamorous, but it's honestly just a lot of trying to help fix things when things have gone wrong, and gather people together to say, let's do this. One of the first things that we do, and one of the largest parts of the work we have, is just triaging incoming reports. So if you find or someone finds a security issue, or what they think is a security issue in Kubernetes, the Product Security Committee is where those reports go. So you'll see, you may have heard in January of this year, we launched a Kubernetes bug bounty program on the HackerOne platform. And that's been actually really successful. It's a place where you can come and report issues in Kubernetes and get paid for it. It's been a great experience so far. We've the Product Security Committee, with funding from the CNCF, have already paid out over $18,000 to hackers for findings in Kubernetes. On the HackerOne page here, you can see kind of what's in scope, and it's not just what you might think of as upstream Kubernetes, the GitHub Kubernetes. It's also the CI infrastructure around Kubernetes that needs to be secure. The Kubernetes build process, the release process, making sure people aren't sneaking in code that they shouldn't be past, SIG leads and approvers. Other things like Kubernetes projects that are not core Kubernetes, but things like add-ons that are commonly used in Kubernetes. So you can see a full list of what the scope is there. And then one of the other ways that folks report issues to us is the security mailbox for Kubernetes. If you don't want a bounty or find an issue that maybe isn't covered by the bounty program, like this is a way that you can report the issue. You can still report it through the HackerOne program, but this has been the historic way that we've had reports come into us. It's not an email for if you have security questions about Kubernetes, but if you have an issue, a thing that you have found that might be a security issue in Kubernetes, please send it anyway. We're not going to get upset about that. When we do have a real issue, one of the other things that we help with is coordinating fix teams. So finding who are the code owners, what's broken, who are the owners of that code, whether that's a specific project under Kubernetes or a part of Kubernetes because it's such a big code base with so many moving parts and pieces. Who does that involve? And then also working with the fix teams to get a release out, assessing, how significant is this issue? How severe is it? Getting that tested and released. So when appropriate, we'll also have a more complex part of the process, which is to coordinate these fixes under embargo with organizations that distribute Kubernetes. So you can go look at our the Kubernetes security GitHub. It's just github.com Kubernetes/security. And you can see who the organizations are that are the distributors. These are companies that you're probably thinking of, like AWS, Red Hat, Google, etc., that distribute Kubernetes either commercially or organizations that have a non-commercial offering even. And so this is what helps those organizations secure Kubernetes. So if there is, say, an issue in a part of the managed control plane, not just in AWS, but in the managed control plane for all different kind of distributors, that's something that might we might send to distributors to have rolled out before it's made public, so that everyone who has a managed Kubernetes is patched before the issue's announced. And then one of the last part, yeah, go ahead.
Sorry, I just I had a thought. I was wondering, I've been on committees before, and I'm wondering, you mentioned all of these people that are participating, all of these reasonably large sounding organizations that are playing into this. What's it like? How do things actually get done? Because that just seems like it would grind, and there would be a lot of debate and sort of wrestling over position and that kind of thing. So, but it sounds like you guys actually do get a lot of stuff done. So what's the experience like?
It's in some ways, it's very good. I think you're right that there can be, especially when most of the time when I'm working on the product security committee, and same for the other members of the product security committee, we're not working with other members necessarily of our organization. We're working with colleagues from all around the world, from different organizations, and that's very similar in some ways to just regular open source, right? And if you've participated in regular open source, you're probably familiar with just the reality that things don't often move fast. There's not someone's boss you can go tell them to go do it faster. You can't escalate internally some business reason to move something along. And so that's also true in Kubernetes. So in some ways that can be not a bad thing, but just be a taxing thing to say, okay, we actually have to move this forward. this is a real issue. And for the most part, though, folks really do respond well. Like when there is an issue, people treat it seriously. They take it. They understand that things have to be done timely, and we get those out. But for the most part, it's really rewarding just to know that, I played a small part in keeping not just, my own team or my own system secure, but I helped in a sense help secure the internet, right? Like Kubernetes at this point is that pervasive that's not like a huge exaggeration to say.
That's awesome. So I've seen a couple of comments roll through specifically about Rocket, but more broadly, I'm just curious. I know this isn't necessarily about the control plane and security, but I hear questions a lot of times, should I be using the Docker daemon? Should I be using Containerd? What runtime engine should I be using? And it's often the impetus is I want to be secure, right? So are there, just like you have the bug bounty and SIG security for the securing Kubernetes, does that include runtime things, or are there separate projects to handle security of the runtime?
No, that's a great question. I think there's a couple different parts to that. Kind of the operator part, like what do I use? And that question is largely dependent on a lot of the things that are relevant to you. Do you want to use the more bleeding edge tech, or are you interested in something that's boring and stable? And those are, come down to, in some sense, business and technical questions that you can answer for yourself organizationally. You can do research to find out what is supported, what is my vendor support, here, what is AWS support, what do they recommend? But then on the security side of the product security committee specifically and the Kubernetes community, if you go to the HackerOne page, there's actually a really great breakdown of the scope. And we actually list out if there's an issue that you find in something like Containerd, the runtime engine, or Docker. Please go report that to Docker or the Containerd project. While Kubernetes does heavily rely on the container runtime, that you can't have Kubernetes really without that, right? If there's not an interplay necessarily with the Kubernetes aspect of that, we would treat that as that's a separate issue in a separate project. Same for other components that you need to run a Kubernetes cluster. Core DNS. If there was a DNS issue, that please go report that there. We are on, they have their own security procedure and their own security distributor list, also which AWS is a part of for things like Core DNS. And so if there's an issue there, they will push that out, and the folks that actually distribute something like Core DNS can notify their distributors. And then the same for anything else like etcd or whatnot.
Cool. Awesome. I'm sorry to interrupt. I just had that thought and it seemed like a good time to ask. So
yeah, no, that's a great question.
Cool.
Yep. So the sort of the final aspect to all this on the product security committee is this last part of just issuing public messaging. So once something is ready to be made public, whether that's an embargoed fix that distributors have worked and coordinated together to get rolled out, or maybe it's a more medium or low issue that you kind of that assumes some higher level of privilege or something, that we can just push out publicly and people can pick up the fix as they deem necessary. We write the guidance to say, here's the issue, here's the summary. Are you affected? Here's the version to know if you are. Here's the version to update to. And so that's one of the other portions that the product security committee is responsible for, and that actually SIG security is going to start helping with in terms of the messaging around issues once they are public.
Awesome.
I kind of want to talk about a little bit of a story here. This kind of gives an example of this process that we've talked about. It starts with a seemingly innocuous command, kubectl cp. Brent or Adam, have you guys ever used this before? Do you know about this?
Actually, I don't think I have. I have guesses as to what it's going to do, but I've never found myself using it or even thinking to use it.
Yeah, this is what so I've been using Kubernetes for almost 5 years now, and this is something I wasn't aware of till in the last year or two, just because I had never needed to use it and I didn't know it was around. But kubectl cp, it probably does what you think it does. It's kind of like SCP, but for Kubernetes. So if I wanted to, if I had a WordPress app and I wanted to inspect a debug log and copy it to my workstation to look at, I could run something like this: kubectl cp, my pod name, path to the file, and then the directory I want to copy it to. Say that now there's a little bit of a story here, but just say that I notice some unusual activity in one of my WordPress applications, like it's behaving slowly, the file assets that users are getting aren't exactly what I expected. The version seems off. Maybe it's an old version of some JavaScript library. So I can't, I thought, looked, all my application images are the same image, so it shouldn't be differences in library. What's going on? Let's get the debug log out. So, as a conscientious developer, I make a debug directory in my home directory, right? I'm not going to put anything in just my home directory. So I go to that directory, I run my kubectl cp, but what I didn't realize was that kubectl cp is effectively running something you may have heard of, kubectl exec. Kubectl exec is like Docker exec. It's kind of like shelling into a pod, right? Except kubectl cp, when you run exec, effectively runs tar in the container. So it uses the container's copy of tar to create a archive of some file or directory, streams that output over the exec channel, and untars it in my workstation with using kubectl. It doesn't use my local tar. This has interesting security implications. What's the problem here? Well, you may have heard of the CVE, probably don't know the name, but last year in March, this was announced publicly. If the tar binary in the container is malicious, it can run code and output unexpected malicious results. So in this example, an attacker could use this to write files to any path on the user's machine when kubectl cp is called, limited only by the file system permissions of the local user. So in other words, if the container is compromised, say it's a some application that is out of date, has something wrong, there's a bug, and someone's able to execute code in this container, they can overwrite tar, and this tar binary could then be tampered with. kubectl would then exec over this channel the tar binary and give me back tar output that's not exactly what I'm expecting. And you kind of think, okay, that seems kind of far-fetched, right? Like it can't be that easy to make a bad tar that doesn't break everything horribly, right? Right? Like I've talked to people that say that. Turns out it's actually pretty easy. Like this is just a few lines of Go code that will stream out a tar file, a simulated tar file. And in this example, it would overwrite your .profile in your, say, if you're doing this one level above your home directory, it would try to unpack a file into your .profile so that every time you executed a new terminal window, that file would get executed.
Wow.
And
Wow.
in this example, it's doing something that's not scary, but telling you you've been popped and here's a bell. But you can imagine that this gets a whole lot scarier, especially if it's arbitrary locations on disk, right? So that's kind of like, well, it seems, kubectl CP, no one's ever heard of that. Like Brent's never heard of it, and he's like a Kubernetes guru. Like, is that really that big of an issue? Yeah, it's an issue. It's an issue. So how hard can it be to fix that? Turns out it's pretty hard. The previous issue was March 2019, and again, another, we've had really great people who've reported these issues, and you can go look at the pull request and the Kubernetes security announced mailer about this. The details were very similar. The original fix was incomplete, and so you think, enough people are looking at this that it's probably good, right? Like, turns out it's not. Again, as in part of AWS, as part of our looking into this issue, one of our developers, Yang, found that it's not exactly complete. Like, there's TAR and file systems and recursive file systems it's tricky to get this stuff right. And this is not, I'm not shaming anyone. I'm actually saying this is hard to get right. Like, I helped review Yang's code, and after he found this issue, to say, okay, do we think that this is good enough? And turns out there was yet another one. I don't have the CVE listed here, but there was another one last year that was another edge case. So that, security is not saying it's people who are incompetent. I'm saying it's really difficult stuff. But in these cases, while it seems like things went wrong, right? Like the fix was incomplete. I would also say that the process went right. A lot of people had their eyes on this and started finding more stuff. Like, that's a good thing. It's better than if not enough people reviewed it and there were no more bugs found, because there are obviously at least 3 more bugs found from the original issue, right? Like, if there weren't people looking at this, that'd be a problem. So to me, this is good. This is a good thing that people are finding this while it seems like it's bad. So kind of coming back to our original question, how are your containers secured? And I think we've answered that a little bit with kind of what's the process around securing Kubernetes. So what I want to talk about for just the next few minutes are kind of what are some of the practical things you can do on your side of the shared responsibility model. Well, we said, the security of Kubernetes, security of the cloud is responsibility of AWS. We help, when there's issues that are found, we help validate them and even help contribute fixes to them. But when you're using Kubernetes, what are some of the practical things you can do? And so I don't want to, there's a ton of things you can do, right? Like, Kubernetes, as we said before, is a complex system. There's lots of moving parts to it. The practical things you can do, I just want to hit a few highlights. To me, if I have a few precious minutes with you, here's what I want to tell you. First of all, when you use the EC2 instance metadata service, shorthand IMDS, the cloud information service on your EC2 instances, 169.254 or 169.254. Turn on version 2 and disable version 1. There's a little bit of work in this for you probably, because a lot of older applications might not have V2, but at this point, a lot of applications have been updated to use V2 with the updated Amazon SDK for whatever language the application's built in. And turn on V2 and turn off V1.
Yeah, and let's just try and clarify. V2's been out for quite a while now. I can't remember how long, but at least
it's been over a
year plus. Yeah.
Yep.
And SDKs have been updated to use it. So if you do run into problems like that with, because of using an old SDK, it's worth the effort to get it updated. So definitely stop what you're doing, spend the time, get moved into the new SDK, because you're only hurting yourself by leaving V1 enabled. Can you tell us, like, basically what's the difference in V1 and V2?
V1 is kind of what, if you've used AWS for any amount of time, longer than a year, you're probably very familiar with. It's basically a simple HTTP server that your applications on your instance can access for things like metadata, like what, in the name, metadata service, what availability zone am I in? What is my EC2 instance ID? One of the other things that is very commonly used is passing temporary credentials down to the instance. So if you launch an EC2 instance, you select an IAM instance profile role, and that's how the instance gets rotating automatic temporary credentials. And those credentials have some IAM permission that you've granted for that instance. So V1, simple, effective HTTP web server. V2 introduces a lot of new hardening techniques that help with certain different class of attacks on applications, like server-side request forgery. So tricking your application server, whether that's whatever the application is. It could even be Kubernetes, right? Kubernetes has had SSRF vulnerabilities in the past. Make a request to the instance metadata server and return it back to the user of the server. IMDS v2 has mitigations for that. Instead of just a simple request response like normal HTTP, you have to go get a header from one endpoint and then use that header for successive calls to other endpoints. So simple reflection type SSRF is largely mitigated with that. There's a bunch of other, you can read up on the docs on this, but there's a bunch of other things that it adds, like there's a hop count limit on how many hops the server will add to the TTL on the response. So if you were on some VPN bridged connection to an EC, say you were running some open VPN or something on your EC2 instance, and a user could get to the IMDS over the VPN. If you have IMDS v2 enabled, the hop count would turn the reply packet of the server, if you made a request to the server, would get dropped because the TTL was set to 1. It would get propagated to the VPN server and then get dropped, and it would never make it to the client. So things like that would be really helpful. They are really helpful for countermeasures for those class of attacks. The second, the second thing that I would say about this is, when you're running containers, don't give them, or as sparingly as you can, access to host level services, primarily including host network. The other thing that this IMDS v2 helps with is, if you have containers that are running in the bridged network, even if it's using AWS VPC CNI, that using IMDS v2 with a hop count of 1 prevents containers from accessing IMDS, and that's actually a really good thing. When you give the container host network access, there's no longer any additional hops, and it has access to your IMDS creds. And the reason why you don't want that is, in AWS, instance metadata credentials are let an application prove that it is that instance, or it is operating as that instance. And so in things like Kubernetes, that means you are more privileged than just a container. So turn off host level access to your containers. That includes not just host network, but host process space. There's a privilege flag on Kubernetes pods. Like, don't give that unless you know you need it. It's not a shortcut to say, oh, I can do special things. Well, it is a shortcut to say, oh, I can do special things, but don't give that out. One of the other things I want to impart is use IAM roles for service accounts to give pods AWS access, as opposed to the instance metadata service. This is the alternative that lets you distribute roles to Kubernetes pods. this has been out for like INDS longer than a year now. It's supported in almost all SDKs it is supported in all SDKs and is present in almost all the modern applications that you're going to use. And if you're writing your own applications that interact with the AWS SDK, go and turn it on and use it. Highly recommend it. One of the other things the top hit list here is turn on the Kubernetes audit logs for your Amazon EKS clusters. This enables the things like you can enable the Kubernetes API audit log, the control plane server logs to go to CloudWatch logs in your account. One of the things that I really, really like about this is it works really well with CloudWatch log insights. So if the Kubernetes audit logs are structured JSON. So if I need to query for, I'm trying to get into my Kubernetes cluster, but I'm getting a 403, my RBAC must be messed up. What user am I authenticating as? What does Kubernetes think I am? Any of those kind of questions can be solved very, very easily with a CloudWatch log insights query against your Kubernetes cluster logs, log group and log streams.
If you're not familiar out there in the audience, by it being structured JSON, you end up with really nice key value pairs where you can search based on key looking for something in the value section and really hone in on exactly what you're looking for.
That's exactly
and
right.
I just wanted to add, using CloudWatch logs insights, this kind of avoids that extra step of having to have some sort of cache cluster to maintain all your logs. It's fully managed, easy to use. So that's a cool reference.
For sure.
Yep, that's exactly right. And then the last thing I would say is you're using a managed Kubernetes service, so leverage it. Use things like managed node groups or EKS Fargate, and also keep your clusters up to date. Like if you love Kubernetes and you were using it, say even you were managing your own clusters before, like the pain of managing a cluster and upgrading it when you own the whole thing. EKS takes the pain of upgrading a cluster and makes it an API call. So like use that. Like keep your cluster up to date. Use the latest version, because while we do maintain the security of Kubernetes and of the versions of Kubernetes, and we backport Kubernetes security fixes, keeping it up to date will help you get access to the latest and greatest features. So that's my hit list of here's the things you definitely should do.
That's a good list. And I'm actually glad that you have this slide, because seriously, I was going to ask, okay, you're the security expert. How do you build an EKS cluster? What are the things that you make sure to do for your Kubernetes cluster? So perfect.
Great. So other resources besides the things mentioned here are just, I would say the EKS docs are great. Like the user guide is really helpful especially if you're new to Kubernetes, but also if you're kind of used to Kubernetes, but you're wanting to understand what are the things AWS provides with EKS. The user guide gives you a great overview of kind of all the security measures you can implement, all the things you can do. And then there's also the EKS best practices guide for security. It's on a GitHub page, and it has a lot more of these practical kinds of things that you can do on your cluster. Things like how do you use pod security policies? What kind of IAM permissions should you put on certain Kubernetes components that run in your cluster? How do you keep your cluster up to date? Those kind of things. Go look at the security best practices guide. It's really helpful, and I highly recommend it.
Awesome. Well, thank you, Micah, for joining. I love the insight on security. I know that is super important to everyone. It's super important to us. It's super important to our customers. Everyone is always, thinking about security. And so seeing like how complex it can be. You know, I mean, Kubernetes is a complex topic, and just one piece of it, security, is in and of itself a super complex topic. So I love seeing some of the background and how it all works. And definitely the advice for how to build a Kubernetes cluster and what are some easy things to do for it and make sure that you have turned on is super useful. So we're gonna take another quick break, about 2 minutes or so, and when we come back, we're gonna have Nate Tabor with us, and he's gonna talk to us about the EKS roadmap and sort of the vision for the future.
Ooh.
Yeah. So that was weird. Sorry. So don't go away. We'll be right back.
I really like to start my morning going outside on the patio. The morning standard meetings very important for me because I can know what the team is doing. I think my job is mainly creating an effective team to deliver the most value to customers. I really like when I see my reports growing on their career and also when people are excited about the work that they deliver. We have sister teams also in Cupertino, Seattle, and San Francisco. AWS managed to get everybody on the same page, regardless of which team you are. End of day, learning how to play the guitar. That's one of the biggest challenges outside of my work. I'm Helbert Maish, a software development manager at AWS in Vancouver, British Columbia.
Today, more and more people are running their workloads in containers for better resource efficiency, workload portability, and flexibility. That's why AWS created BottleRocket, a Linux-based operating system that is purpose-built to run containers. BottleRocket updates in a single step, and updates can be rolled back if necessary, giving you fewer error rates for OS updates and increased uptime for containerized applications compared to general-purpose operating systems, which update package by package. You can easily automate updates to your operating system by using container orchestration services such as Amazon EKS, helping to reduce your management overhead and ultimately cutting down on your operational costs. And because BottleRocket includes only the essential components needed to run containers, it effectively boosts resource utilization and lowers security risks. By leveraging BottleRocket's open source development model, you can make your own code changes and produce custom builds that support your preferred orchestrators and build tools. You can also submit your changes for inclusion to the AWS BottleRocket builds. AWS provided builds come with 3 years of support, giving you a single point of contact for all your infrastructure support needs, including operating system support. Build with confidence and optimize your container infrastructure today using BottleRocket.
Okay.
All right. Wow. This is working.
And I think it's working well. And by the way, nice sweaters, everyone. Good to see we're all on the same page
Thank
here.
you. Thank you. Yeah. I got the memo just in time.
Me too. Actually, I got my sweater just in time. It was like last night, late at night, it arrived. So I'm so glad. So welcome, Nate.
Hey, thanks, guys.
Really looking forward to, talking about the roadmap, what's ahead. Micah kind of really drove it home on, today, how to make things great today and secure today. Yeah. And now we're going to look ahead. So looking forward to that. Yeah,
exactly. We got a lot to talk about. And I think it always astounds me just how much the EKS team does and is working on. And so we have a lot to get through. I may rush through some of this stuff, but I want to remind people at the start, we have a public roadmap on GitHub. And I'll give a slide on that, a quick link to that. But, most of this stuff, not all of it, but a lot of this stuff is there. We also love getting feedback there. So, this is our vision. I'll caveat, I would say there's no timelines here, right? Like some of this stuff we're going to get to sooner, some of this stuff we're going to get to later. And, your input, customer input on what's really important is super critical. Like that's how we decide. So let me actually just get started here. I want to rehash a few things. Bob did a great job with the keynote this morning, and I just want to re-emphasize this slide that he had up, which is how do we build EKS? What are like the top principles that we're thinking about? And I love that we kicked off today with security, because security always comes first for us. Production, this is a production service. We build this to run your mission critical applications. Kubernetes EKS is native and upstream. We want you to be able to bring anything from around the community and run it on EKS. And that's really why we're here, is for that flexibility and the portability that the ecosystem gives to us. And then seamless integrations. You are running with EKS, we're running on the AWS cloud, right? So what we run on EKS should work with AWS really, really well. And we'll talk about a few of those projects. And then, of course, we're committed to open source. This is the lifeblood. This is, it's not just how we make it possible for people to consume what we're doing, but it's also how we contribute to the community. It allows us to effectively be a little bit bigger than ourselves as a team. And we have the EKS team, we have the AWS team, and then we have this, this global team of contributors, which is why we're all here at KubeCon. And so this is really, really exciting for us. And in part because of all the great work that's been going on the EKS team in the last few years, we're really excited to kind of count, customers from all over the world, customers from almost every single industry to be using EKS and to be a part of this journey with us, and to be using EKS to deliver some amazing experiences. And I wish I just had time to talk through all the awesome things that each of these companies is doing, but suffice to say, and I know we have a few people coming up later to talk about some of this stuff later on today and throughout the week at KubeCon, but it is amazing to work really hard on a product and work with some amazing product managers and engineers and security folks and all the other people that we work with at AWS and in the community, and then to kind of put your head up from the desk and just see how impactful what you're building is. And I think for me, that's what keeps me going every day, and that's what makes me really excited to be here. And so, in case I didn't say it earlier, and in case Micah's talk didn't make it clear enough, security is really job zero for us, right? Like this is what we do first and foremost. We drop everything if we can't make sure that things are secure and reliable. And I don't think I can say it enough. So I know Micah talked a lot about security, and I wanted to talk a little bit about reliability. There's a lot of things that go into making EKS reliable, and probably as much. We could probably spend at least as much time as Micah spent on security talking about reliability, but I want to actually just kind of really quickly show this diagram of an EKS cluster. This is effectively what part of what gives a really high reliability. The fact that every EKS control plane, that's the part that makes the decisions on the Kubernetes cluster. So if you're familiar with this inner workings of Kubernetes, there's the places where all your applications run. And then there's the sort of the brains of the system is this control plane. And that's one of the core things that EKS provides, right, is that managed control plane. And we run this control plane in a rather unique fashion. We run this across 3 AWS availability zones, which means 3 separate, not just separate data centers within AWS, but actually separate, fully isolated, kind of like mini regions, sub-regions within AWS. And these AZs, sometimes these availability zones are made up of multiple data centers actually that work together. And then multiple AZs form an AWS region. And so we actually run the control plane across 3 of those at any given time. We have the etcd persistence layer. This is the project that we're really excited to announce is heading towards graduation, and some folks on our team have been core maintainers and contributors to that project. This actually is effectively the memory of the Kubernetes cluster. And then you have the API servers. These run at least 2 across 2 different availability zones. This is the brains. This is the computing part of the control plane, right? And this is the Kubernetes API server. If you say kubectl, get services, this is what processes the request and pulls the data out of etcd or stores the data in etcd. And so we run this across multiple availability zones in separate isolated compute. There's a whole bunch more I could get into, and we don't we don't necessarily. I want to talk a little bit about the vision too, but I just wanted to really make sure that we we looked at, a lot of the innovation is under the hood on EKS. And I don't have the chance to really talk about a little bit of this I'll talk about today, but there's so much innovation under the hood, and it's hard to see if you just hit the API. It just works, right? It's magical. But the team spends a lot of time getting this right, not just on the security side, but also on the operations side and the reliability side. Some of the things we will talk a little bit about today is actually what you see in your VPC. That's this section at the bottom, the customer VPC or virtual private cloud. This is the isolated networking environment where you run your applications as a customer. And so what we do is we run the EKS control plane in our VPC in a fully managed network, isolated network environment. And then we connect you to that using this network load balancer. And we have some other networking connections that we do. And then you have a few options for running with Kubernetes. You can run your managed node groups, which is EKS handles the virtual machine lifecycle, starting virtual machines and stopping virtual machines and updating them. Or you can run with Fargate. Fargate is a fully managed compute environment. And so we'll talk about a few of these things as we go forward and different innovations that we're working on to help it make it even easier for you to run compute on your clusters. So one of the things that this architecture gives us, the fact that we split things out, what that means is that, let's say, and this is rarely, if ever happens, I don't know if it's ever happened, let's say like an entire part of an AWS region goes down, like the whole, like catastrophic failure. I can't even speculate on the cause, but like catastrophic failure. Because we're running across these multiple, not just physical, but geographic areas, and it's all networked together, what that means is that if any part of that system fails, the whole system doesn't fail. And so we have really high reliability from that architecture, right? And so that lets us offer customers a very high level of service. And so we have a 99.95% service level agreement. This is a monthly SLA. And that means that the Kubernetes API server, the managed control plane that we're running, is available at least 99.95% of the time. It's not a goal, it's not a best effort, it's an agreement. If we fail to maintain this, there's monetary compensation that we give to our customers. And this is enabled by the security, the operations, and the architecture that the team, including folks like Micah, work on every single day. So that's incredibly important to us, and we express the work we put into this through the SLA. All right, so that's kind of a primer. I thought it'd be nice at the start of the day to kind of like, talk a little bit about what EKS is and Kubernetes. So let's talk a little bit about our vision. I'll try to connect the dots here. What we're seeing and what matters to us. So this is the world that we face, right? Like, there's so much to do if you're a developer, if you're in operations, getting your stuff out to production. Writing code is like step one. And then there's so much else, right, that happens. Like you have like defined provisioning, documentation, portability, utilization. It's like enough. Like this is so much manual work. This is so much stuff that I have to worry about as a developer or as an engineer. And our goal is to kind of give you this feeling, this fluffy cloud feeling. The reason that we all came, to the cloud in the first place, this sense of calm. And we believe that life with EKS should be calm, and that life with EKS should spark joy. Like using this tool, like we came to these tools, we adopted these tools. I think Micah and Bob were talking about this. We adopted these tools because they really make life easier. They really make life joyful, and they make what we're doing, they make it easier for us to get the stuff that we're building out into the hands of customers, out into the world. And this is really what we're doing with EKS. We want to make it easy for you to get stuff out into the world. And so I put this is a slide that we don't often show a lot. We talk about this philosophically, but we don't necessarily show it a lot. And what this is the ops versus development. And this is sort of I like to call this the conjoined triangles of success, but that's really not what it is. But what this is that if you have a high development maturity, like if your organization is really, really good at writing code, and you can write code really quickly and get stuff ready to ship really, really quickly, but you have low operations maturity, meaning you don't have a good tools to test that code. Even if your developers are great at writing tests, you don't have good tools to test that code, to validate that code, to get that code into production, to merge that code in, to actually host that code reliably. You're in the danger zone, because what's going to happen is you have a lot of developers. You've developed, maybe not a lot, but you have developers in your team shipping code every single day, moving really, really, really fast. And you're not able to actually get that code out. So there's these backlogs, right? These backlogs of code happen. And everyone knows what that happens in an organization is that you start actually missing deadlines. As a developer, I would be extremely demotivated if I couldn't get code out the door, right? I mean, this is where DevOps comes from, is that I'm writing, and I just can't get that out. And it's so frustrating. I just want to like throw my computer against the wall. On the flip side, if you have really high operational maturity and you can take something from code to completion to production really, really quickly, you can stay ahead of the developers. You can make sure that your app is available, and that's motivating. That's motivating as a team, because as soon as something's written, it can be deployed and merged and out into the world really quickly. This is continuous integration and continuous deployment, right? And so what Kubernetes is it's not really a dev system, right? Kubernetes is an ops system. Kubernetes helps you go up that maturity level on ops to stay into the green zone so that you can go faster. And that's really what the goal is here. That's really what we're getting at. And so we think that Calm helps you implement fast. Calm is fast. And that's really the whole the philosophy that we have behind EKS is how do we help you go really fast? How do we get into that? And so all of these things, these standardized interfaces, these on-demand compute, scalable operations, smart automations, simple setups, all the things that we're working on with EKS, these are things that we believe spark joy within your teams. So, EKS, there's all these things that you have to do, right? Like we talked about all the things that are really frustrating and that people have to set up this, going from the application, working the console, having a platform, setting up your tooling, actually having good operational processes, a standardized API, provisioning compute, working in different clouds. These are all the different areas where EKS is working. These are all the different areas that we are, maturing right now. And so, EKS, yes, it's a managed Kubernetes service, but our vision for EKS is that EKS is a hub for Kubernetes. And EKS is a place where you go to operationalize and run your applications in production. Okay, so let's talk a little bit about how we plan to help you spark joy in your life. And I have to say, I'm shamelessly inspired by Marie Kondo here. And I think one of our fellow team members, Nathan Peck, has a great Twitter post about, how do you tidy up your AWS account in the steps of Marie Kondo and the Kondo Marie method. And so these are the steps to spark joy in your operations and development life, and things that we're doing that we hope will spark joy. Like I said, some of these things are things we're working on now. Some of these things are things we'll be, talking about and releasing in the near future. And some of these things will be a little bit farther out. I'm not going to tell you which, but we'd love for your guys' input, either in the chat or also, of course, on our GitHub project, to tell us, what really matters to you. And so the first step that we think is really critical to spark joy is to gather. So the first step here is to gather. This is the first step. If anyone has read Marie Kondo, this is the first step you do, is you gather. And so what you want to do is you want to gather all your clusters together. And how are we going to help you gather all your clusters together? So we're going to put all your clusters in one place with a unified EKS Kubernetes console, and allow you to see those clusters across teams, accounts, and environments. And then also help you unify all that supporting infrastructure that's run on AWS, all your EC2 instances, all your EBS volumes, things that are everywhere. Basically give you that hub for Kubernetes, allow you to see all the applications, all the clusters, all the middleware, and then also all the infrastructure that's supporting it. The other thing is we want to give you simple workflows as you're gathering this stuff. So EKS add-ons, the ability to start operational software with the cluster, to update that software with the cluster, giving you one-click cluster setup and delete. Our goal here is you should be able to come to EKS and get a cluster that's ready to run applications in a single step or a single Terraform or CloudFormation template. We want to give you a lot more mutability on the cluster. So we strongly believe in immutable cluster management, but sometimes mutability helps you get unstuck from things. And so things like mutable security groups and subnets are really high on our priority list right now. And then talking about gathering clusters together, this multi-cluster management tooling. How can I take actions or implement policies across lots of clusters at the same time? How can I manage multiple things in a single unified way and deploy globally? So now that we've gathered everything together, right, we need to review them. So we're going to review our posture, and there's our security posture and our operational posture, right? And so we said security is critical, and security is built into every single cluster. This is not just something that we do; it's also something that we actively work on, right? So security built into every cluster is both a reality and a practice for us. And so some of the things that we're working on to improve the security that's built into every cluster are these IAM to RBAC access controls, making it easier for you to map different IAM users and permissions into the cluster directly with the EKS API, opening up OIDC auth to the cluster, allowing you to actually bring your external OIDC providers, unified policy management, OPA's integrations for the open policy agent, validating images when they run, and of course, private link for the EKS API. Today, we have a private endpoints for the cluster API endpoint. So for your Kubernetes API, you can secure that, making it private within your VPC, or applying basically CIDR restrictions to the endpoint. And we'll be doing private link, this private endpoint for the EKS API as well. There's the EKS API is what you use to create and manage the cluster, and the Kubernetes API is what EKS hosts, right? So you have these two APIs, and we'll be adding private link to the AWS EKS API.
Nice.
And then of course on the operational side, right? Like the giving you AWS operational superpowers for your Kubernetes cluster. AWS, like operations is our blood. Like that's our beating heart of AWS, is our strong operations. And so giving you things like ongoing compliance validation for your clusters, things like PCI, and telling you, is your cluster actually meeting these compliance criteria? I'm really excited about this next one, which is pre-flight checks for API compatibility, looking at your cluster dynamically and saying, hey, if you upgraded to the next Kubernetes version today, is something going to break? Are you using an API that's out of date? Is something not correctly defined on your cluster? Automated security assessments, actually doing things like scanning eBPF logs and telling you, is there malicious activity? Is there suspicious activity on your cluster? And then also we're looking at a cluster health API to actually surface all these these health statuses and things that are happening on your cluster, Kubernetes events, up through a unified API that you could subscribe to or get alerted to. This is interesting for a single cluster. Kind of going back to the last few slides, this is critical across lots of clusters. If you're running 15 clusters in multiple regions, how do you have a unified way to get alerted if something goes wrong? How do you set levels of when to get alerted? We want to make this a lot easier. And AWS has amazing tooling for doing this, and integrating that with EKS is something that we're taking a serious look at. So after we review, right, this is the third step of the Marie Kondo method, is we need to discard. And so what are we discarding? We have to discard our waste, right? We should not be wasteful. Being wasteful is not a good thing in any part of your life, but especially when you're paying for infrastructure. You definitely don't want to be wasteful when you have to write checks. So how can we make that easier? So the first segment here is working on cost allocation. So we're looking at tag propagation. How do you go from the cluster and propagate tags down to all those resources? So now you can explore them in AWS cost and usage reporting. We're also looking at things like per pod and per service cost allocation, and how do we help it make it easier for you to do chargebacks and internal billing. So if you're running Kubernetes across your whole organization, you need to bill internally. How do you wrap up that usage on a per team basis and give them a bill every month that says, hey, this is how much you guys spent on your Kubernetes all up. So these are really important, especially as you scale Kubernetes from a small team to an entire company.
Yeah, I keep hearing chargebacks as like the constant.
Yeah.
You know, we need to be able to do this, and so I know that's going to land and be awesome.
Yeah, I'm really excited about this one. And if you can't tell, these are kind of in like order, a little bit of a delivery order, like what we'll do first versus what we'll do a little bit later. But these are all things that are on our mind, right? Like these are all things that we're investigating, and we're figuring out, you know, when do we do them and how exactly do we do them. So yeah, chargebacks are really important, and especially one of the things we are seeing is companies go from a team of devs that was really forward leaning and was like, hey, let's do Kubernetes, let's do this cool Kubernetes thing and grab this. And, you know, going from that to, you know, actually, you know, having IT leaders and having, you know, engineering managers say, okay, actually we're moving, we're going to Kubernetes. That's a constant theme we hear with our customers, is like, we've been investigating Kubernetes for the last few years, we've been trialing it, and we're ready to pull the trigger and make this thing company wide. And as soon as you do that, a lot of these things like efficiency and cost allocation go from being not so critical to being very, very central to what we're doing. So that's a trend that we're following. Improving efficiency, you know, giving customers the tooling they need to make their clusters more efficient, to make it easier for them to run in what they're doing. And so things like Fargate Spot, letting you do that, you know, manage compute, but do it on Spot. Manage node scaling to 0, so allow you to actually totally scale down those managed EC2 instances on your cluster and allow that to scale to 0 if there's ever a reason where you don't have any workloads, and be able to start that from 0. And then Carpenter auto scaling. This is a new project that we're really excited to announce this morning. And Carpenter auto scaling actually is a metrics-driven autoscaler that can help make it easier to scale completely from 0, especially with compute. And Bob talked a little bit about this as well. This is on GitHub at AWS Labs/Carpenter, Karpenter. Hopefully I didn't get the spelling wrong there, but we're really, really thrilled about this project. It's metrics-driven autoscaling for the entire cluster, and lets you optimize for workloads and environments. And one of the things that we're thrilled about this project is similar to our CDK for Kubernetes project. This is built, you know, by AWS. It's initially initiated by us, but we're building this for the whole community. This is the kind of project you can take and you can run in any Kubernetes cluster anywhere. And I think we're really excited to see what customers do with this and how they can improve their utilization and efficiency with this project. Okay, so we've talked through, we've discarded, and now that we've gotten rid of all the waste in our lives, right? It's time to be empowered. And so how do we empower, right? Like, we're going to empower your teams. So we talked about more people are running Kubernetes across organizations than ever, and we want to help you empower your teams. So we're going to empower development teams with really great tooling. So EKS Cuddle, EKS Control is our CLI built for EKS. It gives you really easy workflows to start and manage Kubernetes clusters. I talked about the CDK for Kubernetes, or CDKs. Elad Ben Israel and Eli Polonsky are engineers on the CDKs project. We're going to be talking about this a little bit later in the week. We have a KubeCon talk on this, and this lets you go from you know, code like TypeScript and JavaScript to perfectly formed Kubernetes YAML on your clusters. Super exciting project. So exciting that I actually put it twice on this slide. That's just how cool this project is. And then thinking about, you know, GitOps mode, how do we let you do GitOps that Bob was talking about earlier, doing Git-driven continuous delivery to the cluster, you know, dynamically with the cluster, and set that up as part of the cluster setup. GitOps profiles, and then we talked a little bit earlier about the Kubernetes Cloud dashboard. And then also empowering you to build faster. getting cluster start times under 5 minutes. This is a really exciting project for us, is actually accelerating the time to provision for EKS, and then also lowering the Fargate pod starts as well, making those super fast. We want you to be able to come and just run workloads and have them start super duper quick.
So I have a quick question on that.
Yeah.
Since faster is the word, my question will be quick. Why does it matter how long it takes a control plane to start or a pod to start? What's going to be the advantage?
It's a good question. Yeah, it's a good question. So for the control plane, for a lot of people, it doesn't. A lot of people run control planes and they run them for days or weeks or hours or years, honestly. Like, we've seen control planes on EKS that have been running for the last 2 years. I have a few that have been running for the last 2 years in my account. But there are use cases, especially for immutable clusters or for testing, where I want to be able to start up a cluster really quickly, test if my code runs in it, shut it down, and then push that code to prod. There are also use cases where you may want to, shard out. We see customers starting to shard out to multiple clusters depending on their architectures. And so having that start time be really fast is also, it's joyful, honestly. Like, if you go to EKS and you want to say, I want to start a cluster, like, you don't want to wait, right? Like today our start times are higher than this, and it's a wait. Like, I sit there for a few minutes, like tapping my desk, waiting for it to start up, and like, it's fine. Once it starts, it's fantastic. But like, we want that joyful experience. And then there's also some really great use cases like this, kind of automated cluster provisioning and CI/CD pipelines, clusters being spun up for just individual immutable test cases, where having really fast create times makes those pipelines run that much faster. And so there's some really good use cases for why this is important to our customers.
That makes perfect sense.
So after we're empowered, we want to connect. And we want to connect our applications together within the cluster. And so the way that we connect is with application networking. So Bob talked a little bit about some of the MTLS work with Spire certificates that App Networking is working on. We're also working on resource auto discovery within the cluster. So when you run application networking, we auto discover your services and your resources so that we can kind of knit them together by default. We also want to unify networking across clusters and accounts. So allowing you to connect your different clusters and accounts together into a single network. And then also we're continuing to innovate on the AWS load balancer controller. This is the load balancer controller project we just announced a few weeks ago, and adding gRPC and HTTP2 support, and also improving our support for NLB instance mode, and making it just even easier to deliver network traffic to your cluster. And then also talking about service discovery, giving you more configuration options for core DNS within the cluster, making it easier to scale core DNS within the cluster, and also a global service discovery integration. How do we go from local DNS and actually back local DNS with a global service discovery framework? So you can have really fast service discovery within the cluster. Applications can find each other quickly, but if an application is running somewhere else, it can also go out of that and actually through the same interface reach across the network and find the right application to connect to that could be running in another region or another account or another cluster. And then we're getting towards the end, but scaling is also important. There's a lot of steps to spark joy. I have to tell you, there's a lot of joy that we're looking to spark here, and scaling your capabilities, right? So after we're connected, we're scaling, and one of the ways that we're doing that is with mega extra large clusters. And we have a talk, I think we have Jesse Butler and Kirti from our team are coming and talking about this a little bit later today. And one of the ways that we do this is with our new control plane auto tuning. This is something that's actually going to be coming really soon here. We're really excited about this, allowing you to run larger and larger clusters and have the clusters seamlessly scale to handle them. And then giving customers support to run 10,000 or more node clusters. This is a really big initiative for us, going beyond the tested limits of Kubernetes control plane, and allowing the upstream tested limits, and giving customers the option, if they want to run these hyperscale mega X large clusters. So this is we're excited about. Like EKS, this is making EKS a tool that enables you and lets you kind of implement the architecture that you want for your business. And that's how we see it, is the tools should react, they should enable, and auto tuning in large clusters, in addition to all the multi-cluster stuff we're working on. really puts EKS in that position. And we also talked about networking, but as you scale, networking also has to scale, right? And so 2 ways we're doing that is with higher pod density on each node. And we're working closely with the AWS VPC team to make that possible. And then also IPv6. IPv4 is a pretty limited space. Some customers are limited to a few hundred or a few thousand IP addresses within the cluster. That actually means that even though you could scale the compute for that cluster, you actually couldn't scale what's actually running in the cluster because you're limited by the number of IP addresses that can be assigned. And so we've done some work on this. We have secondary CIDR support, which is effectively a second range of addresses that your pods can have within the cluster. And if people out there are confused of what I'm talking about, I'll give a quick analogy. Think of a Kubernetes cluster like a city. It's a city, and every time you run an instance of your code, that's like a house in your city, right? And so we talked a little bit earlier about service discovery. Service discovery is almost like a phone book. It lets every house know, hey, if I need to call my neighbor, what's their phone number, right?
You might need to explain what a phone book is to some of the people in the audience.
Think of it like the contacts app in your iPhone, right? So
there you go.
It's like, yeah, it's like Facebook or Twitter, right? Or email directory. But when you build a new house, when you add a new piece of code, when you scale the size of your city, you need to give phone numbers. Like you can't have a house without a street address or a phone number in our cluster. It just doesn't work. You're not allowed to have things that are off the grid in Kubernetes. And so what this means is that some clusters, some cities are limited in scale. Like some people are told, hey, you can only build a city that has 2,000 houses. And they're like, wait, what? Only 2,000? And that's because the way that IPv4, the old way of internet addressing, has, it has a limited number of addresses because of its format. Again, this is a topic we could talk about for an hour, but I'll be brief. IPv6 is the new generation of addressing, and I don't know the number off the top of my head. Maybe you guys do. It's something like a quadrillion possible addresses.
It's like some number like 36 undecillion or something
undecillion,
like that.
Yeah, okay, yeah. I knew it was like not even a quadrillion, like 36 undecillion. It is massive. It basically the folks behind the internet came up with this the theoretical framework and have implemented it. This is IPv6 is used in production today, and AWS is implementing and adopting IPv6. We're going to adopt IPv6, and what this means is effectively, like, there are limits, but effectively the size of your cluster, the size of your little Kubernetes city is unlimited, and you can have as many street addresses as you'll ever need. Like, you'll run out of land before you run out of addresses, and that's really the goal here, is to let you build really, really large clusters, or to have as much running in your cluster as you need to run. We don't want to force that architecture. And that's expansion, right? Like, after you scale, you want to expand. Where do I go from here? Like, how do I expand my reach as a user, as a developer or an operations team that's using Kubernetes? And so the way that we help you expand your reach is first with the latest software. So giving you 4 versions supported at a time. This is a change that we've actually already made. So we support 4 versions of Kubernetes at any time, with at least 1 year of support for every Kubernetes version. This is actually following upstream Kubernetes, which is important to us. So every version is patched, it's ready to go. Moving our release cadence to be within 100 days from upstream. So we want to give you the latest software when it's available. And then also starting to take some of this common software that's out there that people are using and running test suites against it, actually telling you, hey, does this stuff work properly on AWS? Is this stuff validated? Can we build it? Can we run it? Which versions of Kubernetes does it work really well with? And kind of giving you that green check mark so you know, hey, I want to install this operational tool on my cluster on AWS. Is this good to go? Is this version of this tool good to go? And actually giving you some of that validation and building a framework around that for customers to run on their clusters. And with the latest software comes the latest compute, right? So AWS is, lots of different compute options to run your applications on the cluster, from Fargate, which is, our fully managed compute, and includes, adding capabilities to Fargate for observability and making this more Kubernetes native. Today, you have to do a few extra steps in AWS, and we want to make this even more Kubernetes native with Fargate and make it seamless, seamless compute within the cluster. We've recently added support for some new exciting AWS instance types, ARM nodes with the Graviton processors, and then Inferentia, which is our new machine learning chip, and then hybrid, enabling customers that are using AWS hybrid options like Outposts, local zones, and wavelengths to run Kubernetes with EKS on them. And EKS is supported on all three of these hybrid options today. And then also regions. And we'll talk a little bit about regions in a second here. And in addition to the latest compute, we want to let you control the cloud, right? We want to give you full control of the cloud from your Kubernetes cluster if that's how you want to run things. And the first way that we're doing this is with AWS controllers for Kubernetes. So this is an exciting project that's also on GitHub if you search AWS controllers for Kubernetes. And this project is effectively a set of service controllers and custom resource definitions. In more general parlance, what that means is we're actually allowing you to define AWS resources using the Kubernetes API. So you can start with just a Kubernetes cluster on EKS or honestly anywhere, and you can define the AWS resources that you want to run through Kubernetes. So if you want an S3 bucket, or you want an API gateway endpoint, or you want I don't know, like an RDS database, allowing you to set that all up through Kubernetes and then have the metadata for that be fed back natively into your Kubernetes applications. So if you're running a middle tier web app, right, like a shopping cart checkout, and that relies on an RDS database, you should be able to not just run your middle tier web app component in Kubernetes, but also actually use the same API to define the RDS database that's going to be the state store for that app, and feed the RDS database environment variables like, where is this database? What's the login information? Feed that back dynamically into your cluster so that your app can just grab it and run it. So the experience as a user is that I'm running this RDS database, this SQL database locally within my cluster, but actually it's fully managed and hosted on AWS, and you don't have to worry about scaling it or maintaining it. And so that's one example. We have a whole roadmap and a host of controllers we're working on, and Bob talked a little bit about this as well, but that's the kind of user flow that we're working to enable with ACK.
It's kind of funny to think about how you can use the AWS API to create an EKS cluster, and then use the EKS or the Kubernetes API to further create additional AWS resources. Like, it's very who came
chicken
first.
and the egg.
Yeah.
Well, and an EKS controller is not off the table here. In fact, that's on our roadmap. So the idea that you could have this Genesis cluster, for lack of a better word, that basically then lets you define more Kubernetes clusters, more resources. That's absolutely a vision that we see some of our customers starting to implement. And kind of moving on, additional things here is observability tooling, making it really easy to visualize the cluster and the state of the applications within it. We have some great observability tools within AWS, and our partners do as well. And so making sure those are really well integrated. And then we're working on additional CSI drivers for things like S3 and AWS Secrets Manager and Parameter Store, making it easy for you to actually use those with the container storage interface spec, especially for secrets. That lets you actually mount secrets natively in Kubernetes that might be stored in AWS. And then I talked about regions. Run everywhere. This is our goal. AWS EKS is actually in every public AWS region today. There's a few that are in orange that are not quite public global regions yet. Osaka is a limited availability region right now. It's a disaster recovery region, but there's a announcement. This will be a full region in the next year here, and then we also have 4 other regions announced from AWS: Hyderabad, Jakarta, Spain, and Switzerland. And EKS will be in every one of those regions. And so, no matter where you are in the world, we want to let you give you the power to run EKS and to run Kubernetes locally, and to run across all these regions. So that's that was a summary. That's like the tip of the iceberg, right? That's most of the big initiatives. But I really encourage you to stay up to date with what we're doing and give us feedback and propose new ideas. You can also get notified when features ship by subscribing to things on the EKS public roadmap. This is on github.com/AWS/container roadmap. If you scan that QR code, I promise you won't be rickrolled. It really goes to the container roadmap. I should probably test it, but I think it does. Really encourage you guys to follow along and keep up with all the cool stuff that we're doing and working on. And then also, this is an open roadmap, so submit issues, submit ideas. We have a great issue tracker here, and myself and the other folks in the product team regularly look at this and bring this into our product planning discussions. And so I think we have a few minutes for questions here. And if I'm not mistaken, I think there's some other folks on the line from the team as well to answer them. Hey guys.
You said other folks on the product team, and so here they are.
Here they are.
Here we are. Here they are. Here we are.
So there were, first of all, that was really awesome. That the Marie Kondo thing, that was super cool. Super cool, Nate. So
I'm inspired.
So inspired. And my favorite part is getting rid of everything. So just when
just keep your clusters around. Just don't get rid of your Kubernetes clusters.
Right, of course. So there was a lot of talk in the chat around, there was a lot of people that are new to EKS, new to Kubernetes, and I just wanted to plug EKSworkshop.com. So a lot of these, features we're releasing, a lot of features that exist already. If you walk through EKSworkshop.com, you'll be able to do this hands-on on your own. And if you registered for Container Day, I believe there are some credits. So you mix EKS Workshop with some credits. It's a win-win.
Exactly.
Now, okay, so there's a question I wanted to pose to the group here. There was a lot of talk around Carpenter. So if we can maybe explain to the audience, what's the difference between Carpenter and, let's say, Cluster Autoscaler?
Yeah, that's a really good question. I'll take that one. So Cluster Autoscaler is probably the most used node autoscaling project in Kubernetes today. It's actually part of Kubernetes. It doesn't ship with the core Kubernetes code. It's an add-on, but it's maintained as part of Kubernetes. There's a autoscaling SIG. And Carpenter is nowhere near the maturity level of Cluster Autoscaler. I think that's the first thing to point out. This is a really early stage project. This is experimental. I actually put this live on GitHub, myself and our engineers. We put this live earlier this morning. So like very, very early stage project. But it's exciting for a few reasons. The first reason is that the way that scaling works in Kubernetes today is that you scale your application, and that can be in a number of ways. You can either go in and manually scale a deployment, or you can use something like the horizontal pod autoscaler or KEDA, which is Kubernetes event-driven autoscaling, and you scale the size of your application. So you scale the number of pods that are running. And what happens is that at some point you run out of room on your cluster, right? So the Kubernetes API server, the scheduler, can't place those pods anymore. Like it actually runs out of room. And what happens then is that those pods become pending, and the scheduler says, hold on, like I'm waiting until I get some place to put this thing, right? Like I just literally can't put this box down. There's no space for it. And at that point, that's where Cluster Autoscaler kicks in. It says, hey, there's a pending pod. Let's start some more compute. Let's look at the pending pods and figure out how much compute that's going to take and start some compute. And so for a lot of use cases, that's a really good scaling system. It means that your cluster is reacting to the applications you're trying to run. But there are times where that really doesn't make sense. So for example, if you know that you're running a promotion or you have a big sale and you're running a web store, and you know that at 9 a.m. tomorrow morning, in 5 different time zones, you're going to have huge spikes in traffic across multiple clusters. You want to run on a schedule. You need to scale that compute out ahead of the application so that you can scale up quickly enough. You can have everything running on time and not have outages. If you know you have big batch jobs coming down a queue, and you know that, hey, this batch job is about to hit, I need to have compute to land it. having that pending pod architecture starts to break down a little bit. And so with Carpenter, our goal is not to get rid of the concept of pending pods, but it's allowing you to augment it with metrics-driven cluster scaling as well. And also, Carpenter happens to be a really good project for scaling any type of Kubernetes resource. So we're kind of excited to explore those ideas, but the idea that you can come in and you can say, hey, I want to scale up from 0 on this metric, and then I want to use pending pods, or I want to use CPU utilization, and I want to scale down on this other metric. That type of flexibility isn't possible today with Kubernetes, and that's what we're really focused on enabling with Carpenter.
Fantastic. Okay. So there was a lot of talk around Spot instances in the chat. So, you know, and Nate, you mentioned Spot as well. I guess what is the future of integrating, you know, EKS clusters, managed node groups with Spot, and do you see, you know, future integrations down the road there? And anyone can answer, not just Nate.
Sure, I can take that one. Spot support and integration into managed node groups is probably the top EKS feature request right now. I think if you go to the containers roadmap, you'll see, I don't know, 400 or 500 upvotes on it. So it's very clear it's a big feature request. And Spot is actually one of the larger use cases. It works really well with Kubernetes. I think if you look at the distribution of Spot on Kubernetes versus EC2, it's actually more Spot on Kubernetes because Kubernetes does such a good job with you know, health checking and making sure workloads can move onto new instances. So we're very close to finishing out the integration of managed node groups with Spot support. And the nice thing about it is managed node groups will handle all of the Spot termination notices instance draining for you. You don't have to add anything else into your cluster to make that work. Managed node groups will automatically integrate with ASG to handle those termination notices. And as soon as it does that, it'll, you know, spin up a new node, move your workloads, cordon and drain the nodes so you don't have to do anything. So we're really excited about this integration, and it'll be coming out very shortly here.
Nice. One of the questions I had, it kind of is related to Spot, but also just an observation. We talked about Mega XL clusters, and Kirti, I know you have a session coming up later today. But one of the things that I see with Spot customers especially is they oftentimes will have a lot of nodes because they're just focused on give me the right number of cores or the right amount of memory or something like that. And however you know, they end up getting there, they don't really care about. And so a lot of times they'll get like a lot of you know, different instance types and stuff. So Kirti, do you think, you know, the Mega XL work that you're working on is gonna help enable that? And what other use cases are there to have really giant clusters?
Yeah, 100%. So I think, like you said, it's an important use case for running really, really big clusters. So that's one of the things that we're going to probably like support with Mega XL clusters. In terms of other use cases that we've been hearing a lot from customers that they want to run for really large clusters is one, I think Nate kind of alluded to this, but if customers have really spiky workloads, so say, for example, we have an e-commerce customer who sometimes has spiky workloads. I mean, they can predict it sometimes. Sometimes it's kind of unpredictable. But say, for example, you're talking about the holiday season, right? Like Christmas, New Year's. So for seasons like those, for events like those, you would want to use a really large cluster because you can have huge spikes in demand. The second use case that we've seen usually customers talk about for using these mega clusters is batch workloads, like really large data processing, right? If you have huge amounts of data, you kind of like exhaust that 5,000 node limit that we have set by the upstream, and then customers kind of have to shard their data across multiple clusters in order to process that data. So that kind of also increases processing time. So that's another use case. We will actually dive deeper into the various use cases for mega clusters. We have a talk coming up at 3:15 p.m. EST. Jesse, our senior developer advocate, and I are going to talk about it in detail. So please tune in if you're interested. We'll talk more about this at that point.
Awesome. All right. So I think that's about all the time we have for this particular session. So thank you, Mike. Thank you, Kirti. Thank you, especially Nate, for letting us in on what to expect over the coming year. I think this is going to be an awesome 2021. I was about to say, I think Nate froze, but he unfroze.
No, I'm here.
It's all good.
It's going to be an awesome 2021. This team has shipped so much, not just the folks you see today, but there is a huge team behind us that we work with. And, we're just eternally grateful to them and to all of our customers. And thank you guys for having us today. It's been really a pleasure to be able to be here and talk about what we're doing.
Awesome. Thank you. All right. So next up, please join me in welcoming our first of two yoga breaks that we're going to have today. And we're excited to have one of Boston's top-ranked yoga coaches with us today. Ali Singer from Yoga Hub is passionate about helping people cultivate happiness and empowering, that's right, get stretched.
Just get
empowering, empowering everyone to accomplish their goals. And in our first session, chair yoga, Ali is going to guide us through some peaceful meditation and mindfulness, along with some yoga stretches. And of course, yes, you will need your chair. So get ready and join me in welcoming Ali.
Hey everyone, welcome to your first chair yoga session. All you need as a prop for practice today is an upright chair, probably the exact chair that you're sitting on. If there's wheels on your chair, I recommend that you lock them so you're not rolling around unintentionally. We're going to start with a little breathing technique. Then we're going to do some stretching. I know you're eager for that. I saw you already getting some stretches in your chair. And then we'll do a little yoga flow followed by some guided meditation. So we'll start right now with a breathing technique. It's called Ujjayi breath. You can use this to steady your mind. And I know that you're doing a lot of taking in of information today. So this is a meditative technique that can be very helpful as you're integrating all that information and receiving more. So it sounds like this. You might be able to just imitate that and get the feel for it right away. But if you're not quite able to practice it right away, here's a technique for trying it out. You're going to exhale like you would to fog up a window. And then do that, but close your mouth halfway through. Keep your mouth closed and continue to breathe with the throat constriction. So let's try it. Take a deep breath in. Open mouth, exhale. Then close your mouth. Good. I can feel you doing it. I know some of you got that right away. If you didn't, don't worry. It'll come over time. So let's all stand up for some stretching. I'll meet you over at your chair. So use that Ujjayi breath technique throughout your stretching and throughout the poses. That's a really good way to steady the mind, which is what yoga is all about. Stand upright with your arms down by your sides. This is Tadasana, translates as mountain pose. So it's a pretty strong pose. Be very tall and lifted through the center of your chest. On your next inhale, stretch your arms up overhead. Exhale, open arm back bend. Bend your elbows out wide, lift the center of your chest higher, and lean back from your upper back. Next inhale, stretch your arms back up overhead. Exhale, open arm back bend. Nice. Next inhale, stretch your arms back up overhead. We're going to repeat this 2 more times. Exhale, open arm back bend. Keep your core strong. Keep your upper back strong. Next inhale, stretch your arms back up overhead. Final exhale, open arm back bend. Hold and breathe here. So draw your elbows together behind you. Even if they're not getting any closer together, it's the action of trying that really counts and matters for something. Most of the day, sitting at our computers or looking at our phone, we're in the shape that's the opposite of this. So rounding the back and hunching forward. So here we're strengthening the muscles that usually get weakened and stretching the muscles that are usually super tight. Take another breath here to breathe into those spaces. Next inhale, stretch your arms back up overhead. Exhale, Samastitihi. Bring your palms together at the center of your chest. Close your eyes or find a soft gaze. Notice your heartbeat and notice your breath. Take a few more moments here, tuning into your sense of touch. So the habitual mind will always be wandering towards the past or the future, but in yoga and meditation, the goal and the practice is to bring the mind to the present moment. So you can use your sense of touch to help do that. Take one more breath here. Then release your arms down by your sides. We're going to set up for a supported downward dog at the chair. So you can also do this with your desk if you don't have an upright chair like this. You'll stand behind your chair and place your hands on the backrest of the chair or on your desk. Both work. Then you'll walk your feet back to make a 90-degree angle at your hips. So look down at your feet and see that your feet are under your hips, and the hands should be about level with the shoulders. Bend your knees at least a little bit so that you're not locked into your knee joints. Draw your lower belly in so that your core is strong and you're not sinking into your lower back. Breathe here. You should feel a stretch through the backs of your legs, unless you're already really mobile there. You might feel also a stretch for your shoulders. So if you choose to take away one pose from the practice today, this is the one that I'd recommend. Well, this or a standing back bend. This downward dog at the chair is great for alleviating lower back pain by stretching the hamstrings and also strengthening the core. So really hug your lower belly in so that you're active and engaged there. And check in with your breath. And take a few more moments to breathe mindfully here. And if you can breathe really big, perhaps you can feel how it stretches you from the inside, allowing your breath to flow into the spaces that are normally tense. Give yourself one more breath right where you are. Then look towards your chair. Walk your feet forward and stand upright. Release your arms down by your sides. Steady your gaze and minimize movement. Mindfully release. So next we'll do a half sun A, which is a modified flow, moving one movement, one breath. I'll walk you through it. And we'll do it 3 times. So on the 3rd time, see if you can get into the rhythm and flow at the pace of your own breath, nice and slowly. I'm just going to push this chair out of the way, so you'll need some space around you. And I'm going to turn sideways so you can see profile view, but you can stay facing whatever way is most convenient for you to watch if you need to see rather than listen to my voice. On your next inhale, stretch your arms up overhead. Exhale, forward bend. Hinge at your waist and breathe out all the way. Relax your head down. Next, inhale, halfway lift. Press your hands to your legs. Roll your shoulders together and back to a flat back. Exhale, forward bend. Breathe out all the way. Drop your head all the way down. Slowly rise to stand. Stretch your arms up overhead. Exhale, Samastitihi. Bring your palms together at the center of your chest. Take a single breath here. Minimize fidgets. One other, sun A. Next, inhale, reach your arms up overhead. Exhale, forward bend. Hinge at your waist. Breathe out all the way. Relax your head down. Inhale, halfway lift, make a flat back, roll your shoulders together and back. Exhale, forward bend. Relax your head all the way down. Slowly rise to stand. Stretch your arms up, lift up from the pit of your belly, really, really reach. Samasthiti, bring your palms together at the center of your chest. Steady your gaze, steady your breath. One more Sun A, nice and slow at your own pace. Next, inhale, reach your arms up. Exhale, forward bend. Hinge at your waist. Relax your head all the way down. Inhale, halfway lift. Roll your shoulders together and back. Broaden your chest. Exhale, forward bend. Hinge at your waist. Drop your head all the way down. Slowly rise to stand. Stretch your arms all the way up. Samasthiti, bring your palms together at the center of your chest. Steady your gaze, steady your breath. After your next exhale, release your arms down by your sides. Next, we're going to do a guided meditation with eye relaxation, and that will conclude our session for today. So if you prefer to lie on the ground for this part, you're welcome to do that. I'm going to have a seat in the chair. If you're sitting in your chair, you can do exactly what I do. It can be helpful to rest your elbows on your desk in front of you. So if you have some space on your table in front of you, you can use that as a prop. Bring your palms together and rub your palms together vigorously to create some heat. Really, really rub and feel the friction between your hands. Once you have a good amount of heat between your palms, cover your eyes with your palms. So have your palms touching the ridge of your brow bone and cheekbone so that you're not actually touching your eyelids.
Hey, Ali, I thank you very much. This has been an awesome session, and we are going to try and get back to it with GitOps. I hope everyone's feeling refreshed and reinvigorated, and definitely stay tuned for GitOps coming up next, and then Ali will join us again later this afternoon for another session. So looking forward to it.
Thank you.
Thank you. All right, so joining us today, or now, we have Michael Hassenblas and Stefan Prodan. Adam, take it away.
Well, so we're going from yoga to GitOps. It's the ultimate transition. And I think they both, at the end, bring tranquility. And that's the goal here. So
I like that.
I just made it up on the fly. So why don't you folks take it away?
All right. Thanks a lot for having us. My name is Michael Hausenblas. I'm a product developer advocate in the container service team. And together with Stefan from Weaveworks, we're going to try to excite you today a little bit around GitOps and progressive deployment. All right. So we have just a few slides and then a lot of demo. Fingers, everything. So if you remember earlier on, Bob mentioned that already, gave a quick primer what GitOps is, right? So you have essentially everything, your infrastructure, your applications described in a declarative way. YAML gives you a little bit of a hint. So, if you want to do that, you will end up being a YAML engineer, be warned. The desired states, what you want to see running, your deployments, your mesh, your persistent volumes, whatever is described in a canonical way in Git, in this version there. And anything that whenever you want to kick off a change is automatically applied to update your deployments, your applications, or your infrastructure. And everything is automated. You have agents that ensure correctness and alert close loop. So that's nice on a very high level, but what does that actually mean? We have essentially two cycles. The, if you wish, the continuous integration build cycle, developers creating artifacts. It might be a container image, it might be a Helm chart, etc., etc. And then we have the deployment cycle, and Git being this, shared state store between these two cycles and representing a kind of immutable or immutability firewall. So rather than giving developers kubectl access to the cluster and going, fat ferrying kubectl apply, boof, the namespace is gone, we decouple that using Git. And with Git, all the known workflows, all the security, everything that we know and love from Git is there. Love or fear, depending on if you're into Git bisect or whatever. But in any case, you're using Git there, and then you using tools like the ones that we are going to show, Flux and Flagger, to actually do the deployment, to automate that. So to sum up, Git is the single source of truth here, and everything that we want to have changed on the infrastructure or application level is committed. If you're using GitHub, for example, it might be a pull request. You then have bots and humans that are reviewing for conformance, for compliance, or whatever. And once that is merged, the bots automatically, or the agent automatically synchronizes the state in Git with what is running in your Kubernetes cluster. So all the changes are verifiable, observable, and auditable, which lends itself really very nicely also for very regulated environments. Think of financial services, healthcare, whatever, where you need to be able to say at any point in time, this version of the container running here in this staging area of this cluster was originally requested this change by this developer and has been approved by this DevOps or SRE type. All right, so this is on a very high level GitOps 101. We just wanted to make sure that we're all on the same page once we get started with the real interesting stuff, and that is the actual tooling. And for that, I hand over to Stefan, and that is Flux.
Thanks, Michael. So we applied this pipeline, if you think about it, like a pipeline, continuous integration on one side, Kubernetes deployments on the other side. We first applied this pipeline roughly 4 years ago when we created Flux. So Flux was back then powering with Cloud, which is a platform for managing Kubernetes, monitoring, and so on. And in these 4 years, a lot of things evolved. Kubernetes evolved. We got custom resource definitions. We have controllers. We also have libraries created upstream in the Kubernetes repository itself for building these controllers. We didn't have any of that back then. So when we created Flux version 1, we said, okay, we are going to run inside Kubernetes. And that was new because everybody was running the continuous delivery platform outside of it, maybe in Jenkins, or there are so many platforms out there. And we are going to move this inside Kubernetes, and the cluster itself will reconcile its state from a single Git repo. So that was Flux version 1. In the last 7 months, we've been working really hard on Flux version 2. And this is how it looks. An overview. Flux no longer is limited to a single Git repository, and it also goes beyond Git. So in version 2, you can define your cluster state, and not only your cluster state, you can define your fleet state, like all your clusters, dev, staging, production. Maybe you have several production environments and so on. Can define that in a Git repo. Then you can register other repositories inside that cluster, let's say app repositories or specific infrastructure repositories. You can also define state in S3 buckets. This is something we recently added to Flux. And there are particular use cases for using, for example, S3 bucket to define some state. I don't know, maybe you have an encrypted bucket with some secrets in there, and you don't want those to, to move them, to expose them to other platforms. You don't want those on GitHub, for example, and so on. So you can also reconcile state from S3 buckets. You can also define Helm releases inside your clusters, and Flux will connect to Helm repositories to pull those charts from there. And it also monitors container registries and detects when you push a new images there. Another feature that we've added Flux version 2 is an event system. Before, Flux was known as a pull-based delivery system. You'll push something to Git, then you'll wait for Flux to pull those changes from your repo. Now, what if on your dev cluster or dev clusters, you want this loop to be instantly? So what we did, we created a webhook receivers, we call them. So your CI system, after it, let's say, builds an image, it can tell Flux, hey, there is a new change, do something with it. You can also create webhooks in GitHub or GitLab or Bitbucket and so on. And those webhooks will signal Flux that change is there, so it needs to act on it. Another feature that a lot of users asked us about was alerting and notifications. So we had solutions for that. There were several community projects around it. Now alerting and notifications are built into Flux. You only have to define where Flux should send those notifications. And I'm going to explain a little later what that means. So how did we end up with Flux version 2? First, we've created a toolkit. Of course, it's called GitOps toolkit. And this toolkit is a composition of several controllers and Kubernetes custom resources. We have a controller called source controller. And this controller is in charge of fetching manifests from various sources. Like I said, Git repositories, buckets, Helm repositories, and so on. Then we refactored Flux into two specialized controllers that are reconciling our cluster state from sources. One is customized controller, and this controller can apply plain YAMLs from repos or from any source, or it can also apply customized overlays. And a different reconciler is called Helm controller. And what Helm controller does, it reacts to Helm releases. So you can define a Helm release in your Git repo through a custom resource. Helm controller sees that on your cluster, and based on the operation you did in Git, if you added a release, Helm controller will create one. If you modify a release, Helm controller will upgrade one. And if you delete it from your Git repo, well, it will be deleted from your cluster. So any operations you do with Git in the file system, those operations are replicated inside your clusters. There is a dedicated controller called notification controller, which handles incoming events and outgoing events. What I mentioned before regarding webhooks. You can, for example, register a webhook from GitHub and tell notification controller, hey, when you receive an event from GitHub for this particular repo, tell source controller to fetch the new version. Source controller fetch the new version from Git, then it will issue a Kubernetes event that goes throughout the Flux controllers, and all the other controllers will react immediately. Source controller say, hey, I have a new revision. There is a new SHA. Customized controller will apply that on your cluster. And maybe in there is a Helm release with a change. Helm controller will detect that change and will upgrade that particular Helm release. When the upgrade, let's say, is successful, or maybe it fails, you can also configure alerting, also through notification controllers, and can tell notification controller, hey, for this particular Helm release, if it fails, I want you to post the failure reason on, let's say, Slack, on a particular channel, or Microsoft Teams, or Discord, or even your custom webhook. I don't know, maybe you want to store these events in Elasticsearch and so on. There are many ways on which you can expand on Flux events. In terms of observability, we added a bunch of stuff to Flux, so it's easier to debug, it's easier to troubleshoot. because everything is now configured through a custom resource, you can do kubectl get describe, and you'll see what's happening. Flux also now can do health checkings for workloads, custom resources, and if after it doesn't apply, you can instruct Flux, hey, check my deployments, check my stateful sets. If something is going wrong here, let me know. And it will issue a Kubernetes event. It will also expose Prometheus metrics. So you can use Prometheus Alert Manager if you want to do that. Flux also comes with Grafana dashboards. So you have dashboards for monitoring all these operations. Slack and so on, as I mentioned, notifications. And we also added a new thing here that comes from CI systems. For example, in CI, when you do a commit, let's say you have GitHub action, it will build a container image or will run your tests. If that fails, it will set the commit status inside Git and tell you, hey, it's a red dot, something failed here, click to find out more. And we want to have the same experience also when things happen on the cluster. So you can instruct also through notification controller, you can define such a notification, and Flux will write back to your GitHub repo, GitLab, Bitbucket, and so on, and it will write back that commit status. So you'll know by just looking at the repo if something went wrong or not. We also support multi-tenancy, and we have a multi-tenancy for organization here. There are many multi-tenancy strategies that you can apply. In here, for example, we dev teams and operators, platform admins will collaborate on the fleet repository where you register apps and you define clusters. And in here, a platform admin can assign Kubernetes service accounts or users to a particular app repo. And when that app repo will be reconciled on the clusters, it will be reconciled under that particular service account. So you can limit the access of what a repository can contain, right? So in this way, we ensure that teams will not overlap each other and so on. Okay, let's get to progressive delivery. So Flux is doing the GitOps part, right? We can add a new controller to the Flux system called Flagger that instead of letting Flux roll out a new version directly on production to all the users, with Flagger, you can do canary deployments or A/B tests and route a particular segment of your users to the new version. Run your conformance tests, look at SLOs, Prometheus metrics provided by AppMesh to validate the new version. If those service level objectives are failing, then Flagger will do an automatic rollback for you and will let you know, I don't know, on Slack and so on. It will issue a Kubernetes event, and only a part of your users will be affected by that faulted version. So now I can jump into the demo. Are you ready, Michael?
Yes, let's go for it. And since people asked, everything that we're showing here, Flux, Flagger, is open source. So you can just go and grab it, and we show it in the context of our managed app mesh, service mesh.
And hey guys, just a quick interruption. There was just a couple questions I wanted to float your way. One, just pretty simple, is Flux open sourced? So this was a question from the chat.
Yes, all the tools are open source.
Let's maybe kick off with Stefan, because we have understand the tight schedule, and we want to make sure that these things take a little bit.
Okay.
And as soon as we have that kicked off,
so I have a Git repository on GitHub where I define application infrastructure and so on. So I want to take this repository and make this repository the desired state of my EKS cluster. So I have here a cluster, an empty one that I just created. Let's see what namespaces are here. Okay, it's an empty cluster. And now what I'm going to do, I'm going to run a command with the new Flux CLI. This is the Flux version 2 CLI, where we run a command called bootstrap. And what this command does, it connects to GitHub. It uses my token. I've set the token in environment variable. It connects to GitHub, and it stores there its own definition. If this particular repository doesn't exist, it will create one for you. It can add GitHub things and so on to the repo. It adds all its. What?
I think you're going to need to bump up the font size a few notches.
Okay. So what the Bootstrap does, it will create or update an existing repository. It pushes all the Flux manifests to that repository. Then Flux will be able to update itself, upgrade itself, and so on. And afterwards, it will create a deploy key, so it can connect to the repo using SSH and not using my personal access token. So I'm using the personal access token to Bootstrap, but from this moment on, Flux will take its own identity through a deploy key, which is a read-only deploy key. And let's see what happened on my repo here. So we see there are two commits. One commit is where Flux has added its own namespace called Flux system, and here are all the custom resource definitions and controllers that Flux needs, source controller, helm controller, all the things I've mentioned before. And on the second commit, it will create two custom resources. One is a Git repository, and this is how you can register sources on your cluster. With this custom resource, I'm telling Flux, hey, I want you to go to this Git repo, clone it, and make it available inside my cluster. So this is stage one, we register sources. Stage two is we tell Flux how to apply those sources. I'm going to make this a little bigger.
Thank you.
So
much better.
We have here an object called customization. You can think of this object as the server-side variant of the customization.yaml that you usually use for customized build and so on in your for your files. So we create a customization and we tell Flux, hey, apply everything on this cluster from this directory, clusters upmesh. So this one configures how the cluster reconciliation happens and from where. So I want to reconcile this path from this source. Now, if we go back here, and we can...
And here as well, Stefan, maybe 2 or 3 font size increases so that we can see it better.
Want it bigger?
Yeah, a little bit more.
Much bigger. It's going to need to be several notches bigger.
How is that?
Just the font size in the terminal, yeah.
Okay, so what is happening now? I've structured my infrastructure items into several layers, and Flux is now reconciling them in a particular order that I've described in Git, and I'm going to show you what's happening here. So in here, in infrastructure, I've organized this into cluster add-ons, mesh add-ons, and the mesh itself. So let's look at cluster add-ons. What I have defined here, I have controllers, and here I'm installing two controllers. One is the upmesh controller, and the other one is a metric server, so I can work with horizontal pod autoscaler on EKS. If we look at the upmesh controller, we see that this is a Helm release. It installs the upmesh controller from the EKS Helm repository. And here you can see I have no version specified, which upmesh controller I want to install. When you don't specify a version, what Flux will do will go to the Helm repository to get the latest SAMver release from there. And it will do that, it will check that every 5 minutes. So if there is a new upmesh controller release, it will get automatically upgrade on my cluster. Maybe this is not the best way to handle production systems. But for development, you want to run with the latest controllers available. Okay, I also defined in infrastructure the mesh add-ons, which are Flagger, the app mesh gateway itself, and I'm also installing the app mesh Prometheus that is scraping the Envoy sidecars so I can get metrics out of app mesh. So this is how I define my infrastructure, and I'm telling Flux, hey, first you have to install the app mesh controller, register all the custom resource definitions, wait for those to be ready, and only after that install the gateway, install the mesh, and so on. So I'm describing how the installation should happen and how the upgrade should happen. I also have here applications that I've configured. This is my demo app called Podinfo. And let's see how can I define an app through GitOps. I have a deployment spec that's a normal Kubernetes deployment for my application. I have here a custom resource definition specific to app mesh called gateway route, with which I'm configuring the app mesh gateway to route the traffic towards my app. And here we see that the gateway route points to a virtual service reference, but I have no virtual service definitions here in my repo. Why is that? Because we don't need to create all these app mesh objects. Flagger will create them for us automatically. What we need to do is just tell the gateway how to expose the app, and that's it. Okay, so we are here. Everything has been applied. All the layers are at this version. So I'm going to stop this. And now I'm going to see if the load balancer is online.
Waiting for the load balancer. We do that a lot on the Containers from the Couch show.
Okay, let's see. What's the load balancer address? And let's hope this works. Let's open it here. It's not yet ready. It will take a minute or two before it comes online. Going back to the repo to explain something. So we have here 2 release configurations. One is called canary, one is called an A/B test. What I'm going to do now, what I'm using now is a canary definition. And in here, you define how you want your app to be rolled out into production. And we set up a couple of things here. We configure, for example, retries for app mesh and so on, a prefix, rewrite, and all that stuff. What's interesting here is the analysis part where we define our service level objectives, like, okay, I want the request success rate to be 99%. If it goes lower than that, roll it back. And I want my app to respond in a maximum of 500 milliseconds. If the average request duration goes over 500 milliseconds, then my app should be rolled back. Okay, and my app is working. The load balancer is fine. The app mesh gateway has routed everything, and I see that I'm on 500. Now, let's say I want to deploy an application, a new version of my application, and I'm going to do this inside my repo. Going to change the version to 501. I'm going to commit this to Git. I didn't pull the changes. Okay, let me try it again. Okay, commit. Okay, let's check if that actually happened.
So what did you just do? You pushed you committed a change, pushed that up to GitHub, and now we're hoping to see that change reflected on our cluster, right?
Yeah, so what I did was bump the version from 5.0.0 to 5.0.1. And what should happen now, Flux should synchronize these changes onto the cluster. You can also tell Flux to reconcile the changes immediately. So I'm going to say Flux reconcile source git Flux system. And instead of waiting 1 minute for Flux to pull the new commit, I'm telling it, hey, pull it now. And what will happen if I'm doing Flux get customizations, we'll see how the new version will be rolled out throughout my layer. So first it had applied itself, then the cluster add-on, the mesh itself, and now it waits for the mesh add-ons. So every time you do a commit, it will follow that particular order that we described for install and also for upgrades.
So,
and yeah.
We have a couple questions from chat that I want to make sure to address. One, did we ask it already? Is Flux open source? I think we did, now that I'm saying that out loud. Awesome. And then number two, is Flux v2 ready for production? And that's, I feel like that's kind of a, up to the end user's best judgment, but at the same time, what's your stance on it? Should people use it in production?
So we have published a roadmap for migrating from Flux version 1 to 2. We have 3 milestones. We finished 2 of them, and we are now working on automated image updates where Flux scans the container registry. So if you want that feature, you have to wait for it to be done. If you use GitOps in a straight way with no container registry scanning, you just push to Git and you want to synchronize it on the cluster, Flux version 2 is here and is ready to rock. So
nice. Yeah. And then this is probably a simple one for you, but can you deploy Flux v2 using a Helm chart, or is there a Terraform provider? What are the easy pre-baked ways to deploy Flux v2?
So we don't have a Helm chart. We do have the CLI that can generate the whole YAML for you. So you can do Flux install -- export and generate all the YAMLs. It's like you are doing a Helm template. And we also have a Terraform provider. So you can do the whole bootstrap with GitHub, with GitLab, and so on by using Terraform. That's what we have right now.
Not to forget, Flux is a CNCF project, so everyone is welcome and invited to participate and to help growing.
Awesome, right. That's a good point. Are there any best practices for managing secrets between different environments using Flux?
Yes, we have support for Mozilla SOAPs, which is a solution for encrypting secrets with PGP, with AWS KMS, with Azure Vault, with everything. So try out Mozilla SOAPs is a great solution. We have full support for it. And we also do have support for any controllers that are dealing with secrets, like seal secrets from Bitnami, Vault controller, and so on. So we have lots of choices. I prefer Mozilla SOAPs because it doesn't involve a controller. The decryption is built into Flux.
Nice.
Okay, so what happened while I was talking? Flagger has already promoted the new version. It gradually shift traffic towards from 5.0.0 to 5.0.1. And now it's at the stage where it's promoting the workload for everybody. And we should see that happening here, hopefully. You can also look at Flagger logs to see what's going on. Everything that you see here, it also exists as Kubernetes events. So you can use those events to monitor. I'm telling the logs because it's easier. So what Flagger did, it has advanced the weight until 30% because that's the maximum weight that I set. Everything worked okay, and now is routing all the traffic to the new primary, which is 5.0.0.1. And if we see here, we see that, okay, everybody now it's on the new version. And this deployment strategy works great for stateful apps, APIs, and so on. But what about front-end apps where you have static assets and so on? You will definitely need something to pin users on a specific version, session affinity. How you can do that with Flagger and AppMesh? So we are going to switch the strategy from Canary to A/B test. And let me do that real quick. So we replace the Canary with the A/B test definition. We bump yet again the version 5.02 this time. And
A/B essentially means we're going to expose certain versions like 5.02 to a certain population, for example, mobile users, or in our case, Firefox, right? So if you're using Firefox or curl, then you should get 5.02, right? That's.
Yep. I'm going to tell Flux to reconcile again. And we can look at the A/B test and see what's different. So we have quite the same thing. There are only two changes here. Instead of a progressive rollout where I'm defining the step weight and the maximum weight, how to route traffic, instead of that, we are defining a match condition for HTTP headers. And we say, we tell AppMesh, hey, look at the user agent header. And if the user agent header contains Firefox or curl, use that user segment to test my app. So instead of routing based on percentage, now I'm routing based on a user segment. So we have applied that. Now we have to see if... okay, so Flagger has detected a new change. We are here in a Chromium browser. Let's see Firefox. Firefox is on 501. Chrome is on 501. What is Flagger doing? Okay, Flagger has run the acceptance tests. And once the acceptance test has passed, then it applies the actual matching rule. And if we look here, okay, Firefox is on 502, all the others 501. Great. So this is how I can do a load test, but an A/B test. But what happens if, let's say, the new version 502 has problems, has issues? Maybe the Firefox users will encounter HTTP errors or high latency and so on. Going to try and simulate errors. So I'm going to use the, let's see if we have the URL here. Okay, we have the URL. So I'm going to use the URL to generate 500 errors, and I'm using curl, so it will be directed to the new version based on that match. And now I'm generating 500 errors. Let's see what Flagger does while those 500 errors pile up on the new version. Okay, we see that Flagger has detected that the success rate is no longer over 99%. It now has dropped to 97%. So what it does, it stops the iterations. And because I've set a threshold of 5 errors, it will retry 5 times. So you can think about it as, I want some error toleration. Maybe, I don't know, maybe the app is slow for a couple of seconds, but I don't want to fail the new version unless that error is consistent. So I'm telling Flagger, hey, keep reading until you reach a maximum threshold. And it failed 3 times, 4 times. And now when it will fail the fifth time, it should stop the whole experiment, the A/B test, and roll back everything to what was before.
All right. So I think that that kind of concludes our look. Are there any last minute you want to wrap up with a point to drive home GitOps?
Yeah. Okay. So
I think we had this
the demo
Flux
is
2
over.
code management.
Rolling back, fail check threshold, canary failed, scale it down. It has routed all the traffic back to the old version, and this is how automatic rollback works. Going back to the demo a little, to the slides. So we use GitHub discussions to discuss Flux version 2 API proposals. If you have ideas how we can make version 2 better, how to integrate Flux with other platforms. Now Flux not being a monolith like before, it's way easier to integrate it with other things, like, I don't know, Tecton, GitHub Actions, and so on. Please join our discussion forum on Flux 2 and let us know what your ideas are, what your experience is with the new version, what you like, what you dislike, and yeah, help us build a better Flux.
Awesome.
That's it.
That was a great demo. I know that automated deploys and rollbacks and all of that is super advanced and cool. I know our audience is gonna love it and want to go out and implement it. So definitely check out Flux. And if you, by the way, I've seen in chat people asking, are we going to be able to watch these videos? Yes, absolutely. We're going to have these videos available on demand, so be watching for that. If you want the presentation material and to for us to let you know when the videos are ready, definitely register with the sign up page. Someone will post that in chat. I think it's been posted throughout the day. So definitely register yourself there, and we'll be sure to reach out when all that is ready. So we're going to take a quick break, about 2 minutes or so, and then up next we're going to have a panel, a discussion panel where we can just ask questions and try and cover at a high level what all is happening in the Kubernetes space. So we'll be right back in a couple of minutes. Thanks.
I usually like to wake up in the wee hours of the morning to get some work done in my study. By the time the family wakes up, I help my wife with the morning routines. As a software engineer, the dream is to be right there at the bleeding edge. The solution.
Oops, we're back. So I didn't know that button would end the video. All right, so break over. Sorry about that. And we will go ahead and start with the panel. Luckily, we have our panelists here. Who just left?
Micah. He'll be back, I'm sure. The internet, it breaks
things. I know,
things.
right? Here he is. So, hey, Micah, welcome back. Good to see you. So,
Hi.
Adam, you want to introduce our additional guests?
Well, actually, I think it would be awesome for them to just go ahead and introduce themselves. We have an esteemed panel here, and let's start with Cornelia. Why don't you? And then we'll progress through the folks here. So, Cornelia, please feel free.
Yeah, I don't know if everybody else can see us shifting. I was on the couch for a moment. It was super cool.
Well, here, let me take care of that.
There we go. Thank you. So hi, everyone. Hello, fellow panelists, as well as the audience. My name is Cornelia Davis. I am the CTO at Weaveworks, and I think we might touch a little bit upon GitOps as the panel goes forward. So that is part of the reason that we're represented here. Weaveworks, in addition to being all about GitOps, is really all about AWS as well. We have a very, very close partnership with AWS for some time. We're the creators of EKS Cuddle, and we continue to maintain that. For me personally, I've been at Weave for about a year, just about a year. Prior to that, I spent the last 7 or 8 years at Pivotal. So I've been working on cloud native application platforms for almost a decade, originally with Cloud Foundry, and then later on for the last 4 years or so, including my time at Weaveworks, have been really heads down and working on Kubernetes. And then I have to, Manning will be really happy if they'll be unhappy if I don't say this. I'm also the author of a book for software architects and developers called Cloud Native Patterns that goes over all of the different patterns that you need to build resilient software in a changing lands, constantly changing, shape-shift, highly distributed.
Nice. And Liz?
Hi, I'm going to assume you can hear me okay. We skipped over the tech chat, so yeah, great. So my name's Liz Rice. I run open source engineering at a company called Aqua Security, where we specialize in security tools for cloud native platforms. And as part of that, I'm involved in projects like KubeBench and KubeHunter. Bob actually mentioned KubeBench in his keynote this morning, which was great. And we were really happy that AWS contributed tests for the EKS benchmark for that. So that was awesome. I am also involved pretty heavily with the CNCF, which for anybody who doesn't know, it's the organization that owns Kubernetes and a lot of the other cloud native projects, and where we all come together to collaborate on these amazing open source projects. And I am the chair of the technical oversight committee for the CNCF. Since Cornelia mentioned her book, I feel I would be remiss not to mention mine.
That's awesome.
She's given me permission, right? So I earlier this year I published a book about container security, which I hope people enjoy.
That's awesome. And Micah, I know you were here earlier this morning, but maybe give us a quick recap of, in case people hadn't joined yet, about you and what you talked to us about this morning.
Yeah, I'm Micah Hausler. I have not authored any books. I don't have anything to sell you. I am an engineer on Amazon EKS. I work on the product and on security. I'm also a Kubernetes contributor and a member of the Kubernetes Product Security Committee.
Nice. And I don't know, Liz, did you get a chance to catch Micah's talk earlier?
I did actually. Yes. So
I mean, since you're an expert in security, let's just give him a grade real quick. What did you think?
11 out of 10, definitely.
Oh, awesome.
Yeah, no,
awesome.
I mean, he gets an extra point for being part of the product security team for Kubernetes, because that is a group of people who are doing really important work in terms of dealing with issues that do come up, because any complex piece of software is gonna, from time to time, somebody will find a vulnerability in it. And it's great that we have, amongst all these people who are essentially volunteers, it's a security team that's behaving like as well as any professional security team. So it's great. Thank you, Micah.
Awesome. So you mentioned software complexity, and yeah, that definitely plays, into how we approach Kubernetes and how we think about EKS. But to help sort of simplify some of that, we just saw a demo on GitOps, and that can really make the complex simple. So what is Weaveworks doing, Cornelia? What is Weaveworks doing to further that, and to just continue to push GitOps and help customers make that transition from the sort of push mindset to the pull mindset?
Yeah, excuse me. So kind of tying that in with this theme of security that we just started with, I love how you just characterized that, Brent, which is around making it more simple. Security is, we've said, quite frankly, for decades that we can't bolt on security as an afterthought, that we have to have our developers and our operations teams doing it. But in order for them to be able to do it effectively, we do need to simplify it just a bit. And certainly GitOps plays a role there. And I think one of the main abstractions that I think will allow us to do this is this idea of a pipeline, of a GitOps pipeline. So if you think about, there's security elements that are handled very early on in the software development lifecycle, all the way back to source code. And then we have these steps where we're doing things like we're doing scans on the software to look for things that we can see at compile time that maybe aren't config, but that are based on the way that we're constructing our code. And being able to tool those security elements into the CI pipeline has been an absolute enabler for developers, so that they don't have to understand these intricate things. They know what linting means, or they know what some of these scanning steps mean, and they can easily tool those into their CI pipelines. Well, what GitOps does is GitOps extends beyond that, and this notion of a GitOps pipeline extends, it takes that same concept and now says, well, actually, let's take that more into the operational side. So we're going to allow you to, during delivery, insert some security related steps. During operations, so these GitOps pipelines go all the way into operations as well, insert these elements into the GitOps pipeline. So the GitOps pipeline is one of, I think, the key enabling factors that allow us to achieve some of this level of security. There's a few others as well, but I'll pause there and see whether Liz and Micah want to, chime in on that point.
Yeah, I mean, I'm a big fan of GitOps. It's not something I have a huge amount of experience with, but just the idea of the separation of concerns, that, being able to restrict access to your cluster by human beings is a hugely valuable thing. As Cornelia was saying about, inserting things like scanning into the pipeline, we just have to have all those things automated. They have to be quick, simple, easy. Otherwise, people won't do them. And if people miss out security steps, then, holes get opened and people will take advantage of them. So yeah, GitOps is a great example of automating all the things.
Yeah, this goes back to like the original DevOps, right? Like, why did DevOps first become popular? Like, because it reduced the manual steps, it enabled automation, and GitOps is kind of the natural progression of that. Making sure that systems are doing the work and that the code is approved by humans, but that you're not having humans checking, oh yeah, hey, that image is good. I took a look at it. Like, no, you want the process to just manage that.
And I like that there's definition that it comes with, like you are defining, this is what I want my end state to look like. And you don't have to get caught up in how to get there. You just say, this is it, code review me, check it in, and then that can get rolled out to wherever it needs to get rolled out to.
Yeah, and I think you nailed it there, Brent, because that's another one of the things that is so important about GitOps, is that GitOps, if you will, is a more opinionated way of achieving some of these goals of DevOps. And as you said, the declarative model is super important with that, because it allows us not just to do automation, but to do automation in a particular way. And so if you've done declarative and you've got all of the automation that is making sure that you're staying that way, it allows you some really interesting, powerful things that, again, are security related, like drift detection.
Oh, yeah.
Is making sure that somebody hasn't kubectl applied or kubectl deleted, kubectl applied and removed some security, some security posture from within the cluster, because you've got an agent that's sitting there and making sure that you've got, things like drift detection, protections from drift detection. And so that's, again, something that GitOps is designed to be able to do, or maybe not designed to be able to do, but certainly enables.
So Liz mentioned, one of her favorite things was that you more or less get to disconnect the humans from the cluster. And I mean, we always talk about security sort of as the thing that, you know, is ideal, the ideal end state. But do you actually have customers, Cornelia or Micah, maybe you've seen some customers that have clusters that, you know, almost no human actually runs kube control against? Like that, it to me is the awesome end state, but is it realistic?
Absolutely. I'll jump in right away and say we totally do. We have customers that that do everything, and they even do their Kubernetes configuration as well as their application workloads. And some of whom are even using the GitOps-based approach to do cluster provisioning, because they're using things like CAPI to do cluster provisioning, all completely driven from the GitOps angle. And I like to refer to kubectl as the modern day equivalent of SSH.
I like that.
100%.
Yeah. And I think that ability to provision your infrastructure, things like the what do you call it, ACK, that kind of controller, the ability to run controllers against other pieces of infrastructure that are going to connect to your cluster, that are going to be services to those clusters and to the workloads. It's so powerful. I think, you know, when somebody first came up with that controller idea, the idea of a reconciliation loop, I imagine, you know, that the number of things that have been built on top of that, and the fact that you can provision so many things and reconcile so many things, it's so powerful and really exciting.
Yeah. What I like about ACK, I want to jump in there, because what ACK does, in essence, to sum it up in like one line, is that all of those AWS services had APIs, and they were all predominantly imperative APIs. Mm-hmm. What ACK fundamentally does is it creates a declarative API. It creates the schema for what is it you want, and then it creates that special form of automation that makes it so, and allows you to do things like drift detection and all of those things. So it's really transforming from an imperative API to a declarative API.
One of the things that I really, to answer your question, Brent, about like lights out, lights out cluster.
Lights out,
right?
That's fancy.
Like a lights out data center, where you don't have people running around doing stuff unless there's something actually wrong. So you have a lights out cluster. One of the things I'm really excited about is CDK and CDKs integration. A project that I'm working on right now internally is a really fun project where I'm actually dogfooding EKS. I'm creating EKS clusters, and I'm using CDK to create the clusters, to install the applications on the clusters, and like developers aren't supposed to touch those clusters. Like those just live. We have our automation around it, and to me, I feel way better about managing my own cluster, knowing that humans aren't touching it. So I think that's going to be a really great set of tools for customers to use as it continues to mature, and like especially the CDK and CDKs integration develops and matures.
I mean, can you, like, Nate? By the way, welcome, Nate.
Thank you. Happy to be back.
I saw that there was some free time on his calendar, and so I went ahead and like just said, "Join us." This is your area too.
You called, and I'm here. Yeah. Oh, I'm very passionate about CDK for Kubernetes, CDKs, and ACK.
So how do these things fit together? Like, you know, we talk about ACK, we talk about CDKs, and CDKs. There's CDKs plus, and then we talk about, you know, GitOps with Flux, and I mean, that's a lot for a beginner to start to think about. So how do they position against each other, with each other? How do you use them together? And
yeah, if I'm really lucky, I'll actually get a slide up here in the next 30 seconds to show you this whole end-to-end picture. But these are not technologies that work against each other in any way. In fact, these are technologies that are designed to work with each other and should be used together And here I go, actually was able to pull this up. If you just give me a second, I'll actually share my screen here and show you kind of a nice high level view. It might not have all the elements in here, but it is a nice high level view of kind of how we think about this. So here's kind of what we think of as the big picture, right? So on here on the left, you have your CDK's application, right? So this is using code, using JavaScript, TypeScript, Python, C. They're adding support for C and Go as well on the CDK's project, and you're using that construct as a developer. You're writing your configuration for the cluster in the same way that you're writing your application code. And so as a developer, I don't need to go out and like study the Kubernetes documentation. I don't need to go out and figure out, hey, at my company, every service needs to be, backed by a load balancer that's configured in this specific way. A central team at my company maybe can figure that all out. They can say, hey, this is what a web service looks like. This is what a job looks like in Kubernetes. Here's the template for that. And we're going to vend that as a code library. And so now as a developer, I can pull that in and say, okay, I know what a web service looks like. I know what a job looks like. I know how a secret is stored, not just in terms of the generic Kubernetes YAML, but in terms of like how my company wants me, how my organization has decided that, we need these certain tags, we need these certain annotations, we need to run Kubernetes in a certain way. So I can pull all that in as a code library. And code libraries are awesome because unlike a lot of other artifact types, they can be versioned and they can be dynamically updated. So if say we need to expose a certain port now, or we need to add a certain tag or a label into our objects, that can be sucked in through a new version, right? Really easily. And then I can just add as a developer, okay, I'm going to use this image and I'm going to add these other different parameters and blah, blah, blah. And I don't need to understand all the boilerplate. So that's CDK's. That's what makes CDK's awesome. And so then you compile that, right? So CDK's compiles out to Kubernetes, conformant Kubernetes standard YAML. And that CLI is our compiler. And then you get this assembly language, you get this YAML, and that's the assembly language of Kubernetes, right? That's what powers this whole experience. And so that's in the middle here, you have this YAML. And now this is where you start plugging into all these other concepts like GitOps. So actually backing up really quickly, where does ACK fit in here, right? So ACK, and we're in the process of doing this, CDKs can actually suck in CRDs and pull in custom resource definitions like ACK. So you can pull those ACK definitions into your CDK's project, and you can define all those AWS resources in code as part of your CDK's project, spit that all out to YAML, right, using CDK's project. And now all this awesome stuff we're talking about that Micah was talking about and Liz and Cornelia about GitOps and how do we actually like now manage our stuff, kind of these lights out clusters, I start with this YAML artifact, and now we have our Git repo that's effectively the, quote unquote, the declarative memory of our system. And then that gets deployed through an automated process. Flux CD is a tool that I know Cornelia and Weaveworks have done a lot of investment in, and that can be running on your cluster, watching the Git repo, and then continuously as you're pushing new versions from source out to the assembly language of YAML, and then that gets continuously deployed, automatically checked and deployed onto your cluster. And of course, there's other elements like checking for correctness as part of that. Checking to make sure that configuration is good. But what's cool about that is that you need those checks for correctness. You need those automated processes on the deployment side and on the commit side. But with also, if you have something like CDKs, you can build the best practices on the source code side and on the generation side. So that's a really awesome system end to end now, because you're building in the right configuration. You're abstracting away the ability to kind of get this wrong from the individual developer, and you're giving them the tools to get it right. And then you're also implementing this with the automated processes that make sure that whatever is actually flowing through that pipeline is right, and what's going on the cluster is correct and doesn't, isn't misconfigured or have vulnerabilities. And so this whole thing works together.
That's something that as I watch the chat scroll by, I see a lot of discussion about, I can do this with Terraform and I can do that with CloudFormation. But I think one of the things that we get with this kind of stack is that next level of moving our opinion left, right? So as you know, the experts in whatever field, maybe it's your security experts, they come up with their opinion on how things should be. They can actually sort of embed that into the CDKs library that your company might be providing to your developers, and that way developers can be successful earlier.
That's right.
So Liz or Cornelia, like what are some, or Micah, are there any success stories from, you know, companies adopting shifting that security to the left, be it through CDKs or some other opinionated tooling? Is there anything there that you can tell us about?
I'm not sure that I could speak to CDKs per se, but the general idea of shifting left and organizations requiring certain like policy-based security decisions and pushing those back to developers, that has become, you know, it's becoming quite commonplace. So we see a lot of organizations where they might have a set of approved base images for the containers, for example, and you know, policy checks as part of the pipeline, because it's all about doing your checks in the pipeline to make sure that you're only building images on those approved based images, and that when you're deploying images, they've been through the appropriate checks, that you're not just deploying images from, you know, random places on the internet. So yeah, absolutely, I would say as we move to cloud native, it kind of part and parcel, you have to incorporate that shift left, that idea of policy-based automation through your CI/CD pipeline.
Do you guys help organizations? So, you know, we're talking a lot today about the people, or sorry, about the technology, but, you know, it's people that sort of drive this. So are there any, you know, standard practices that have developed over how people should be organized, or how, you know, the managers and the leadership should think about, you know, converting to a process like this, where you're shifting, you know, responsibilities to the left and providing tooling rather than trying to catch things with a net at the end of the pipeline? Are there any practices that you could talk about?
I think it is.
No, please go ahead, Liz. Please.
Okay. So it is a huge cultural shift. There is no doubt that if you have a traditional organization with its development team and its ops team and its security team who've never really gotten together, they are going to have to communicate. And, you know, that's why we've come up with lovely catchwords like DevSecOps. You know, that kind of encapsulates this idea that you're going to need some teams with representatives from all of those people to help make that transition. And, you know, yeah, there are lots of folks out there helping large organizations to make that cultural change, because it's not something that you can just sort of flick a switch and do overnight. But the benefit in terms of, at the end of the day, can your business ship functionality quickly? That's why everybody's doing DevOps, and if they're, or DevSecOps, and if they're not, you need that rationale. You need, you know, a business that wants to be able to ship functionality quickly. Otherwise, don't bother. Don't do it.
One other thing I'd add to this is that it seems like a lot of extra work. It can seem that way especially if you're looking at it from, I have an existing process and now I have to change everything. But there's huge wins to be gained, especially if you don't always have this, but if you have something new you're starting it this way from the beginning makes everything easier. Like, seriously, it makes everything easier. Like you think that it's going to be a lot of setup, and there is some setup at the beginning, but once you have it in place, you just have something you can roll with, and there's huge value gain from that.
Yeah, the thing that I would add into this conversation is that I think that there's an organizational structure And forgive me, it's going to go a little techie as well. And I know we're trying to talk not just about the tools, but there is this organizational structure I think that we're seeing folks be very successful with. And it's this notion of a platform team and an application team. And so it's absolutely true that we need to take these silos that used to exist and we need to get them working together. But the answer isn't as simple as, well, create a 2-pizza team that has a security person and it has a, compliance person and it has a da 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 da. You need to leverage things like platform to be able to put certain things into the platform. Again, back to what we started with, which is to create these appropriate abstractions for the application teams to do their work. And so I always like to say that the goal is to enable the application teams to just move at light speed while maintaining those enterprise controls. And so using this organizational structure of the platform team are the owners of the enterprise controls, and the app teams are the owners of rapid delivery. And if you go all the way back to what Dora has talked about, Dora talked about these developer productivity and operational efficiency buckets. And those really map nicely if you can come up with these organizational structures of platform responsibilities, platform teams, and app responsibilities.
I want to add that I know we've talked a lot about CDKs, but Cornelia, specifically to your point, when you have a platform team that can, traditionally it's been a model where the development teams need to find a config to deploy to an environment. So they go searching around, here's a manifest I can take and hack on and hopefully it works, right? Whereas when we talk CDKs now and we shift, now you have a team that can build a reusable module that a development team can simply import in their code, and all the best practices are built into that module. So now there's no requirement of getting acceptance or approval from a platform team. You're truly working together because CDKs is enabling developers to move at their pace by using best practice modules built in. So I think, again, it's just moving up the stack and eliminating that complexity and the walls and the silos. So.
Yeah, and I would add to that, actually. I would take Nate's diagram, which was really super diagram, and I would drill into that a little bit and suggest that the role that Git plays, the role that an immutable version store plays, is not just in the assembly language, which is the YAML in this case, but it's also in the CDKs. And then that compilation step of compiling from the CDKs, which, by the way, one of the other things I want to say that's really important, and again ties back to this, security, is that what's so great about something like CDKs is it gives you a different programming model. The programming model of YAML is, I love the analogy, Nate, it's the assembly language, right? And so that puts this huge cognitive burden. And so now I've got less cognitive cycles left to actually solve the security problem the right way. I mean, we all know that we've heard about breaches because somebody didn't understand how to configure IAM the right way. So they were like down in the weeds and they did one thing and it had these cascading effects. So if we have a different programming model that creates a better frame in which I can think and configure things. And then I actually store the CDKs in a Git repo. And as a part of my GitOps pipeline, I'm doing that compilation step to the assembly. I can actually start to trace that across. That doesn't mean it goes all in the same Git repo. Git repos play dual roles in GitOps. They play the role of user interface for, pull requests and things like that. But they also play this role of versioned immutable distributed store. And so I think it plays that role in kind of a more detailed picture of what you showed, Nate.
I think you're nailing it, Cornelia. I mean, this is such a critical point. And I think that thinking about these projects, it's not that we're trying to replace YAML. It's not that you're ever going to replace that assembly language. And you have legions of Kubernetes developers and operations folks that are really good at YAML and understand Kubernetes YAML and how to write it. And that is awesome. I think that's actually what also makes the idea of putting this all through a Git repo so powerful is that whether you have a team that maybe are not experts or want to use templates and don't want to write everything in YAML and are using something like CDKs to generate that YAML, or you have some, expert folks that like have been using Kubernetes for years and really want to just like, they work best if they're going straight into the YAML. Those people can come together. Like you can have different teams operating on the same set of clusters, and that all gets put together in that language in the Git repo, and it all gets standardized through the YAML. So that is the assembly language of Kubernetes. There's no replacing that, but these tools extend and leverage that. And that's, I think, what's really cool is that this stuff all comes together. And I think what I love about that slide and what I love about this discussion is that we talk about a lot of this stuff in isolation. We talk about GitOps, we talk about immutability, we talk about this YAML code generation, but really these are not. It's that premise of you have to choose one or choose the other. That's a completely false premise. These things all form this really powerful system. And to kind of what Liz is talking about, I mean, that is the shift left, right? Like in the diagram, you're moving things out of the processor, you're moving things out of kind of defining things directly on the processor, on the cluster, and you're moving that all left, you're moving the practices left, and that allows for standardization and better controls, and ultimately, in addition to those things, it actually allows for acceleration, because it allows those development teams to actually offload the cognitive overhead of making sure everything's set up and merged correctly and is done right into automated processes, which not only improves your posture for operations and security, but also lets you go faster, because the individual development teams don't have to worry about, hey, did I get all these controls set up correctly? Those things should just be built in. And I think that's probably the right way for us to operate as technology teams.
It's almost like it gives an organization the ability to scale their expertise, right? So they're going to have, imagine a tech organization inside a company. They have one or a handful of people who are super powerful with security. They are on top of security. But if you were to try and reorganize them into, to Cornelia's earlier point, into a 2-pizza team, they may not be able to spread very far, right? There just aren't enough of them. But if you give them the power instead to just bake in their expertise into the tooling and then let everyone be able to pull that tooling and use it, then their expertise gets propagated throughout the entire organization. So like when I think of Micah's presentation earlier this morning, one of the most valuable bits was at the very end when he said, at minimum, you need to be doing these things on your cluster. And, some organizations, they would let you build your cluster and then they would come along with their checklist. Did you do? Did you do? Did you do? And instead, you could say, here's how you build a cluster, shift all of that to the left, and we're going to make it super easy so that you're motivated to use it. And it's going to come built in with all of those things that we normally look for.
I think we're definitely seeing quite a lot of innovation in this idea of platform, a layer of abstraction that the business developers don't, the developers for the business apps don't need to concern themselves with what's underneath that abstraction. And we're seeing projects like Backstage, which recently joined the CNCF as a sandbox project, doing precisely that, sort of taking the learnings from Spotify's sort of experience of having a platform team and sharing that with the community. I think we'll see a lot more instances of things like that and innovations like CDKs, allowing people to get away from that. I really like this sort of mental model of Kubernetes as a distributed operating system and YAML as the assembly or the system calls or something like that. It does work well. And developers shouldn't need to know that level of detail.
So when I think about, security, another thing that I think about is CIS benchmark. And I know my coworker Pavan did a lot of work to get CIS benchmark working for EKS. But what, just more broadly, what does CIS benchmark do for users, and how do they think about, using it to, what do they do with it? What's its use case?
Yeah, so just for anybody who hadn't come across it before, CIS is the Center for Internet Security, and they publish a lot of different benchmarks for different software, pieces of software, with recommendations for how to configure it according to best security practices. And there's a benchmark for Kubernetes, and there's now a kind of flavor of that benchmark for EKS. So it's very similar, related to, but has some EKS specific tests. And there are a couple of other similar kind of distribution specific versions as well. And I think there are two ways of using those benchmarks. There is the kind of compliance tick box mentality of like, I just need to comply with the benchmark. I need a tool that tells me, yep, it works, and that's great. Some of those recommendations do, lend themselves to a little bit of, you might want to think about them a little bit more carefully, or some of them will say things like minimize your use of, I don't know, privileged containers would be an example. You may have some examples where you have some apps that for some reason have to be privileged. I hope not, but maybe you do. And, and so you're going to have to apply some thought. You can't necessarily just completely automate the whole thing, but the CIS benchmark will give you a very good starting point. I think also today, more and more of the default settings from Kubernetes are going to be pretty compliant. So there's less work to be done to make your Kubernetes cluster compliant. And I think EKS will be, at least in the control plane, compliant out of the box, if I'm not mistaken.
What I really like about what you just said there, Liz, is that you said that the default is going to apply to those, but implied in that is that there are configuration settings that deliver those benchmarks. And if we take those configuration settings, well, those configuration settings to a large extent, because everything, even configuration of Kubernetes, aside from the API server flags, but even those are being declared in things like cluster API, everything can be declared. And so you could actually, I can imagine, and I'm not an expert on these benchmarks, but I can imagine modules, maybe even CDK's modules, that implement various benchmarks from CIS. And then we use GitOps to do, the whole process, and you get this repeatable system, repeatable and secure system. So that sure seems like a pretty idealistic way of doing things.
With no humans connected to it.
Lights out. Lights out Kubernetes cluster.
I love that. Have I just been oblivious? Is that a real term, or did we just make that up?
No, it's a real term for data centers. Like you have the lights out data center, people aren't in it, and so we're just taking it to Kubernetes because it's the same thing, right?
I think that happened here on the show.
The lights out Kubernetes.
Lights out Kubernetes.
Yeah.
Boom. Heard it here, folks.
Indeed.
That's awesome. Okay, so KubeCon is happening this week. What's everyone looking forward to? Who has talks? What are you hoping to see at the upcoming KubeCon?
So I have a talk, and I will start because it's like the last talk on the last day, which is like the worst slot, except for I'm thinking in a virtual. It's not actually the last. It's on the last day, but I think it's right after lunch. And a physical conference is like the worst because everybody's on their way to the train station and the airport, but nobody's going to the train station or airport. So I'm hoping folks will show up. But I'm talking about GitOps patterns. And the title of the talk is GitOps is likely more than you think it is. So it's some of the themes we've talked about. It's not just automation, it's a special type of automation, et cetera, et cetera. But then of course, I'm excited about virtually the entire program.
Nice. Anyone else?
I think I might have a talk even later on Friday. I'm not sure.
You're the chair of the TOC, so
we have a TOC panel, public panel. It happens every KubeCon, and I'm pretty sure that's pretty much. It's usually the last thing, definitely checking out by the time they've come to that. But I have a keynote on Friday where I'm doing predictions from the TOC. Ooh. So we've come up with a few. Mostly just sort of trying to extrapolate from some of the submissions that we've seen over the last year or so, and think of a few things. I'm sure there will be things that that we haven't included, but we've got 5 technologies to watch, so look out for that. And then I'm also talking on, I think, Thursday about a project called Starboard that kind of does some of this, using the operator model to run security tools. So yeah, more automation, but for just running tools over your running cluster. Yeah.
Cool.
Nice. Oh. And I also have a talk, of course, shameless plug for CDK for Kubernetes. We'll be talking about that. Myself and Elad Ben Israel, who's our principal engineer at AWS, who helped build this project and create this project. We're talking about that this Thursday at 4:50 Eastern. So join us for that. We'll be talking. It's actually a workshop demo. So there's I talked for a bit and kind of show some of the slides that we just were looking at, that kind of idea of how does this connect together for GitOps and other types of architecture, like what's the pattern. And then there's actually about a full end-to-end, how do you actually set this up? How do you use CDKs in production? How do you get this going? And so it's going to be a great talk. Really excited. Would love for you guys to join. And this is recent news for us, but CDKs will be joining the CNCF as a sandbox project, and we're in the process of onboarding that. We're accepted by the TSC, and we'll be joining that. So look for that to show up as a CNCF sandbox project. We're really excited because though this technology comes from AWS and we originated it, it works for, it's a generalizable Kubernetes technology, and we're already seeing this used by Kubernetes users across lots of different environments and clouds. And so excited to be giving that as part of KubeCon, and I'll join Cornelia in saying I'm excited about the whole program after that. Like, this is always such a fun week, and I'm still bummed I don't get to go to Boston. I love Boston, but I'm really impressed with the work that this team has done and with the CNCF has done to put on this awesome virtual event, and I'm just really looking forward to the entire week.
Awesome. Micah?
Yeah, I'd say the same. I'd say the same thing as Nate. Like I really will miss this year the in-person aspect of it. I think the talks are always great. One of my favorite parts about KubeCon is the SIG meetings and getting to have just face-to-face time with these people that you interact with online the rest of the year. But I think I'm hopeful, and I think a lot of folks are, that maybe next year we can actually have that. But I do think that this is going to be a great virtual event. I think KubeCon EU showed that this can be done really well virtually.
Yeah. Nice. All right.
Maybe just to echo on that, like, I encourage everybody, if they're going to KubeCon, get interactive, particularly in Slack. Everybody is there and everybody really wants to hear from you and talk to you and your ideas. So do get stuck in there.
100%. Yes, absolutely. So thank you everyone for joining. I think this was an awesome panel, and I hope the audience got a lot out of it. So we're going to take another quick break, and when we come back, we're going to talk to a couple of new AWS employees and talk to them about what it's like to work at AWS, and just, we always see questions like that, and so we thought, hey, let's just go ahead and let's get out and talk about it. So join us. Make sure to stick around. We'll be right back. Thanks, everyone.
I like to wake up early in the morning because I do my best thinking. It is super important that we have diversity in our business. I meet with my interns daily, and it is important to us that they are more than technically strong. We need them to be people strong as well. The key is actually predicting what a customer is going to need and then work backward from there. True joy to work with passionate people. You can see people multiplying each other's productivity. Around 2 or 3 o'clock, we'll often go to the deck and have a bowl of ice cream. I'm Ridley Huang. I'm a principal software engineer at AWS.
Skyscanner is a global travel search company. We have over 100 million users a month relying on us to find their travel needs.
Customers cannot accept that our site is offline for anything more than a few seconds. So it's super critical that we are available all the time, and this was one of the main driving forces for moving to AWS. we were always playing catch up. The data centers were getting close to capacity constantly, and we were constantly having to add new hardware and play catch up with our ever increasing growth.
Skyscanner engaged with AWS from day one. We got support from our account team, the solution architects, and they provide us with some great support to kickstart our migration. This wasn't a basic lift and shift. We spent 3 years doing re-architecting, and then the last year doing lift and shift and re-platforming.
At Skyscanner, our container environment is spread across Amazon ECS and Kubernetes. We have over 700 services deployed onto these clusters, and on any given day, we'll be running sort of 8,000 to 9,000 different tasks and pods on the clusters. There's some really innovative services that are available on AWS, and they certainly help Skyscanner to power their business.
Skyscanner initially used on-demand instances. We quickly moved to reserved instances for 70% of our workload, but then to drive down costs further, we use Spot. Skyscanner's entire online platform uses Amazon EC2 Spot instances. Amazon EC2 Spot instances saved us 70% per core and also provided us the flexibility to move our workloads globally.
Kubernetes and Spot is a great fit, especially if you're running stateless microservices. The fact that the scheduler is designed inside of Kubernetes to move instances of services about, you can deal with the issues that you have with capacity. Using a traditional data center, it used to take us 6 to 7 weeks to launch a new service. On AWS, it can take us 15 minutes. We have thousands of services running in AWS versus a few hundred in data center, and that means more products and new features for travelers.
Migrating to AWS has enabled Skyscanner to focus on innovating for the traveler rather than managing IT infrastructure.
Hey, we're back. Adam. Sorry.
Hey, everybody. So, yeah, thank you. So now we're going to talk about what it's like to work with us, and we have some folks here that I'll let them do the introductions. Obviously, we've met Bob before. We've seen Bob here, but why don't we start with you, Asha? Just say hello, introduce yourself.
Awesome. Thank you, Adam, Brent, for having me here today. Hi, guys. My name is Asha Chakrabarty. I've been with AWS for, I want to say, almost 6.5 years now. Started out as a solutions architect, and now I'm working on the container services go-to-market team. Thank you for having me.
Thanks for being here. Chandler?
Yeah, thanks, Adam. My name's Chandler. I'm actually the newbie of the group. I think I've been here 4 months now. I'm working with Bob on some new Kubernetes stuff that we're doing. And yeah, thanks for having me here.
Fantastic. And Bob, should we maybe have another intro? I don't think you need one, but why not?
Intro. Hi, sure. I'm Bob Wise. I'm the Kubernetes and App Networking GM for AWS.
Awesome.
Fantastic.
So I know a couple of you are new to the team. Bob, you've been around for a while now, but we have this pandemic going on, and who was hired and onboarded during the pandemic? Anyone?
I was.
What was that like? I mean, it has to be weird.
It was definitely weird. I think the nice thing is our team's going to be virtual here, the team I'm working on specifically. So you're kind of just clicking into what's going to be normal for a long time. But I did end up moving to Seattle during the pandemic. That was interesting. So that was not very easy to coordinate, but it was done. And it was actually a little bit easier than my wife and I thought it would be. But yeah, I mean, you're getting onboarding. There's a lot of more face-to-face Zoom meetings, or we use Chime here, and you make it work. I think it's not as bad as some people might think finding a new job during the pandemic. And yeah, you figure it out, you make it work.
Is there anyone that you work closely with that you've still never met in person?
Everybody, I think. I think I've never met Bob in person. I saw Bob one time at reInvent last year, but it was like across the room, and someone was like, "That's Bob Wise," and I was like, "Oh, okay, that's who Bob is." But he's never met me in person.
That's hilarious. Welcome, Romain Jordan, by the way. He also is new to AWS. As of when did you join, Romain?
Actually, 3 months ago, August 17th. So yeah.
Maybe introduce yourself since everyone else has.
Sure. So yeah, I joined AWS recently as the senior manager for the developer advocate team for the container services. So I've been experiencing the same than Chandler, being onboarding during the pandemic, doing all the interviews also in a virtual form factor fashion. So that was yeah, a good experience so far. I mean, what I really like is the way the onboarding is done here. Make it very efficient. So I had a lot of opportunities to engage with many people, and as Chandler, I'm in the very same situation. I've never met in person any of my team, including you, both of you. So, so that's a bit weird, but actually, Shime and the video conferences help to bridge the gap. So hopefully. We'll be able to meet more people soon, but actually the fact that we have such a great system in-house to meet people, I think it helps.
Awesome. And Asha, one of the things that I hear from candidates a lot is they're wondering what is the culture like at AWS, and so can you give us an idea what's it like to work at AWS?
So I want to say it's I'd like to kind of categorize it or make it analogous to it's like a huge umbrella of scrappy startups.
Yes.
I think scrappy would be probably the right word to use here. You get a lot of autonomy to drive opportunities and have the opportunity to also make impactful to basically work on impactful projects both for customers and for the business. I think one of the things that struck me as really different and new when I joined Amazon was we crystallized, a lot of our thinking, thoughts, data-driven analysis into these, massive 6-page narratives. That kind of formed the basis for how we express our ideas and how we garner support for them and get funding for new projects and so on and so forth. But I think what's powerful about that is it forces you to really think at a deeper level, whether it's you trying to pitch a new product, solutions, specific capabilities or features that you want to build on behalf of customers. You're empowered to express that and gain leadership support for driving those things. And so to me, that's kind of akin to, you being able to wear multiple hats and drive, the impact at whatever scale you want. I don't think I've experienced that level of autonomy or ownership at any one of my previous opportunities. So I think to me, it's a very scrappy culture. You do have a lot of autonomy. You do have opportunities for owning whatever it is that's that you're passionate about. So it's scary in the beginning. It's such a flat hierarchy, right? Like there's I can ping Bob and bug him. Bob will ping me and bug me. So I'm just kidding, Bob. You never bug me. But there's really no stopping you from interacting with your GMs, your VPs. You've got an idea, you've got things that you want to do, go for it. So that's kind of what after 6.5 years, at least that's kind of how I describe the culture.
That's awesome. So I have a question from chat for Bob, maybe, since he's been here so long. Short Dude Games wants to know, what are these 6-page narratives being referred to? So maybe tell us, like, how does AWS use docs and narratives to help drive decision making?
Yeah, I think one of the things that you quickly discover when you come to work at AWS is the importance of good, clear writing. And one of the principles of meetings is to ensure that everybody gets on the same page, if I dare use that word here in this context. You can, like, Jeff Bezos actually has talks on this. You can find on YouTube that are pretty amazing. How important it is that you not go into a meeting without everybody understanding what the context is, and the way you do that is you all sit together for the start of the meeting and you read a document together, and the better the doc is, the better the meeting goes, naturally, because that is the foundation on which a lot of decisions are made. The 6 pages is pretty strictly adhered to because you only have a certain amount of time, and so part of the discipline is being able to condense what may be a long, complicated problem into 6 pages or less. By the way, we also do 1-pagers is another a common doc format for smaller things. And I'm not sure who to attribute it to, but the statement about sorry this letter is so long, I didn't have the time to make it short, is especially true in this case. So really being able to condense something down into 6 pages or 1 page in a clear way is really critical to making progress, and it gets everybody lined up. So I am this is one of the things that I have become a huge fan of. I didn't really understand this idea of how to work before I joined AWS, but it's also interesting to me to see how many other people outside AWS, often this habit is taken by former AWS employees into their company, have been adopting that approach because they find it so effective.
Nice. That's fantastic. And I just, Micah Hausler was in the chat saying, I work for Chandler and I haven't met him in person yet. So that's another.
And what's interesting on the docs thing also is how many times have you read a 6-page doc, like 3 times in a day, and then, maybe 18 different 6-page docs in a week. Like, you would never do that. Typically, you never have time. But what was surprising for me coming here is that because we allocate the time at the beginning of the meeting, you actually end up learning so much. And you're in meetings because maybe you're there just for context to learn about, a product or a feature some other team is building, but you end up learning 6 pages about their product or feature. And so I think the learning opportunity for an individual going through that process is huge. And that was one thing that I quickly became a fan of as well.
I think the discussion afterwards is also something. These docs drive some extremely interesting discussions and debates. I learn a lot from those discussions and debates in terms of perspectives that I didn't even consider, the questions that get asked, and I think I don't know how it was for Chandler or Romain, since you guys just joined you, but I remember when I joined and I entered into my first doc read meeting and I had no clue what was going on. Everyone was silent. Typically you enter a meeting and you're like, okay, aren't we supposed to be talking? And then you slowly start to understand, okay, you read first, and then you discuss, which makes a lot of sense because people aren't going to have the time. If you just give a doc to somebody and expect them to read it, given everyone's schedule, it's so tough. I think the idea of having that read happen collectively and then discussing it is a much better method.
So one of the questions I saw scroll by in chat was, why not just ask everyone to read the doc before the meeting?
Yeah, that rarely happens.
Right?
It's like when you get into that hour that you have, like after 6 years, you just become a really fast reader and you become really good at massive context switching. But it's a great way because you're not expected to read the doc before. So in a way, when you read the doc for the first time, you get some real vanilla comments and descriptions about, oh, okay, this is how my doc landed with everybody. So it gives you as a writer a really good view into, okay, how can I improve this next time? How can I make sure I'm landing the points that I need to land with more clarity? And of course, it definitely saves everyone time because you're giving everyone that period to read.
Cool.
All right, can I do a little subject change here, do a little transition, and I want to talk about interviewing. So, what are some interviewing tips if I'm, I got my interview scheduled, I first the phone interview, I'm really excited, or even, I'm going on site. Well, not on site anymore, via remote. Chandler, what are, from your experience, maybe what are some tips that you have that you could share with the audience going into an interview here?
Yeah, gladly. Shameless plug. My team is hiring, so take these tips and apply them. But no, I think interviewing here was super interesting on the outside, and then when you join and you go through the training, and it's actually quite a bit of training to do interviews here, you start to understand it a lot better. So some of the things I wish I would have known, first is it's almost solely based around the leadership principles. So the Amazon leadership principles, there's 14 of them, and they are embedded in just pretty much all parts of the culture here. And it starts with interviewing. And so the easiest tip is you don't really need to know like what the questions you're going to get asked are, because the questions are going to be 100% based around the leadership principles. So one thing I wish I had done a little bit better was actually write down some examples from my past of when one of those leadership principles applied to what I was doing or a problem that I encountered or something like that, so that I just had a good list of things to pull from. So that would be probably my biggest tip for people interviewing, is read the leadership principles and then write down examples and multiple examples for each one, so you don't reuse examples in multiple interviews. And really just think about those times from your past that you can show proficiency in one of those leadership principles. That's probably my biggest tip. And then obviously, if you're applying for a software engineering role, it's pretty standard, I think, from that perspective. You need to study your data structures, your algorithms, like your standard coding problems. We're trained to not ask like tricky questions or questions that are designed to stump people. Like, that's not the point. It's really all about just being objective as possible and making sure that you have the skills needed to fill that role. And I think most people probably do, even though they might think that they don't, or they might think they might fail that interview. They should just interview anyway, because it's really not, it's not as nerve-wracking as it sounds. And so my advice is to apply to roles on my team. And then once you've done that, study the leadership principles, and write down those examples. I think that's the best advice I probably could give on this.
Nice. I like the on my team toss in there. That was good. What?
I was just going to actually pose to maybe someone else, like, Romain. Yep. You're also just freshly hired here. Maybe talk about some of your tips.
So I was going to say exactly the same that Chandler. I'm hiring. So there's an open position in my team at the moment. So have a look at it, and feel free to apply. One of the things that I did for my prep work was actually to prepare. I think I've never been so prepared to go on an interview, and part of it was because I read about the interview mechanism at Amazon. And I thought that I would need to have great examples ready. So I did that work. I write down a lot of examples. I try to think about, okay, what were my achievements so far, and how can I tell a story about them in the context of the leadership principles. This was really helpful for me to get ready. I feel also that at least my experience as a candidate, but also now on the other side of the fence, is that I feel that interviewers are keen to understand your achievement. So of course, we encourage people to follow the STAR model, the situation, task, action, results model, to explain what you have achieved so far. But if you are a bit lost in your explanation as a candidate, interviewers will try to ask you, questions to better understand what you have done. You, not we as a team, but you specifically as an individual, what you did and how you drove results. So that's a good lesson learned. And so if you are to apply at AWS, get ready.
Cool. So I feel like everyone needs to have the same answer for this one, but what is your favorite leadership principle?
So I start. So
Okay.
customer obsession is, of course, top of mind to anybody at Amazon and AWS specifically. I think it's great because and every time you write something, every time you do something, you say, okay, you take a step back and say, how does it help my customers eventually? And is it what I say too service centric or too my team centric? And is there an opportunity to reframe it in the customer eyes? So working to backwards from customers is always the best approach, and this is something which is very helpful for us to drive the business. And there are many other leadership principles that are really interesting. I like the invent and simplify leadership. I think there's a great opportunity, specifically in this market of containers, which is growing and maturing. There's so much we could do to simplify things for our customers. So if you are like this, feel free to apply.
Nice. Good answer. Does anyone else disagree that that's the number one leadership principle?
Well, I think it's interesting. I mean, you tie it back to what we were talking about at the beginning with these 6-pagers, and that's actually what they're designed to do. Is we have a whole process of working backwards from what the customer is asking for and delivering that as a product or a feature, and that's what those 6-page documents are designed to do. At least some of them are. So I think that's the most obvious answer is customer obsession. But I also noticed that a lot of the leadership principles you have to figure out how to balance them against each other. You might have something that's like deliver results and insist on the highest standards, and you have to figure out kind of how to go fast and not break things. And so I think that's kind of how the principles were designed. And it's not necessarily like you can always just take one and prop it up over the others. You really have to evaluate, your decisions against all of them.
Nice. So there's an interesting question posed in the chat. What's the most difficult leadership principle when joining the company? And I'm guessing it's a different answer for everyone, but I don't know. What are your thoughts? What was difficult for you to adjust to?
I think for me, at least, it may not. It's challenging, but I think it was think big. You're every day you're working with customers, you're understanding more about how they use AWS services and products, you're trying to solve their problems, but it takes some discipline to pull yourself out of your kind of day-to-day to really identify trends, patterns, things that you're seeing, because you're talking to so many customers, you're immersed in all of the new things that AWS is working on. And not only that, just trying to keep up with our own set of feature launches and service launches. It does get, it's like information overload. And so, I think to be able to really identify those crucial think big ideas, take some discipline on your part to pull yourself away for a little bit and just give yourself some time to think about how we can innovate or invent and simplify or build the next big thing for our customer base. So I'd probably say that was the most challenging one for me.
Awesome. So we only have a few minutes left. I want to make sure that we've pasted a link or two in chat for job openings, but what kind of openings are there? Give us your best pitch. What are you hiring for?
Yeah, so I would say, well, if you go to Amazon.jobs, you'll see all the open positions, and there's a ton on there. But for my team specifically, you would search for Kubernetes or the EKS team or containers. And the stuff that we're looking for are developers who are interested mainly in distributed systems. Ideally, you have some experience in distributed systems of some kind. So either Kubernetes itself, which is great, but that's not necessarily a hard requirement. If you've worked on other distributed systems, or you feel like you understand distributed system concepts really well, that's a great team to apply to. And then the other nice to haves are like obviously Golang. We do a lot of Golang here, and any other language similar to that. But again, not a hard requirement. So I think what we're looking for at the end of the day are really good developers. And I think that's what every team at Amazon's really looking for. And good people and good developers. I mean, I think that's the way we hire.
Awesome. Romain?
Yeah, so I think what we are looking for as DAs are practitioners. So people who are, on their keyboard and are building stuff, and they know what is the pain of building an application and using the container, so they can relate with other people. So our mission is to drive adoption, not only awareness, but adoption. So help people understanding how they can use the technology in the cloud to build new application. And the other aspect of it is how to improve our own services. And for that, we need a lot of empathy. We need to be able to listen to people to understand what are their pains and what they are trying to achieve, so we can discuss with Chandler and Bob's teams, so to enhance our product eventually.
Nice. Asha, we shared your link, but at the same time, what are you looking for?
Oh, thank you for that, for sharing the link, by the way. So on the go-to-market team, we work really closely with our product, service developer advocate teams to essentially go out there and help scale adoption globally of all of our container services. And so, we build go-to-market plans that we help define, market segments, the customer base that that we're looking to increase adoption in, set strategic business strategies around how to go about making sure that our customers can adopt our container services much more seamlessly. So a lot of the critical competencies that we're looking for, is a lot of think big, a lot of bias for action, ownership, and deliver results. Someone with a really good business development, go-to-market background, but also also with product experience, and who is a technologist, someone who has the technical understanding to be able to essentially understand what our customers need, and also experience with impactful customer interactions. We want, things that would make you successful in this role is the ability to build deep relationships with both our internal teams, our product teams, as well as engineering, as well as the field and your customers. Being able to embrace the massive amount of internal stakeholders that you're going to have to work with, because building a business involves a number of different teams. Being able to leverage the field to be able to scale adoption of our container services. And of course, being able to build scalable mechanisms so that you're able to essentially scale your role throughout the world globally. So I think it's just the right mix of business development acumen as well as technical acumen.
Nice. All right. So I think that that was a great summary of what's happening hiring wise, and hopefully you got some great tips on what to expect going through the process. When we come back, we're going to Bob's going to stay around. We're going to recap what we've announced today, and then we're going to maybe take some questions from the audience. So get ready, and we're going to be back in about 2 minutes after this break. See you in a second.
My mornings head upstairs to the Frog, finished room over garage. It's a Southern thing. We had our team huddle this morning, and it's always fun. So in professional services, we get creative. It's a lot of thinking on our feet, with workarounds that we can implement to support our customers. My day typically ends around 5:30. I love to ride my bike, take a bike ride around the neighborhood with my son. My name is Jennifer Letourneau. I am a practice manager in professional services at AWS.
Hey, it's Adam and Brent, and we wanted to let you know that if you're looking for more live or on-demand container content,
you should subscribe to our YouTube channel.
Head on over to youtube.com/containersfromthecouch and also check out our website at containersfromthecouch.com. Thanks.
Thank you.
China.
Takoyaki.
Right. Wow. I mean, we just keep adding people to the couch. This is amazing. I love it.
Do you ever find any change left in the couch from previous guests?
Dollar bills. Just dollar bills.
Popsicle sticks.
Popsicle sticks. Nice. Okay, so we have some newcomers. Not necessarily new to the show, but new today. So let's introduce, we'll start did I get the direct? No. All the way over, Pavan Mystery. Tell us about yourself.
Yeah, hey everyone. Thanks, Brent, Adam. You're doing a great job. Enjoying the show again. So, hi everyone, Bob and Jesse. Hello, good to see you again. Yeah, so I'm Pavan Mystery. I'm a developer advocate here with AWS Container Services. And I've been with AWS for a bit more than 6 years now, mainly security. So I worked with AWS security, and I was a specialist security solutions architect before in Europe, so serving our European customers and solving their security challenges. And what interested me was the great work we're doing at Container Services team and the security challenges our customers were facing. So I was getting questions around Fargate and security and all the good things around container security. So right now, my focus is around educating and working with our customers to help them understand the features, the cool tools that we are building around CDK. So lots of conversations around CDK in general, but overall, that's what I'm doing right now. And we have a session in like probably 15 minutes on a few things which are interesting. So look forward to covering that.
Nice. And Jesse, tell us about yourself.
Hey, y'all. So you can tell I'm also a DA in the container services team because we all have the wooden background. So trivia question for our regular viewers, which one of us doesn't have a green screen right now?
Oh.
It's this guy. So this is actually a photo of Brent's actual wall, which is just fantastic.
What kind of trivia question is that when you answer it a millisecond after you ask it? Come on.
I don't know. There's like 7,000 people out there. I didn't expect, Anyway, so yeah, I focus on EKS and Kubernetes in the DA team, and I come from an OS development background. So if you want me to ever wax poetic about container runtimes and that kind of junk, I'm here for it.
Nice.
But yeah, just super psyched with all the stuff that we've been working on and we've been building for weeks and months, and we're here and we're talking about it. It's so rad. It's great.
Well, so one of the things, or actually, Bob had a lot of announcements this morning. He told us about cluster auto tuning and the improvements that are being made there. Some exciting stuff. He told us about Carpenter, and then he told us about MTLS. And I'm not sure that by the time we got there that it really resonated. So I was wondering, Pavan, can you just talk to us a little bit about Why is MTLS so important, and why have people been asking for it, and what's it going to do for people?
I'm sure that's a great question, Brent. So we, as we have discussed before, we share our roadmap with our customers and listen to our customers. We talked about leadership principles and how we are kind of focused on our customers' requirements. And through our roadmap, what we have seen is security is a top priority, not just for us, but for our customers as well. Now, MTLS and our previous launch related to end-to-end encryption within AppMesh were kind of really highly rated and highly requested features on AppMesh and other services from our customers. So if you look at the number of likes and follow-ups you get on, we were getting on the roadmap, and the follow-up questions as well, they were kind of the customers were asking for the features. What MTLS brings and the general integration with Spiffy, Inspire, and the accepted open source projects around giving identity to services and objects. So we have traditionally provided identities to resources which are native to AWS and to users who are accessing resources within AWS. But this whole concept around with Kubernetes, where you have resources within Kubernetes and to give them identity so that you have an extra layer of security. So when you have a microservices environment and you're working with a number of services coming up and down and scaling, you want to ensure that the services that your services are interacting with, they are speaking to them correctly. Like in a physical world, we have the faces and our own mechanisms to identify the person we are speaking to and sharing the information with. However, in Kubernetes, that's difficult. So in case of a service talking to other service and sharing some information with them, I need to find out whether that service has the right identity. Am I speaking to the right service, or it's been hacked by a hacker and it's posing at someone else? So I think that's what overall MTLS does for our customer workloads.
That makes a lot of sense. And Bob, you went through a lot in your keynote, and there were, like I said, there were a lot of cool announcements. What were some of the key takeaways, if you wanted to sort of summarize or recap for the audience? What should they focus on?
Well, different container days, we end up with sort of different themes, and I would say one of the themes for this one is scale and scaling up, or scaling up and down. And so two of the announcements had to do with like two different very important aspects of that. And I think I used the control plane word for phrase earlier in the talk, and I should remember that when I first joined AWS, I heard control plane, data plane terms thrown around quite a lot, and that was a little unusual to me. I hadn't actually heard the phrases used that way, and now I'm sort of in the habit of just talking about it that way. So maybe just a quick clarification for folks, like what does it we mean when we say those things? And so in this case, I was talking about the control elements of the Kubernetes cluster. The API server includes etcd, the data store. It's essentially the brains of the robot that actually make the thing work. And then in AWS, we would call data plane the nodes. So all of the worker nodes where the customer's workload actually runs. And those two things are important and somewhat related, but also somewhat decoupled from each other. So, but if you're scaling clusters up and down a lot, you've got two concerns. One is, how can I make sure that the control plane piece, the thing that's handling all of the requests that are coming back and forth from applications, from a user doing, using kubectl, from CD pipelines that are asking the system to do things, monitoring tools like asking for stats. So you have load on kind of the brains of the operation, and then there's load on the what we call the data plane, all the workers, all the nodes. And you end up having to worry about scaling of both. And in the Kubernetes control plane case, we're scaling those resources up and down kind of automatically as needed. In the data plane case, this is much more workload dependent. And some customers run very static workloads. Some of them really like the size of the cluster goes up and down quite dramatically. And that's a really important thing for both application cost as well as I'll say quality. There's a trade-off. There's always a trade-off between, are you able to deliver against your SLOs? How much money do you want to spend? And it's in lots of places, it's easy to just spend lots of money to get a great result, but it's not always a great business decision. So ensuring that you have great mechanisms to keep the fleets of nodes that are handling application workloads closely matching to what's actually required, so customers are not paying for any more than they want, is really important. There's very different workloads, like big batch workloads where something has to scale up and run really hard for a long time and then scale back down later, has a much different kind of scaling characteristic than clusters where it's requests from the web coming in because it's a sports event has started, and so you see these super sharp peaks, and so you need a lot of good tools in order to manage your clusters efficiently and automatically.
That's awesome. When it comes to scaling, I know that Kubernetes has been sort of in a position to offer that at the data plane level, but we announced, of course, control plane level scaling as well. What's the driver behind that? Is it as organizations continue down their monolith to microservice journey, do they just have that many more microservices and therefore it drives a need for scaling, or are they trying to put a whole bunch of otherwise unrelated microservices into their cluster? Like, what's the driver?
Yeah, you used the M word, microservices.
Is that a bad word?
I'm going to say microservices is a bad word.
Okay.
Which is maybe a little controversial opinion. I'd say there's just services. Services should be no bigger or no smaller than they ought to be. Maybe we should talk about monolith to microservice migrations and where and how that makes sense. I think the principles of microservices, of having things that are kind of architecturally decoupled, that can be independently deployed and operated and scaled, are really, really critical. Whether every single service needs to be as small as possible, I think is a trade-off question that dev teams need to address for themselves. I think smaller is not always better. So I prefer services versus microservices.
I like that.
That's certainly its own debate. I think one of the most commonly asked questions when I have meetings with customers is, should we have fewer bigger clusters or more smaller clusters? And this was largely, I will say, unanswered because different companies different teams end up making different choices. But the general tensions, like it's a typical design tension, right? Like there's trade-offs to be made. The one that tends to drive customers towards fewer, bigger clusters is this efficiency issue, where they have lots of workloads and they want to share those workloads as much as possible and have shared resources. In the case where your cluster auto-scaling works really, really well, it's probably possible to not adopt that as a pattern. In other words, you should be able to run more independent clusters and have each cluster kind of scale up and down. This does mean that as you move from a handful of clusters to hundreds or thousands of clusters, you need to start actually managing those as as repeatable automated infrastructure. And so there is definitely a thing where teams kind of flip from, well, I have a couple of Snowflake clusters and I take special care of them and they're really big and we have a team that keeps an eye on them, to, oh, I'm running lots and lots of clusters. This is one of the places we see the importance of a GitOps approach. The ability to have a standard declarative way to manage lots and lots and lots of clusters. So I think we're, with a lot of the work we're doing, whether it's with GitOps or cluster auto scaling improvements, is we're enabling customers, if they want to run more smaller clusters, which also helps. It's a better security boundary. It's better blast radius, another AWS term. When something goes wrong, let's say a human misconfigures something, how many things die? How many things break when you do that? So,
awesome.
Yeah.
So, you mentioned bigger clusters, and I know, Jesse, you have a session coming up on, I think we're calling it Mega XL clusters or something, huge. What should we expect?
I like mega cluster. That's what
Mega
I like.
cluster,
It just sounds
nice.
It sounds like a transformer that got lost somewhere and it's now back for revenge. Yeah, so Kirti and I are going to get on with you and talk, I think after Pavan's session, about that in particular. Like Bob said, there's a lot of, with scalability, there's a lot of ins, a lot of outs, a lot of what have yous, and it depends on what your workload is, depends on what you're looking at. There are definitely some types of workloads that can benefit from just growing that cluster beyond the typical, upstream guidance around, say 5,000 nodes. So that's what we're going to talk about. And we're going to talk about aspects of scalability so that we can understand sort of the context of why we're even doing that work. So
okay,
hopefully that's fun to talk about.
Cool. Awesome. Bob, did you have anything to add to Mega Cluster?
Yeah, so one thing is that I was the SIG chair for SIG Scalability, co-chair for SIG Scalability for a number of years. And so this is one of my favorite topics, as you can probably tell. I think you were asking about why customers run these big clusters, and I missed a pretty important one. So often what we see is customers who have large clusters on-prem where there's no cloud-like flexibility in terms of the size of the pool. And so the typical practice has been, you take all of your nodes, you jam them into one big pile, let Kubernetes manage it for you. And that works really well when you have a fixed pool. But then when you move into a cloud compute environment, you can actually flex your workloads up and down and flex your clusters up and down, which is something you really can't do in an on-prem environment. But and I would say, by the way, that this is a very decent pattern. And so one of the reasons that we have a lot of customers interested in these mega clusters is that the first easy thing to do is kind of shift the cluster onto AWS as it stands. And that's maybe a really big cluster. And then in a pattern, I would say almost similar to the work that teams may do to take a monolith and start breaking apart into smaller services. You can kind of do that kind of refactoring at the kind of cluster and distributed application level, where it may make sense for customers to start pulling those apart. So the starting point is often these really big clusters that are shifting from on-prem to AWS. And then we see actually more smaller clusters as being the next step.
Nice.
So
awesome. All right, so coming up next, we're going to have Pavan, and he's going to be joined by Abir. And then after that, Jesse's going to join us a little bit later for a session. So we're going to take another 2-minute quick break, and then we'll be right back. See you guys soon.
6 a.m., making coffee while my husband walks Zoe. Time to look at my calendar. In technical sales, we have to solve for the unknown. Being able to think big internally and alongside our customers, we call it the art of the possible. Zoe needs another walk. My name is Angie Thomas. I'm an enterprise sales leader at AWS.
AWS, our goal has always been to building innovative cloud structures, solutions that scale, ideas that adapt, and most importantly, long-term relationships with our customers and communities. Because it's these relationships that have powered some of the most meaningful work we've touched. From supporting telehealth solutions and remote learning for millions of students across the globe, to enabling data analysis within the science community and big thinking in the tech world. Building is in our DNA. It's what we've done since day one. And it's what we'll continue to do moving forward. So come join us. We can't wait to see what you build here.
Hey, we're back.
Hey.
All right. So we have Pavan joining us, and then also Abir. And Abir, you're new to the stream, so why don't you go ahead and introduce yourself real quick?
I'm Abir. I'm a senior engineer on the EKS team. I've been on EKS for the past couple of years, since 2018. Been a great org to work at. I've worked on some cool stuff, and really excited to see Kubernetes evolve as it's evolving and EKS evolving with it.
Awesome. Nice. And we all know Pavan, our resident security expert. So all things security, definitely check in with Pavan. He knows what's going on. So welcome back.
Yeah, as Jesse said before, Brent, you can tell by the containers from the couch, so like from the background, who's been around and
Nice.
like what shows. Yeah, we've been doing. But yeah, welcome Abir. I'm very excited about having Abir on the show because in terms of people who've been tracking Amazon EKS quite closely, and as Liz Rice, who was on the panel before, mentioned CIS-EKS benchmark, Abir and I work closely with a lot of other individuals from our team, including Micah, who you have seen and has been presented on security. So we work together on the CIS-EKS benchmark, which is a security benchmark for assessing your node configurations in relation to Kubernetes or EKS.
Right. Who wants to start first?
I'll go first.
Right.
I'll set some fundamentals, some background, and the topic of this session is building, securing, and modernizing on Amazon EKS. So the idea is to help you dive deep into building applications and the challenges you may face, and what kind of tools would you end up using to do that. So in terms of building applications, securing them, and also modernizing them. So when it comes to building an application, it's not just one thing. I mean, you're talking about a number of parameters to balance and measure out. One is maybe cost, other is security, configuration, operations, and how would you make sure that the application which is running on your Kubernetes cluster is scalable enough, is secure enough, and you are doing the right things which are in your remit. So the talk, I'll set some fundamentals around security and what we've been discussing, and then I'll hand it over to Abir, and he'll take us through some of the exciting tools which are out there to help you build and sort of make sure your clusters are in a good shape. So in this slide, I mean, I'm not using slides, and this is a new one for me. I think we've done this before on the show, Brent, so hopefully this should be straightforward, but I'm just using my browser, and I've got some demos to show.
Yep, looking good.
So in terms of what Micah presented in his security session, which was great, by the way, so he talked about a slide briefly, and this is really important to understand for customers who are adopting or looking to adopt security or using it already within Amazon EKS, is the shared responsibility model. So I, in my role as a specialist security SA as well, this was the majority of the time we kind of spend on discussing the shared responsibility model in terms of where does our customer's responsibility lies and where does AWS ends. So this is a good place to start in the context of Amazon EKS. And when it comes to the slide which was shared before by Nate in his presentation, I've just picked it from the presentation. So apologies if it's not clear, but this is the EKS cluster architecture. And we have the managed control plane, which is managed by AWS, but it's fronted by a network load balancer, and customers interact. And they have the nodes which are within their own VPC. So we create managed node. They would create a managed node group, for example. In this case, we have the customer VPC, and within the node groups, you'd have nodes which are created for you when you're using managed node group. But however, when it comes to components within that node group, you have things like kubectl or kube. There are tools around kubedns and a binary which is installed, which we'll take a look. And those tools can interact and help the cluster engage with the API server. There is other alternative which is managed for you. When you don't want to use the nodes, you can run your workloads on Fargate. But right now for this presentation, we'll focus on the managed node groups. So one of the things customers have to be mindful of is the nodes are sitting within AZs, and that's something Abir will take us through. AZs are our availability zones, and as you can see on this screen, we have on the control plane, we make sure that you have the availability and scaling presented to you, offered to you as a managed service through our managed control plane, which AWS is responsible for. When it comes to the nodes sitting within your managed node group, or if you're opting to use unmanaged node groups, you're running your own nodes, then you are responsible for configuration and security. And for customers to ensure that they are securing their nodes correctly, we worked with CIS benchmark, and that's something that Liz mentioned before on creating or introducing the CIS Amazon EKS benchmark. So we have worked closely with the Center for Internet Security and created this benchmark for our customers so that they can go ahead and assess their nodes which they are responsible for security configurations. So I think Liz mentioned a tool which Aqua Security have created, which is open source, and she does a demonstration here, which you can look at the blog as well. But we'll quickly touch upon what the CIS benchmark is and how you can access it. So you can go up to cissecurity.org and within CIS benchmark. So if you go up to the homepage, you'd have the CIS benchmark section where you can click on download and go ahead and search for Kubernetes. There you can see all the available Kubernetes CIS benchmarks for different versions which has been produced by CIS. And there you'd be able to see the Amazon EKS benchmark and straight away sort of download the latest version, which is 1.01. So it's as easy as sort of registering and getting access to the free benchmark. So once you have the benchmark, in terms of how to use it and assess your nodes against it, we have created Brent, Adam, and the teams within AWS, and this is an open source project. We have created EKSworkshop.com, and within the intermediate section, you'd have a step-by-step. Again, we did a video on containers from the couch as well. So a step-by-step around how to assess your nodes against the CIS EKS benchmark. So what I'd like to show on the security aspect of securing your managed node groups is a quick demo around how to use it in action. So right now I have a cluster in my AWS environment. Let's take a look. Right, so I've just followed the instructions on eksworkshop.com and created the EKS workshop and cluster, and here we have a few nodes running. Right, so we have 3 nodes running, which is a kind of default setup running Amazon Linux 2. And those are the nodes where our containers or our applications would run when you create the environment. In this case, you'd have the responsibility to secure those nodes, make sure they are up to date. Within the managed node group process, you'd have ability to upgrade these nodes through CLI or through your console as well. So make sure they are up to date and don't have any vulnerable packages running within them. To ensure that you're running a secure configuration for Kubernetes, KubeBench tool will help you assess your Kubernetes, like EKS cluster, against the CIS benchmark controls. And the way we would do that is I have a file or a job which is there within this cluster, within this environment, Cloud9. So I'm using Cloud9 right now to interact with my EKS cluster. And if I just quickly show you the job page, which I'll try and run, it's running the KubeBench tool, and it's running it against the node for the EKS benchmark, right? So it's going to create that job. Let me just ensure that I've deleted that for any previously running jobs, and I'll quickly sort of apply that job, and that would create a pod which runs that assessment for you and creates the runs it against the CIS EKS benchmark. So to view the logs, all you need to do is kubectl logs, and that's the pod which ran, because I don't have any other pods running. This is a new cluster, and that's what you can see is the checks which are recommended by CIS are passing, and the configuration on the worker nodes have been scored, and all 14 of them pass, and there is a warning around one, which again is, it's kind of a setting which you need to choose around what event record QPS you want to set. It is set to the appropriate level, but then you want to change it to less than 5 or something, you can do that. So that's how easy it is now for customers to run and assess their nodes and build applications on a secure environment. So before I hand over to Abir on deep diving into building and scaling microservice applications on Amazon EKS, I'd like to point you out to Containers from the Couch, where you can use this nifty tool which is out there around security. Like, you just search for security and it will come up with a lot of different it will come up with different suggestions and the walkthroughs we have done with our team, and that will help you understand more topics around RBAC. So security is a layered approach. It's not just a CIS EKS benchmark or a certain configuration. It's an ongoing process, and you should take it as so, as in it is a never-ending, so an up-to-date, upgraded process where you need to keep working on it and make sure your environment's secure.
Hey, Pavan, there was a question that came up in the chat. For worker nodes, would this be included? Would AWS Inspector CIS rules be included at some point?
That's a great question. We are tracking some of the requests we are getting from our customers on integrating the results from the CIS benchmark to other AWS security services. We have a suite of AWS security services, Guard Duty, Security Hub, Inspector, as you mentioned, Macy, and all these services we're working at on sort of understanding how they can best be integrated with these controls. So watch this space, and we'll keep on updating you and interacting with you on the GitHub roadmap. If you find anything missing and you really want that feature, do engage with us and call us out. We are all on Twitter and also GitHub. So please do engage with us on these topics so that we can listen to you. At this point, I'd like to hand it over to Abir. Are there any questions for us, Adam?
At this point, that was the one that stuck out. There was a couple of nods to say, hey, please ask this question. So
excellent. So without further ado, I'll hand it over to Abir, and he'll take us through some of the deep dive details.
Yep. Thanks, Pawan. And thank you for introducing both the EKS architecture and then talking about like properties like event QPS, because as you mentioned, there's a lot that EKS can do for customers as a provider for Kubernetes. And then Kubernetes is flexible enough and provides enough knobs that customers can control. So I'll walk through some of the things that EKS provides for customers to run high availability workloads and how they could like consider architecting their applications. I promise it won't be just slides. I'll do a few demos. I'll open up my terminal on the side and show you what that looks like. So Pawan already gave us a great introduction on what AZs are. So this was just an AZ primer. I'm pretty sure most of us comfortable with AWS know about AZs. They're isolated zones. They help us isolate our failures. So if you're running in a region, like Pawan mentioned, EKS is multi-AZ. So the EKS control plane is always highly available for our customers. So if there's an AZ availability, it's not like you won't be able to access your Kubernetes cluster. And we also recommend that customers, when they're launching their managed worker nodes, launch across AZs. And this guarantees that you have enough worker nodes in every AZ, and that gives your applications a good availability. But just launching your worker nodes isn't enough, because as we know, Kubernetes allows you to launch pods, and the Kubernetes scheduler by default does a pretty good job of balancing pods across nodes. But depending on your workloads and depending on how critical they are, you might want something more. And as we're talking about, like Kubernetes gives us that flexibility. So there is a way that you can indicate when you're doing a deployment to Kubernetes that, hey, you know what? I want to make sure that my pods are evenly spread across AZs that my nodes are in. And as you can see that I wrote down 2 small points over here. There are like 2 ways of saying that, oh, you know what? I absolutely want that my pods are scheduled across AZs. And here's one which says that, yeah, try as much as you can. But in the case, for example, like, you know, an AZ is unavailable or instances in this AZ are unavailable right now, go ahead and like launch the pods on like the available instances in the available AZs. So it's a pretty cool, so you would really want to think about like what makes sense for you. So I'll just show you how this sort of looks like. So if you like, this is just a simple kubectl describe command. If you like describe your node, you'll probably see this label. And this label is like starts with 117. The older one was beta.kubernetes.io/failure domain. So I'm using the latest one, but if you're using an older version of Kubernetes, you have an option to like use the other one for your own demo or your own sort of like tries. So like I was saying, that only schedule pods. So let's see what this looks like in action. Whoops. So I'll open up this thing. So here's like a simple Nginx deployment. And the interesting part is here. If you notice, it says that, hey, you know what? Distribute. For this deployment, I prefer that during scheduling, you distribute the pods based on this label. And this is the label that gets auto-applied on every node. So I'll show you my cluster over here. So, okay, get nodes. So maybe that's, oops. Let me just fix that. Yep, sorry about that. Yep. So as you can see, my cluster has 3 nodes all on 117. So here's a simple query, because I think it would be hard to parse this. That will show you that actually all my 3 nodes, so this just greps through the nodes, finds the labels, and shows you that through the nodes, I have all in 3 different AZs. So then USS 2A, 2B, and 2C. So now what's going to happen is that I'm going to apply this application. So let's see, Nginx AZ spread. So now if I do get pods, you'll notice I have 2 pods. One of them is still creating. So let's hold up. Okay, so I have 2 pods running. So let's, yeah. And if I actually describe these pods, you'll see that they're actually on 2 different nodes. So if you see that the node it's on, you'll see this is on a node 136, 172. And if you look at the other one, this was CRP99. So you'll see this is on node 187, 153. And as we know that I have only 3 nodes and separated in 3 different AZs, you can see that these got spread across 2 AZs automatically. So let's see what happens if I make this 4 replicas. So I hope I saved that. Yep, I did. And all I'll do is I'll do kapply next. And so let's see now. So I think this is an old one. This is an old one from what I remember. And these are the 2 new ones that are creating. So let's see if they are up. So what's actually happened is that now that actually 3 of these pods are on 3 nodes. And then one of these pods is now shared across one of the nodes that already had the pod. So because we went with preferred tiering scheduling, even though I only had 3 nodes in 3 separate AZs, I was still able to launch 4 replicas. And this is useful, right? Like think of the case where there's an AZ level problem that you are facing, an AZ is isolated, or you're having an issue with like launching instances in a particular AZ, and you have like an event where your horizontal pod autoscaler is scaling up your pods. If you have this property set for preferred tiering scheduling, you're still going to be able to scale up, and you'll just scale up in a separate AZ. And once your AZ event is resolved, you'll be able to sort of redistribute the pods by your own. But
that's great. So can I just interrupt a bit? In terms of
sure.
the key that you use, the topology key, is that a property that's provided or built in when we create a cluster, or is it something we need to specify?
Oh, that's great. So actually, if this is something that's automatically added to every node by Kubernetes itself. So if I just describe this, any of these nodes, you'll see that I didn't add this. This is like Kubernetes does this for us for cloud providers. And this is, as you can see, the topology key is added by itself. And this started in 117. And if you have a pre-117 worker node group, you'll see this one, which is failure domain -pida. And this key was recently graduated in 117. And at some point, this will fall off. So people will have to upgrade their workloads.
Could you, with the preferred during scheduling, ignored during execution setting, is there an equivalent that would allow you to reshuffle the pods? Like if, let's say, one of your 3 availability zones went, horribly wrong briefly, obviously you lose those pods, and because it's preferred during scheduling, we might pop up our normal scale into other availability zones. And at that point, we're kind of unbalanced, right? We would be like a lot more in 1 or 2 availability zones and practically 0 in the third that was having a problem. Is there a setting that would sort of automatically shuffle things back and rebalance the pods back?
There aren't things that will automatically reshuffle things back, but I will talk about something that will make sure that inadvertently you don't kill a large amount of capacity if your cluster gets unbalanced like that, or or EKS doesn't inadvertently do something. So I will come to that after this.
Awesome.
Cool.
Right.
So we spoke about prefer during scheduling, and I'll give you an idea about that. So let's look at something else for something more strict. So here you go. So here's one which says required during scheduling. So think about a case where, for example, you use EBS volumes, and we know that EBS volumes are intra-AZ. That is, you can't move an EBS volume from one AZ to another. And then this might be a case where, you know what, you really don't want pods to start launching in another AZ, because you know when you have to do the thing of rebalancing your cluster, now you can't move your volumes around with you. And that might be something that could be like disastrous to the way your application is architected. So this is more of a stricter guarantee. So let's see what happens when we scale out this application. So here I have only 3 replicas. So let's see, I go k apply strict spread.yaml. So let's see. So these are still creating. So as you see, these 3 Redis cache pods came up. And this is pretty standard. They're spread across 3 AZs, as we saw. But the interesting part occurs when I put, say, the replicas as 4. And now when we do pods, oops, I didn't apply it. What you'll see is one of them is stuck in pending. And this one is stuck in pending because there's actually no other AZ where it can schedule this pod. So I think if you also see this thing, it might tell you something interesting about it. So you see failed scheduling because 0 out of 3 nodes are available. 3 nodes didn't meet the pod affinity and anti-affinity characteristics. So you can, like, these rules can get pretty interesting. You can choose to obviously customize them a lot. I've seen customers on other applications where you would want certain pods to be co-located and the traffic to be shared on the node. So if you have a database or a cache and your application server, you maybe want your application and cache to be on the same pods, but your database to be on like a separate node. And then now you're guaranteeing your cache and application are co-located together for better performance. And you're running multiple network hops. And then you have your database somewhere else where you care about like, oh, the EBS volumes need to be always spread together correctly. So you can do some interesting application architectures with these.
Yeah, this is really great in terms of designing applications when pods are being placed within a multi-AZ environment like EKS. And there are customers who are probably sensitive around a particular AZ or putting their workloads in a particular a set of AZs, then they can architect their application around it. So that was a great demo. Thanks, Abir.
Yep, thank you. So let me show you guys one more thing. The thing Brent was talking about, like how do I guarantee that now that I have these pods running in different AZs, that I don't end up with like many of my pods like gone. So Kubernetes has this great construct called pod disruption budgets. And this is a contract that you create with anybody else using the cluster or cluster admins that, hey, you know, I'm an application developer and this is my service. And as you know, that 100% availability is the goal, but it's definitely a theoretical goal. So you know your application best, and you know that maybe, you know what, 80% of my pod should be up for like most of my traffic to be served. And I'm leaving 20% up there for like redundancy, reliability, in case of outages, in case of upgrades, stuff like that. So this is the way. And so you can specify something called a pod disruption budget policy. So this is a sample policy that I've written out here. We'll do a demo of this as well. And all this is saying is that, you know, hey, this is the name of the pod disruption budget. So the spec says min available. You can go with min available, max unavailable. You can go with a percentage, and you can go with an absolute number. So you have a couple of options over here. And the next part is like the match label, like what pod do you want to match this with? So let's do a quick view of this. So let's do PDB. So as you can see, right now, I've obviously configured it to max unavailable 0. This isn't a great pod PDB that you should configure, but I'm saying that, you know what, there should be no pods that once I deploy this PDB, for my Nginx pods, none of them should actually ever be terminated. And you see how that plays out. So if I apply this, as you can see, and let's see, get PDB. Nginx. So as you can see, it says that there are currently 4 pods running, the desired is 4, the total is 4, and there are 0 allowed disruptions.
Nice. So there was a question in chat from LAX Meekanth 80. I know that's not what how it would normally be pronounced. Forgive me. We have 50% spot and 50% on-demand nodes, but we need the pods to be spread across multiple AZs. How do I specify this using affinity? Sometimes we need all pods on spot only. That's totally doable with what you're showing us, right? We can
So you can you can definitely do that. You can start spreading across multiple AZs is the way I was showing you. Is like, let me just pull up one of those again. So depending on your requirement, oops, I want to do the Vim. Next spread. There you go. Yep. So definitely using this, you could like spread them across AZs, and you can also use label selectors to like choose. So if you're, depending on how you're launching your spot capacity, you'll be able to like label your nodes with a particular label saying that, oh, these are spot nodes. And then you can put in a label selector along with this. So this is just a pod anti-affinity selector. You can also add a label selector. I don't have an example of this offhand, but once you add that, and it'll be very similar, there'll be a label selector, you'll put your label key there, and then these pods will only be scheduled onto the nodes with those labels. So
perfect. And if you do it as preferred, then you're gonna get pods scheduled onto spot nodes unless they just aren't available, which, as we all know, can happen with spot. So that way you don't have an outage or downtime. You just shove as much as you can onto spot as quickly as you can. And as far as the label selector, node selector, I don't know about you, but I actually like to bring my spot nodes up in a different node group. And by having them in a different node group, then you do have kind of that built-in mechanism. But otherwise, if you're putting them all in a mixed node group, then you could label them yourself and select them that way.
Yep, definitely. Like, and if you do bring them in a different node group, and depending on the tooling you're using, if you're using EKS managed node groups, and EKS will add the labels. If you're using EKS CTL will add those labels automatically for you. So you definitely have a couple of options over there where you can like get that labels done automatically for you versus you writing some sort of node labeler that will take care of this.
Awesome.
So let's go back a little bit into this. So like we configured this pod disruption budget, and we saw that okay, we're saying that allowed disruptions is 0, but what does this actually mean in theory? So let me show you like what that means. So let's say you're a cluster administrator, right? And then you're like, hey, you know what? I actually need to like put this node down because there's a maintenance operation, or I'm seeing like there's some issues with this node, or I just want to upgrade this node. And a very common way of upgrading nodes is that you do a drain command. So let's see, I have, oops, it's gone out of my history. So there's some more flags that I probably have to specify. There you go. So I need to do -- ignore daemon sets, and I need to do -- delete local data cache. So now if you see what's going to happen is that if you notice what it says over here is that, you know what, it's trying to evict this pod, but cannot evict, but it will violate the pod's disruption budget. So it's continuously trying. So if I was actually to go and now change the pod PDB, it'll actually be able to like successfully evict this pod. So you can do some interesting things with this. So like here, so this is what we use effectively to like set up the contract between infrastructure providers as managed node groups in EKS and application developers or customers of EKS. So what we've done in managed node groups is that customers always want to upgrade to the latest version of Kubernetes. They want to upgrade to the latest version of the Army that we launched because it comes with improvements, security improvements. And what we do is that we always respect your pod's BDBs when we upgrade.
Yeah, so, and I think we need to like reinforce this one more time just to make sure everyone understands, because we're talking about setting something all the way down at the pod level, right? The pod disruption budget, but something not at the orchestrator level, but actually above that. The thing that's managing your node groups is actually paying attention to that, and it understands that way down deep, there's a setting that if I take out a node, you aren't going to be meeting your pod disruption budget. And so it avoids doing that. And having that full, idea of a managed node group, that's really where it starts to shine. If we were just using autoscale groups, we wouldn't really have this functionality. It would be up to us to manage the relationship between pod disruption and node count. But by having managed node groups, the whole thing can be managed end to end. It's really great.
Absolutely, yeah. Brent, I think that was what I was impressed by when I was speaking to Abir about this, and I think this is a unique kind of feature to highlight and like share with our customers, where if they are building an application at an application level, they have the control to architect around the EKS cluster. So the application is really deciding the behavior of the cluster, and that's really important as customers scale their environments.
Awesome.
So
I don't want to cut you short or anything, but I think that was an awesome demo, and I want to make sure that it looks like you were sort of proactively answering one of the questions in chat from Pardeep092. He was asking about exactly that right as you were starting to talk about pod disruption budgets and how they all work. So it's an excellent mechanism for ensuring that you have a good amount of uptime and you don't lose your pods while you're cycling your underlying infrastructure.
For sure. Like, I think as infrastructure providers, application availability is critical to us, and having that contract with our customers and helping, like, it's hard for us to understand our customers' applications and each of them, and this is like the right bridge for customers to like hand us off saying that, hey, you know what, this application 80% always up, and that's what we want to respect for you.
Nice. Awesome. All right, so when we come back, we're going to be meeting with Jesse and Kirti to talk about mega clusters, and we're going to work through all of those details. So I want to make sure that we give you enough of a break. So we have 2 minutes planned. So take a quick break, check back with us in about 2 minutes, and we'll see you then.
Cool, thank you.
I am a technical person, so we drink tons and tons and tons of coffee. I act as a liaison between my technical team and my business partners to help drive the team to deliver results. I was a little STEM girl. I've always been nerdy. I just want to see more women and more women of all colors enter the industry. I try to end the day at the same time every day. I'm Lynn Lucas. I'm a senior technical program manager at AWS.
From achieving your business goals to advancing your career, building your cloud skills can make every day a new opportunity for success. That's where AWS Virtual Classroom Training can help.
Highly available environment.
We bring live online classes to you so you can keep up with the pace of innovation and learn in-demand AWS cloud skills wherever you are. Engage with peers and AWS accredited instructors.
We'll have traffic coming into our private subnet.
Gain insights as complex topics are broken down in real time through hands-on labs, demonstrations, whiteboarding, and presentations. Get your questions answered and learn best practices that can be used right away. Every AWS training classroom course is offered virtually. Choose a public class delivered by AWS or an APN training partner that's convenient for you. Or schedule a private engagement with a dedicated AWS instructor to develop your team.
Thank you very much.
Go from learning to doing and keep on innovating with virtual classroom training straight from the source. AWS.
Hi, my name's Dakota, and I'm a solutions architect covering the Central Midwest territory. Towards the end of my enlistment as a cryptologic linguist in the Marine Corps, I was connected to an AWS recruiter who suggested the TechU program. It was a great fit for me because of my lifelong interest in tech, and actually since graduating from TechU last September, I've been working with customers in delivering results in the form of well-architected reviews, immersion days, and workshops. The most impactful thing that I've had a chance to be a part of to date would be the Fred Hutch Hackathons, where I was part of a team helping to find innovative ways to process data and develop applications to help make the lives of those dealing with cancer easier and will ultimately contribute to the annihilation of cancer.
All right. It's hilarious. I'm always surprised when we come back, just every single time. I even know it's happening. There's a countdown telling me it's about to happen, and yet when it happens, I'm like,
every time.
It's so funny. All right. Welcome back, both of you, Kirti and Jesse. Good to have you again. I'm going to shuffle the screen around a little bit because you guys are important, so you should be on top. And we'll just be down low, getting covered up by text and all that stuff. So, how's it going? What are we going to talk about?
Pretty good. So, yeah, great. We're going to talk about running really, really big clusters today. Very exciting topic. I know it has been brought up multiple times throughout the day today. So we're very excited, Jesse and I, to talk about it.
Awesome.
Yeah, like Bob had said, like we tend to have themes for our container days, and yeah, we keep touching on this one. So we're gonna dig into it and kind of one aspect of it, which has multiple aspects. So
nice.
That'll be cool.
So, this comes up, I think Bob brought it up earlier today, but it comes up in, it seems like almost every customer conversation. Should I have fewer bigger clusters or should I have more smaller clusters? And there's not a definitive answer, but we've had, kind of a direction. But now it sounds like even the direction might be changing. So what's new? What's happening?
I think, so we have a few slides here. I think this is a very interesting question. I know, like you said, like Bob kind of answered this. But what I would suggest is we go through the slides and I kind of like have answered this question in my slides. So then at that point, I can talk about it.
Perfect. Your slide share is up, by the way.
Yeah, I'll get us rolling. So there we go. Now my taskbar is gone. Yeah, so I think that is exactly the right type of intro into this because I don't know that we as a service team see that things have changed, but we're just trying to address more and different types of configurations and scenarios for our customers. So just to sort of do a little level setting, like when we talk about scalability, what is it that we're talking about? Are we talking about control plane scaling? Are we talking about managing the data plane? As Bob had said, we sort of throw these terms around. So control plane being where the control aspects of your cluster live. Data plane, from a managed service perspective, being your nodes, right? Or the workloads within them, right? Auto scaling, based upon the workloads. And the answer is yes. Like we are concerned about all of these things. And so, within EKS, scalability has been a foundational principle of the engineering work and the design work that's gone into it from the beginning. I just joined in February. As one of the things that I noted is that, sort of the design tenets and where they had set the scope for the service, the important things to the service, that's all really been front and center. As Nate was saying before, sort of priority zero, day zero sort of concerns. So for this session, what we want to focus on, and we'll touch on a lot of different things, but we want to focus on, what does it look like for clusters when we build clusters beyond that 5,000 node upstream guidance, like really, really big clusters. And what are the scalability bounds when you're building something like that? And then we want to touch on some of the work that we're doing currently. So Kirti, do you want to talk a little bit about sort of from the product side of things?
Yeah. Yeah, for sure. I think I think to begin with, before we get into running really big clusters, I also kind of want to address the question that Brent asked, right? And I think this is a question that we get a lot, when do you use large number of small clusters versus one big cluster? although I think the right answer, and Bob kind of like said this, is it really depends. It depends on your use case. It kind of like depends on the workload that you're running. But I would say that large number of small clusters for majority of use cases is still the way to go. However, there are a few genuine use cases, and I'll get into that a little later. I know there was a question in the chat that can utilize large clusters for the kind of performance and scale that they offer. And even before I do that, I kind of like want to talk about how do we at EKS AWS think about scalability. As I think Jesse rightly mentioned, this has been something that has been on our mind since the beginning, since the time when EKS started, right? I think we at AWS run the largest number of Kubernetes compared to anywhere else in the world. So we also think it's kind of our responsibility to push the envelope of how big a cluster can scale and what a Kubernetes cluster means. So which is kind of like why we're working in this direction. I would say that mega clusters is not the only project that we're working on. As far as scalability, the whole domain is concerned, I know cluster auto-tuning, Carpenter, a lot has been spoken about it today. Those are other exciting projects that we're working on in the scalability domain. So yeah, that's what we think about. In terms of specific use cases that can utilize a mega cluster, I think that there are multiple, again, like I said, but these are the ones that come up a lot. So for example, if customers want to run spiky workloads where you can see a huge spike in demand, sometimes predictable, sometimes unpredictable, that forms a good use case for running a mega cluster. We have an e-commerce customer who sees a huge spike in demand during holiday season, Christmas, New Year. So basically this could form a good use case for that kind of a customer. Then we also have other use cases with regards to machine learning applications, batch processing. Another use case that comes up a lot is big data processing, right? Like if you have large amounts of data that kind of, bigger than what could a 5,000 node cluster would fit, you kind of have to shard your data across multiple clusters, perform processing against multiple clusters. That kind of like increases your processing time. So it just makes sense to run a really big cluster for a use case like this. I think another use case that we see a lot, and I think Bob spoke about, is customers who are trying to move their workloads from on-prem to cloud. The general design there that we've seen is customers use one big cluster, and it's just easier to move that big cluster to cloud, to AWS. And later move on to smaller clusters as they go on in their migration journey. I also think I think we've spoken about use cases where customers can use this, but I really think it's important to talk about scalability and what does it actually mean when you are trying to run really big clusters. I think SIG scalability, SIG is basically a special interest group for scalability within Kubernetes. So they do a great job of just defining how to think about scalability within Kubernetes. And I think the way SIG scalability puts it is scalability is a multi-dimensional aspect of the system, right? Nodes per cluster is a good proxy to think about when you're thinking about how big your clusters can grow. But there are multiple other dimensions that you should think about. We have a great diagram on the next slide. Jesse, if you could. Yeah, so like I said, nodes per cluster is just one dimension. There are multiple other dimensions. You could think about pod churn, you could think about pod density, total number of pods for that matter, your namespaces, your services, your networking setup. I can go on and on and on, right? Like multiple things that you have to think about when you're trying to scale beyond 5,000 nodes per cluster. And I think this is more complicated by the fact that when you try to scale or stretch across one dimension, your cross section with regards to other dimensions will reduce. So if you're running a lot of nodes per cluster, the number of pods per nodes that you can run within your cluster will reduce. So I think it's really important. I think the point that we're trying to get across is it's really important that customers get a fuller picture of what they're trying to do, because even though these limits have been defined, systems behave very, very differently at their limits, because your configurations are going to be different, right? It's not going to be a standard configuration for most customers. So on paper, what we are telling you, or like what the limits look like, they would be very, very different from what you actually have in practice. But the good news is we have some guidance in practice that we can utilize. Yeah. So
yeah, we do.
yeah. So
Sorry, I'm having a really hard time juggling
that's
all the
okay.
different screens.
That's okay. Yeah. So like I said, you can think about nodes, and I mean, when you're a lot of people think that when you're trying to run more nodes per cluster, that would mean more resources, right? And if you're trying to run more pods per clusters, that means more work is getting done. But if you see on the right, and this was something that I was talking about, if you're trying to stretch across one dimension, your cross section with regards to other dimensions, I think we've shown pods per nodes here, that will reduce. So even if you're running a 10 node cluster or a very small cluster, and if you're trying to stretch across, say, for example, pods per node, your cluster can fail and it can become unresponsive. So that's one thing that you should think about. Jesse, do you want to talk about services backends?
Sure. Yeah, sure. Yeah, similarly, so you look at sort of the number of services you can run across a cluster or the number of backends per service, and you sort of have these two ends of the spectrum that you're pulling at. So with more backends, you have more pressure on the total services that you can house in a cluster. But with more, sort of more nodes, you can stretch out and have more services that are smaller. So this is sort of what we're talking about, right? And it's important to just say, okay, these aren't just numbers. There's a whole picture. And even when you look at these numbers, behaviors can change when you're really pushing systems, at every level of the stack.
Yeah, and I'm sorry to interrupt, but I think this is super important to really like solidify for our viewers, because so many people get caught up on how many pods or how many nodes, but there's just a ton of stuff that goes into it. And if you start having, for example, pod churn, if that starts to be super high for you, then all of a sudden the calculations that you may have come up with or made while things are perfectly healthy are no longer going to work for you. So, there's a ton of stuff that plays into this. It's not as simple as tell me what the highest one number is.
So a funny turn of phrase here. So everybody's familiar with back of the envelope calculations, right? So you just kind of jot down some stuff on the back of an envelope. We actually refer to all of these configuration variables as an envelope. This is sort of a scalability envelope. So this is like making back of the envelope, calculations with the envelope moving, or changing shape. There's a lot, like I said, there's a lot of ins, a lot of outs, a lot of what have yous. And you also have, like, under the covers, you actually have real bounding parameters on particular functional pieces of software. So etcd is a great example, right? So, you have a subsystem there that everything relies on, and it can literally only do so many IOPS in particular configurations. So just with that one aspect, when you're working with different configuration parameters and sort of coming up with different models, you need to keep that in mind. And that's just one of many things. So the idea here is really to, when doing this engineering work, SIG Scalability called this out early on, and, sort of decomposing the work into smaller sets of configuration combinations, and sort of, putting work into saying, well, where can we stretch things? What can we do with configuration to actually make these functional limitations, have higher bounds? So getting back to what Kirti was saying with pods per node, this is a great example of just seeing, pulling in two different directions, right? So the more nodes you add, the more pressure you're going to add to the API server instance in the cluster. Around density, so the more pods per node, you're going to put more pressure on kubelet on the node, right? So you sort of have this, well, you can have more nodes, but not quite the pod density, or you can really max out your pod density, but you're going to have less nodes. So you're sort of pulling and pushing on both ends of that. And, services we touched on. So I think the rough, so there's some rough guidance here, right? So 10,000 services for a cluster, 5,000 services in a namespace. So each service ends up being represented as environment variables that are all linked together in every single pod in the cluster. So obviously, with thousands and thousands of services and only having so much space in a pod, you sort of end up having pod crashes, and you hit upper bounds there. So these are just sort of examples of like looking at these different parameters and how they all come together. This is actually one of my favorites, just to sort of visually see there's real like differences in, depending on what your workload is. So getting back to even what Bob was saying before, you can have more smaller services or less bigger services. I mean, it's pretty obvious, right? But there are so many parameters to this, where even that upstream guidance is roughly speaking. And looking at a pod, maybe your pod has 2 containers in it. So with services, it's the same thing. Well, maybe you only have 5 backends, or maybe you need more, right? And so you have to think about all of these aspects when you're building out your control plane, basically.
Nice.
Kirti, do you want to talk a little bit about the current work going on?
Yeah, definitely. So I think we've said this before, but what we're trying to do is we're trying to go beyond the upstream supported limits of 5,000 nodes per cluster. And today we are basically on that journey. We've been testing at different limits above 5,000 nodes per cluster. So today where the team is at is basically they are testing at 10,000 nodes per cluster. And basically, we are also trying to test different types of workloads. We've been talking to customers. We've been trying to understand what kind of work, because like I said, no customer workload is similar to some other workload, right? So we've been trying to talk to a lot of customers, trying to get data in terms of what kind of workloads they run and what is suitable for these, like what kind of tests do we perform for these large scale clusters. So we've been trying, like I said, we've been trying different types of workloads. Some have like high number of backends, some have low pod density but larger number of nodes, some have, and vice versa, like high number of less number of pods but high pod density. We've been testing different configurations. And I think another thing that we've been trying to do is we've been also trying to predict potentially what would customer workloads look like a year or a couple of years down the line, and we've also been trying to test for that. So that's the work that's going on. There are a few challenges or things that we've been trying to do with regards to going above or beyond 5,000 nodes. Jesse can cover that.
Sure. Yeah, it's been really interesting, sort of, working with the team and being in, Slacks and kind of watching what they're doing and the different findings. So, basically when you think about this stuff, you think, okay, so, all right, fine. Scalability is not just doing this, you can have this max, right? So now we know that all of the dimensions are really malleable and things are moving around, but then there's also just real world impact for trying to say, allocate 4 or 8 or 10,000 nodes all at once from a system like EC2. It's not designed for that. It's an incredible service and it's incredibly rich and it can do a lot, but it's not designed for us to say, yeah, just give us 8,000 nodes, right? And every time you're provisioning a node, as someone in the chat had pointed out, obviously, it's not just compute, right? You have networking, you have storage, you have all these other implications, and there's no single API call happening here. So what you end up hitting is of course, API throttling, right? Like if you're just hammering EC2, they're like, when so there's lots of work going on there across multiple service teams and in EC2 and EKS and others, sort of looking at how we can make that stuff more efficient. And I think that's an example of how this kind of work can lend to more features and a stronger overall cloud ecosystem and inside of AWS, because we need ways to do that. And around IP provisioning as well, like what can we do there so that we can allocate maybe entire sets of IP addresses, entire networks. So there's a lot of really cool work going on there.
Yeah, that's something that's already.
Yep.
I was just going to say that's something that's already come up in the chat. Like how do I handle allocating so many IP addresses because we know how IP addressing works right now with EKS, and every pod gets its own IP address. Well, if you're scaling up to 10,000 nodes running 50 plus to I don't know how many the max pods might end up being. That's going to be a lot of IP addresses that you're assigning out. So figuring out how to handle that and manage it. Someone else mentioned Kittles and Bits. Love that name, by the way. Mentioned also what kind of strategy do you use to manage that many nodes? 10,000 nodes. You're going to use tagging to help keep them organized and stuff like that. But are there other strategies? Spreading them across availability zones is an obvious one. But I don't know. I mean, it's staggering when you start to think about it. And I'm guessing what you would start with is, what does my workload have to accomplish? And that's often driven, like Kirti pointed out earlier, it's driven by maybe your data, or what the work is going to be doing with your data. If you're a big machine learning shop and you have a ton of data that you have to crunch, then you don't want to have to shard all of that data out and assign it to multiple clusters. You want it to just be in your giant pool of data. So what does that translate to when it comes to bringing up all of those nodes to run all of your pods to be able to crunch all of your data? I think that it's all kind of driven by whatever is at the foundation, which a lot of times ends up being data.
And there's another aspect of what you're talking about there too, where, and I just think this is amazing. Sort of when I got into the industry, everything was metal, everything was racked. Enterprise, so kids listening, enterprise disks when I was a junior engineer were 2 gigabytes and they cost $2,000. I mean, so you had to think about things like mean time before failure of hardware components. And so when we started building really large storage clouds and SANs, it was like, oh yeah, you're going to have 200,000 spindles. You're just going to have a disk fall over every 2 minutes. These are the things that we handle for you, right? So you don't have to worry about things like that. So if you say, oh, I want, 6,000 or 8,000 nodes because I have one of these workloads that Kirti described, you can just kind of do that and know that that's just part of what's being offered here. It's kind of cool. But then getting just this one last bullet, this is interesting to me, even just getting all the way down to the container runtime you're using, right? I mean, if you're using Docker or you're using Containerd, those are 2 very different runtime engines that have very different characteristics. So when you're thinking about things like pod churn and really trying to drive a lot through, maybe Docker isn't the choice. So there's a lot of cool stuff here. And, so some of the work that's happening right now obviously is in configuration. So things like the scheduler, controller manager, they have a QPS default of 20, right? So yeah, that's sorry about that. Yeah, I'm an old guy. Watch that. So the team right now is working with configuring QPS up to 100 and seeing what type of impact that has, or looking at some of those backend configuration characteristics of subsystems that we're talking about, planning for 10,000 or 20,000 IOPS backends for etcd. So there's a lot of work going on here, and a lot of the data looks really promising. And especially, around those characteristics that as a developer advocate, I think of, so what does the pod density look like? What are latencies in spinning up workload? What does the pod churn look like? And so we don't want to just say, oh, here you can have 8,000 or 10,000 nodes. Good luck making it work, right? That's part of all of this work is part of making it work for you, so that you have a seamless, transition into these really large clusters for those types of workloads.
Awesome.
So yeah, I mean, there's so much to talk about here. I think we're sort of short on time, but Kirti, I just wanted to make a couple of observations and pass it off to you. So one thing that I'll say, sometimes when we talk about something like this, I mean, this is really a roadmap transparency session, right? We're just sharing with you some of the things that we're working on so that what might be coming down the pike. EKS here is really the product. This isn't about scalability. It's about making EKS a more robust, service that has more options for you and will better map to the types of workloads that you want to run. And so just one thing, sometimes when we're talking about this, we say, okay, so what's going into the ecosystem? Like, where is this going to land in Kubernetes itself? As Kirti pointed out, like, we have maintainers of SIG scalability on the team. Our GM, Bob Wise, is one of the co-founders of that SIG. Like, we are all about upstream. A lot of this work lands in EKS itself, which is the managed service. That's not interesting to Kubernetes, but what we learn here is definitely going to be reflected, outward and into the ecosystem as much as we can.
Nice. Awesome.
Yeah, I think just last closing thoughts. I would say that, again, like, this is a very exciting but a very complex topic. So there are a lot of things that you have to think about when you're trying to go beyond the upstream supported limits of 5,000 nodes per cluster. But if this is something that you're interested in, or this sounds exciting to you, please reach out to your account teams. I know we also have a email ID that customers or people watching on the chat can send questions to. Please reach out to us and we'll be happy to answer your questions.
Yeah, and that's my, whoops. I always get confused which direction it is. So that's my Twitter handle. I don't know, you can see it there. So that's my Twitter handle. You can find me on Twitter as well, or Brent is, I work with Brent, so, get to either of us. And if this is something that's really interesting, I think we can bring it back to a Containers from the Couch and talk about more stuff and maybe look at some types of workloads running at this scale. It would be really fun.
That would be awesome to do. All right, so we have a break coming up real quick, bio break, about 2 minutes or so. And joining us after that, we're going to have Scott Malky, and he's going to talk to us about Graviton and all of the goodness that comes along with that. So you definitely don't want to miss that. This is the latest and greatest in processing. So definitely join us. Hang out. We'll be back in 2. See ya.
Today starts with a workout. My husband and I do triathlons. Here's 10 years worth of races. I manage critical systems for 11 data centers. In my job, the only constant is that no 2 days are the same. The amount of thought and redundancy that we put into our systems is incredible. There is no place else to work on systems of this scale. I'm Frances Baldwin, Data Center Engineering Operations Cluster Manager at AWS.
Building and managing a startup can be challenging. Our goal at Amazon Web Services is to help guide startups like yours on a successful journey. That's why we created AWS Activate. It's free to join and gives you access to a bundle of resources and tools, including AWS credits to help you get started on AWS support credits for expert assistance when you need it, and technical training and hands-on labs to get you up to speed and proficient with AWS services. Startups in some programs also receive special promotional offers, including discounts, free trials, and other startup-friendly perks that can add valuable tools to your startup. Plus, with Activate, you'll be able to access the AWS Activate console, built by the experts at AWS, which delivers recommended content personalized for your startup. The Activate console also makes it easier for you to track and monitor your AWS credits and costs, and get real-time updates on the health of your AWS environment. By joining AWS Activate, you'll gain access to a global network of developers and entrepreneurs who are achieving success on AWS. And you'll have opportunities to showcase your startup at AWS events, including summits and reInvent, and on the Startups blog, helping you reach potential customers. Ready to get started? Sign up for AWS Activate today.
Well, things are different these days, but we're figuring it out. We're doing school online now, learning a lot. Finding cool stuff to watch. Dad's got some new workout buddies. And I still get to spend time with you.
Okay, now we're gonna put in the sugar.
Hey there.
Hey.
We have Scott Malky with us. By the way, he is just really fun, and I think you're really going to enjoy this. Honestly, talking with you, Scott, is always a good time.
It's thank you for the kind words. I'm beyond thrilled to be here today. This is I can hardly contain myself.
Oh, I see what you did there, and I support that 100%. So we just had a lot of really good conversation around large clusters, the mega cluster, as Jesse called it, like a transformer. I love that reference. It really does feel fitting. And so now we're going to talk about Graviton2 and all the amazing things you can do with ARM. So I'm really looking forward to hearing what you have to say, Scott. So why don't you lead us in? Why don't you introduce yourself and let's get into it?
Yeah, dude, absolutely. Thanks for having me. This is, like I said, I'm super thrilled to be here talking about a really cool technology. My name is Scott Malky. I'm a specialist SA on the EC2 side of things, covering the Graviton and Graviton2 processors. And today we're going to talk about multi-architecture images. That's what we're here for. So if I can actually advance the slideshow, that would be great. All right. So quickly, I want to do just a quick little intro about the Graviton processor in case y'all haven't heard about it. Just a quick intro there. Talk a little bit about how to build multi-architecture images, and then finish up with some tips and tricks, resources, links, further places to go if you want more information, want more details, things of that nature. So, Graviton. Well, what a lot of people don't know is that we've actually been running custom AWS silicon for a number of years transparently to customers. So a lot of the hardware that powers the EC2 Nitro system and other backend systems is actually custom silicon designed by us and run purpose-built for us. And what happened was a few years ago, we were very happy with, we still are happy, but a few years ago we were really happy with how this silicon turned out, how the silicon worked for us, and we said, "Gosh, what could we do if we could optimize down to the silicon level for our customers?" Right? What if we built a processor that we know was only going to run in EC2? What could we optimize once we had sort of full control over the entire piece? Right? And it's really just an example of how we continue to innovate and build on behalf of customers. We see something internally that is working really well for us. We see something that is that we're very excited about, and the performance gains and the impact it has internally. Let's give it to the customers, give it to our customers, see what they do with it, see if they like it. So in 2018, we came out with the Graviton processor. It's the first ARM-based processor in AWS. It powers still the A1 instance family, if you're familiar with those instances. Topped out at 16 vCPUs. It's a 16 nanometer chip, has about 5 billion transistors. This was announced at reInvent 2018. And it did really well. Customers really liked it. There are a number of customers still using the A1 series today. Really great for those sort of horizontal scale out workloads, things that can just go this way. Not the most powerful chip in AWS, but certainly very, very good at what it does. And customers came back and said, "Hey, this is great. We love seeing custom silicon. We love seeing ARM64 on AWS." And so reInvent last year, we came out with the Graviton2. And these pictures are actually to scale of the actual processors themselves. So it goes up to 64 vCPUs. The cores themselves are significantly more powerful. It's a 7 nanometer chip and 30 billion transistors. So a significant leap in power and capability. And it powers a bunch of instances. Powers the M6G, the C6G, and the R6G. And more recently, we announced the T4G, which is our burstable variant. So these are available now in, I believe, I want to say 14 regions. So many regions. Region availability is a big concern for us. So throughout this year and into next year, expect some more information about that. We also have the standard SSD versions and the bare metal versions, if that's more your speed. An important thing to note too is also we are running a free trial of the T4G up until the end of this year. So you can get a T4G micro for no cost. So 750 hours, no cost per account. So if you have not tried a Graviton2 based instance, it's literally free for you to try it out. T4G also works really well with ECS, EKS, all of that stuff as well. So you can spin up node groups with T4Gs if that's more your testing method. So why is this important, right? So yes, we have a really great processor. It powers a bunch of instances. It's really powerful. Well, why am I here talking about it? Why am I so excited to talk about it, right? So the reason that we aren't calling these M5Gs or C5Gs, we actually bumped up the version here to 6, is that these are incredibly high performance instances, right? They are literally the next generation, right? So we went from the highest x86 based instances at M5, the Graviton2 based instances at M6G, right? So very performant. They're 20% cheaper across the board. If you look at the pricing, you literally take the price for the M5, slice 20% off, and you have the price for M6G. So even if you assume the same performance by transitioning from a 5th generation instance to a 6th generation instance, you're knocking 20% off your EC2 bill, right? And in fact, what most of our customers see is actually a bigger performance bump. They actually see anywhere from 10 to 40, 50% better performance. We like to play it safe and average around 20%, again, depending on the workload. We'll talk more about that a little bit later. And so, between the 20% lower cost and maybe 20% higher performance, up to 40% better price for performance. And especially when the session before us talking about running things at sort of mega scale, this scales really well, right? The more power you get, and the more power per instance, less cost per instance. You're talking real money once you start getting into large cluster sizes. So here's what it works with, and this list is growing every day. All the majority of the Linux-based operating systems you've got here, including the two BSDs. In terms of containers, ECS and EKS work really well with Graviton2 based instances. ECR supports multi-arch, which I'm getting to in a couple slides, and our open source projects, Firecracker and BottleRocket, also BottleRocket especially. Since GA has treated ARM64 as a first-class citizen, and we've worked closely with that team to really help out there. Couple things you'll notice looking at this chart on the operating system side, we don't have a Windows logo there. Microsoft does not put out a Windows Server SKU for ARM64. There's no server operating system for ARM64. So on the Windows side, so that's why we don't offer it. We don't have any sort of philosophical thing against Windows. We like Windows just fine. We like Windows containers. It's just not an offering that we can give yet. And on the container side, you'll also notice that Fargate is not on that instance. That is also something that we are working towards. It's on the roadmap. We want to do it. We're just not there yet. So watch the space. It's again, we don't have anything. We love Fargate. Fargate's awesome. It's super cool. We're just not there yet.
And Scott, there was a question about Solaris support.
Not that I'm aware of. If there's a specific use case that you would like Solaris for, please reach out and let us know. Again, we're not opposed to it, but I don't know of any customers who have previously asked to run Solaris on ARM64, on Graviton2. I mean, but let us know what you want to do, and we'll help you get there. Specifically about containers. Containers, they do share the underlying host kernel directly, right? This is the difference between containerization and virtualization. I think this should be fairly old hat to pretty much everyone here. But because of the kernel sharing, each container instance, and more importantly, the image that it is instantiated from, needs to have the same instruction set architecture, that is x86 or ARM64, as the host on which that container is running. So to put it more clearly, to run on an x86-based host, you need an x86-based image. And this is sort of the default that I would imagine most people here are used to, right? I do something on my x86-based Mac laptop, and then I run it on an x86 instance on AWS, and it just works, right? Conversely, the same thing's true about ARM64. If you want to run on a Graviton2 ARM64-based host, you need an ARM64-based image. And to do both, which is what we really want to do here, you need a multi-architecture image. All right. So how do we do that? Well, let's talk about that. Well, so step one is you got to build the images, right? And there's a couple methods here. The first one is to build natively on both host architectures. So you take the same Docker file, you spin up a Graviton2 or Graviton host, you spin up an x86-based host, you use some sort of CI/CD pipeline, or even Docker itself has a remote build functionality if you want to do more of a hub and spoke type workflow. You go in parallel, you build them, you push them to the same registry. There you go. Now, two things here. That's very fast, right? You're building natively, so the build should take a lot less time, and you're going to get the performance benefits of actually running and building that image on the architecture that it is designed for. So that's great. The other option is to build via Docker's new BuildX software, which under the hood leverages QEMU. It's emulation cross-compilation. This will basically let you say, okay, I've got a number of platforms. It uses BuildKit under the hood. You say, all right, I want an AMD 64. I want an ARM 64. I want a S390X, pick your poison. And you say, here's my Docker file, build all of them for me. Now, the sort of trade-off there is that using that is significantly slower, right? It's doing emulation depending on your Docker file, depending on what your Docker file is doing. There's a lot more math, just straight up math involved in there. So you're trading sort of performance for convenience in that trade-off, right? The one thing I will say for this is that you absolutely want to check in your Docker file the from image. You want to start with a multi-architecture image. If you start with an image that is only one or the other, then it's not going to work if you do it, because it's going to, it sort of turtles all the way down, right? Yeah. So you can use the image inspect command here, returns a JSON. Some would call it a manifest, if you will, a little foreshadowing there. That can be parsed with JQ to find out OS and architecture compatibility for a specific image. So once either we build in parallel or we use BuildX, we have our architecture images specifically. How do we actually use them, right? Okay, well, so the first thing we want to do is tag them, right? We want to, once we've got them built, we're going to tag them with their instruction set architecture. In this example, I'm using ECR because I love ECR and it's amazing, and it supports multi-architecture now. So we tag it with the correct ECR tag. We're going to create that manifest, which is that JSON that gets returned. Docker has a command to do this, Docker manifest create. And then you basically push the images, push the manifest to your registry. Okay, so we've built our two, in this case, two architecture images. We're going ahead and tagging them and pushing them just like you would with any other image. There's only one more small step of creating that manifest. And step three, well, there is no step three. This is the beauty of multi-architecture in the container world, is that the Docker daemon or your runtime daemon that's running on the host, that's talking to the kubelet or talking to ECS agent, right? That knows what instruction set architecture it's running on. It knows I'm on a Graviton2 based instance. I'm on a x86 based instance. I'm running on Solaris because, I don't know why, but I am. And it says when you run Docker pull, it talks to the registry and says, "Hey, registry, I'm looking for an ARM64 image. You got one for me?" And the registry says, "Yes, sure, of course you do. Here it is." And, "Oh, thank you so much." Right? There's a little bit of a handshake there, where automatically, if you have a multi-architecture image, the Docker pulls just work. It gets the right image without you having to manually specify and tell it, "Oh no, this is ARM. This is x86. This is something else. This is something else." So there you have it, right? That's sort of the huge benefit there, is that with a little bit of extra work up front, pardon me, to support other architectures, that you can get a tremendous benefit, not only in running the current generation of Graviton processors, right? Again, better performance for less money, but there's also a future-proofing side of it too, right? Right now, Graviton2 is, the best price performance on EC2. There may be sometime in the future instances where or workloads where that's not the case, right? Once we start getting into M7s, M8s, M9s, Graviton 3s, Graviton 4s, Graviton 5s, right? By putting in this initial work to go multi-architecture, you really future-proof yourself in terms of running the most appropriate compute fabric for your container workloads. And it just ensures that you can always not only performance optimize, but cost optimize. And especially if this is part of any sort of CI/CD pipeline or any sort of work like that, you really, it's almost sort of a set it and forget it, right? Like once you've built it once, it will typically just continue to work, right? So for, again, depending on your language, depending on your runtime, but interpreting compiled bytecode languages typically just work, right? They just go. A lot of times, like for Java, the JVM handles that lower level, or your interpreter, right? The Python interpreter is the one that actually cares what instruction set architecture it's running on. So typically that just works, right? Compiled applications, because they do generate a binary, will need to be recompiled. But any major compiler you want to work with supports ARM64. And I will especially call out Go and Rust for having really great multi-arch support pretty much out of the box. All right. For AMIs, showed you the slide earlier. Linux, absolutely. BSDs, absolutely. Windows, not yet, but you can find it there. And the vast majority of our tools work transparently, just like you would with an x86-based instance on Graviton2. So both CLIs, all the SDKs, the CloudWatch agent, SSM agent, EKS control, Kube control, ECS CLI, things of that nature. We do have a getting started guide on GitHub, AWS Graviton getting started. So that's been assembled by us and some of the EC2 team to really help you transition and optimize your applications. There's a great couple pages on containers specifically in this repo. It goes into a lot more detail about the languages and libraries and stuff that I just talked about. Lots of details in terms of optimizations, certain Java libraries that may use intrinsics and various other things, right? So, depending on how far down that rabbit hole you want to go in terms of, converting, SSE to Neon and things of that nature, we can, we'll be there, right there with you. In general, we, the Graviton team, are submitting patches and submitting work to the latest and greatest versions of things. We are, depending on the project, depending on the interest, depending on the usage, some of that is getting backported. But really, in general, if you want to ensure the best experience, you really want to be on the latest and greatest. That's all I got. y'all. Questions, comments, concerns? I mean, I'm just hanging out all day, but we're very passionate about this. We think we're really proud of the Graviton processor, and we'd love for y'all to try it. Works great with EKS, works great with ECS. T4G is literally free till the end of the year. Give it a shot. Let us know what you think.
Yeah, and I just want to echo what you said earlier, Scott. I mean, so 20% cheaper off the bat, right? So already you're getting cost savings. And then when you add it being more performant, it's like, why wouldn't you?
Right.
That's the question.
Well, that's, again, like, even if you assume you're getting the same level of performance, which, depending on the workload, we doubt, but, even if you assume it's just a straight 1-to-1, 20% off the top. I think that's the message here is it's at least worth giving it a shot. Right. I mean, depending on your EC2 bill, again, go talk to your finance department and say, hey, if I could take your EC2 number and cut 20% off of it, would that be worth a week or two of, dev time? Yeah. Right. Again, we're in AWS, we're in the cloud. Try it, especially with the T4s. I mean, it's free 99. You don't, right? You're not paying for that right now. It's free trial, which is unheard of. Yeah. That's really cool. Yeah, absolutely. And, that repo is, we do take issues. We do take pull requests. If you try something and it's not working, or, hey, this, you're doing something on Go and it should be doing this. Why, I'm getting some weirdness. Submit an issue to that pull request. That's why we've got, or submit an issue to that repo. If there's something on that repo that you try and you have a better way of doing it, submit a pull request. We take PRs, right? Like, we're on GitHub. We are here to make it work for you. So that's really fantastic. And even getting into your the build pipelines. Realistically, most of us that are working with containers in production, we have some sort of build, right? CD, CI, GitOps process. So it sounds like you're just adding, when you introduce, multi-architecture images, it's just maybe an extra step in your pipeline, or using Docker BuildX, and then push both of those images up. And now, regardless of the chip you're using, you'll be able to pull those images down and run them. And really, it's building the images that's the hardest part, and that's why we cover that. Is that once you have that in your pipeline to build either in parallel with BuildX, and then for any sort of CI/CD for your CloudFormation templates, add a G on the end, right? Like, I mean, well, bump the number up by 1 and add a G, right? It's 2 characters, right? Once you've gone and done that work, you can absolutely reap the rewards of just knowing that whatever architecture becomes the best for your workload, you can take advantage of it. And I will say it's definitely not as hard as a lot of people think it is. Sometimes I'll talk to customers and they'll think that porting something to ARM64 is this huge deal and is going to require a ton of work. And that's what we found is, again, for most people running interpreted languages, it's usually just either being on a later version or maybe a library or two, or sometimes it just moves over. Sometimes it's literally either a recompile or nothing that is you're not having, no one's having to hand hack assembly language like instructions here, right? So yeah. I mean, you can if you want. We love assembly too, right? But That's awesome. Well, look, the information has been given here. Go out, test it, play with it, see how it works in your environments. And always, we're always looking for customer feedback. So please bring it back to us. Let us know your experience. We really want to hear about it. So Scott, thank you. That was really great. We are going to once again jump to a quick little commercial break, and then we will be back to talk networking in EKS. So thanks so much.
Hey, it's Adam and Brent, and we wanted to let you know that if you're looking for more live or on-demand container content, you should subscribe to our YouTube channel.
Head on over to youtube.com/containersfromthecouch, and also check out our website at containersfromthecouch.com. Thanks.
Thank you. Good?
Yeah, I think that was
Feel good about it?
Yeah,
All right.
I feel pretty good.
Containers let you package your code so it can run anywhere. Before, you had to provision and manage servers, often requiring complex infrastructure to run your containers. With AWS Fargate, you can now run serverless containers, so you don't have to manage any servers. Fargate can quickly launch tens of thousands of containers and will seamlessly scale to meet your application's compute requirements. Live the Zen life and let Fargate take care of your containers so you can build powerful apps today. Learn more at aws.amazon.com/Fargate.
Feeling stuck to your old guard database provider with big price tags, high lock-in, and punitive licensing terms? Break free with AWS Databases, giving you the scalability, performance, and availability of commercial-grade databases at 1/10 the cost. AWS databases are fully managed, giving your team more time to build applications. Hundreds of thousands of customers have saved time and costs by moving to AWS databases. Join them. Gain database freedom at aws.amazon.com/databases/freedom.
Startups at every stage face challenges, whether it's finding the right technical guidance, building or scaling their business, or balancing time and resources. With so much to accomplish, startups need an easier way to find the right resources for their specific needs. Introducing the AWS Activate Console. The Activate Console is designed to help you through every step of your startup journey. With the console, you can explore the recommendation feed, which delivers personalized content just for you and your startup. By matching the most relevant content for you based on your startup profile, interests, and usage of AWS services, the recommendation feed saves valuable time by bringing the right resources directly to you. The console also features a built-in cost and credit summary, providing visibility into your AWS credit awards, balances, and bills, so you can make informed decisions while maximizing your AWS credit spend. With an added notification feature to alert you of pending credit exhaustion, you're always informed and in control. You'll also find the Tech Hub, which provides real-time updates on the health of your AWS environment, recommended AWS support services, and links to AWS technical support, so you can solve your tech problems quickly. Plus, the console showcases a wide variety of exclusive offers, discounts, free trials, and other startup-friendly perks from trusted organizations and software vendors that can add valuable tools to your startup. With the AWS Activate Console, you'll have the resources and tools you need to build, launch, and grow your startup on AWS, all in one place. Take your startup further. Experience the Activate Console today.
Okay, welcome back.
Again,
I feel like after the 8th or 9th time, it's less shocking, and the transitions are working better.
You would think. For me, it's just always a shock. So I don't know why. I'm just going to be surprised every single time.
It happens. It's understood. So, listen, we have quite a group here, and as I alluded to earlier, we're going to be talking Kubernetes networking on AWS, and I think Mike was here, but he had disappeared. I'm sure he'll be back any moment.
He knows where to find us.
He does. Containersfromthecouch.com, or no, he knows it here. Anyways.
Oh, good point. Yeah.
Oh, there he is. Perfect.
But we should do a round of introductions, and especially now that we're all back. Who do we have?
Let's start with Yang.
Hi, my name is Yang, and I'm working at Amazon EKS Networking team, and I'm mainly responsible for the AWS Node Balancer controller, which is pretty known as AWS LB Node Balancer controller, and my GitHub handle is Moonface.
Nice. Good to meet you. How about Shuba? You're up next.
Hi, everybody. I'm a product manager in the containers team, focusing on App Mesh and Cloud Map.
Cool. Fawad?
Hey, everyone. This is Fawad. I work with Yang and Mike and Shuba and everyone here. I'm responsible for AWS networking for EKS.
Awesome. And Mike?
Hey everyone, this is Mike. I'm one of the product managers on the EKS team. I've been focusing a lot on our networking features, so excited to share some of the things we've been working on with you all.
And you guys have been hard at work. There is a lot to share here, right? So I think we should probably just dive right into it. Is Mike, are you up first?
Yes.
Sweet.
I'll give a quick overview of what we're talking about here. So I think we have an hour today to talk networking.
Yeah.
We could probably spend days and just scratch the surface of networking in Kubernetes. It's a broad topic, but today we're going to cover three things. We're going to talk about pod security groups, which is the feature we launched in the last couple of months. We're also going to talk about the new AWS load balancer controller, and then we're going to finish by talking about service mesh and the app mesh integration that we've done with into Kubernetes.
Nice.
So those are our three topics. I think we'll mix in some questions as we're going here, but we also have a few demos, pretty light on the slides and heavy on the demos in this session.
Cool.
So let's start with the feature we're calling security groups for pods. We launched this around 2 months ago, and I think one of the questions that we've got a lot is why? Why did we launch this feature? Because Kubernetes already has a thing called network policy, which is a way where you can define policies to control network traffic. And network policies is really good when it comes to managing traffic within the cluster, but one of the areas where it struggles if you want to control traffic outside of the cluster to, say, other AWS services like RDS or Elasticache, as you can see on the screen here. And so it really came as no surprise that adding support for security groups directly into pods into Kubernetes was one of the top feature requests probably since EKS launched over 2 years ago now. Because security groups are such a core building block of securing any AWS cloud deployment, that our customers wanted to integrate them into their Kubernetes deployments.
Yeah, and I'm sorry to interrupt, but I just want to reinforce what you're saying because when you're at AWS, you're operating in a giant ecosystem of resources, and not everything that you're going to be reaching out to is going to be something that's in your cluster. So you want to take advantage of being able to reach out to those other AWS services, but still do it in a secure way. So this is an awesome feature.
Exactly. And I think the one thing I pointed out before I get too deep in this is we already had a feature that provides similar security functionality, but at the authentication authorization layer. So we launched a feature last year called IAM roles for service accounts, which lets you associate an IAM role to a service account within Kubernetes. And what that gives you is the ability to do fine-grained pod permissions to access other AWS resources. But what we heard is that a lot of customers have compliance policies that in addition to securing at the authentication layer, you also want to do it at the network layer. So it gives you that defense in depth where you're securing at both layers, the networking and the authentication. So I'll show, you can see this diagram on the screen here. This is actually from directly from the launch blog that we put out a couple months ago. And there are really two reasons we built this feature. One is controlling access to other AWS services, and that's what we're showing here. The other use case that I did want to mention is that we've heard from customers who are migrating to Kubernetes, right? There's a big push right now to modernize, migrate off of VM-based applications to containers so you can be more efficient in developing and deploying code. And one of the things customers told us is that we already have our compliance policies are all built around security groups. Our security teams aren't really familiar with network policies, so we'd rather just bring along our existing security groups and it'll make that process of migrating to Kubernetes a lot easier. So that was the other reason, is that you could also use security groups as an alternative to network policy if that simplifies your migration. So if you take a look at this diagram, this is the before picture. What customers were doing before to work around not having the ability to put a security group directly on a pod is you would spin up 2 separate node groups, because a security group previously used to be associated with just the node. And then you have to configure all these complicated taints and tolerations and node selectors. So you'd say, I want application A to land on node group A, and I want application B to land on node group B. And that's just not really how Kubernetes is meant to be used. You want to just deploy applications to a single shared compute and let Kubernetes take care of the scheduling. So this was before. And then if you scroll down here, this is after. Now when you can apply a security group directly to a pod and have those pods share the same node, you can consolidate down to a single node group and have, for example, pod A that needs to go talk to RDS and pod B that goes and needs to talk to Elasticache. And then I'll quickly run through here how we did this, because there is actually a lot that went on behind the scenes to make this feature possible. We integrated with, it's currently an internal VPC feature called ENI trunking and branching. This is something that ECS integrated with last year, and we added support for it with this feature. And I won't get too much into the technical details, but it essentially allows us to attach many more network interfaces to an instance than you can normally do. And for each of those network interfaces, we'll assign security groups, because security groups are actually associated with network interfaces, not just nodes. It's just in a VM world, you typically only have a single network interface. So node and interface are the same thing. So there's three steps there are three phases really that need to happen to make this feature work. The first is advertising the branch interface limits. We took advantage of a Kubernetes feature called extended resources, where in Kubernetes by default, it'll automatically advertise things like CPU and memory. That's nothing you don't have to do. But you can also advertise anything you want. So in this case, we're advertising these branch network interface limits. If you just flip this flag in the CNI plugin, then every compatible node will advertise, for example, there's 60 slots for branch interfaces. So you can schedule 60 pods that require their own security group. So that's step one. Step two is scheduling the pods to the nodes. And for that, we introduced a new custom resource definition. It's similar to network policies, but in this case, you're actually defining the security group. So I'll show a demo in a second here, but you're essentially saying, for these pods with these labels or these service accounts with these labels, assign these security groups to those pods. We have a webhook running on the control plane that's going to check if a pod is requesting or if it matches one of these security group policies. If it does, it's going to inject this resource request. And then the pod watcher running on the control plane will see that, and it will attach one of these. It'll allocate a branch network interface and annotate the pod with those interface details. And then step three is coming back and actually setting up the pod network. So back on the node itself, the pod spec is now annotated with these branch network details. And then the CNI plugin is going to run through a bunch of these steps to configure the route tables, IP rules, in order to set up the pod networking. So those are the three steps. We're pretty excited about this, and I'll jump into a demo here unless we think there are some quick questions we want to get to.
I think we should go ahead and jump into the demo just to make sure we have time for everything else.
We'll go quick here. So I think quickly I want to show I have an RDS database that's already spun up, and then I want to show the three security groups I have. So this is the RDS security group. In the inbound rules, I have this test security group that I created, and this is the one that I'm going to associate with the pod in my cluster. This is the test security group itself. Its outbound rules is it can talk to anything in the VPC, and I don't think it has any inbound rules. And then the last security group here, and this one's important, is the EKS cluster security group. So this will be applied to the nodes of basically any pod that doesn't need its own security group is going to be associated with this. So I'm making sure that in the inbound rules of my cluster security group, I'm accepting traffic from the pod that's going to get assigned this security group. So we'll quickly run through an example. I'm going to show two pods on the same node, one that'll be able to access RDS and one that can't. If we look at our policy here, let me make this a little bigger.
And while you're working on that, there is an easy question that I'll go ahead and pop up. It's So this manipulates the security group attached to the host's ENI, or it creates a new one for the pod. And I think this is one of the coolest things, is that it creates a new one just for the pod. The pod gets its own. Do I have that wrong?
Well, to be clear, there's no you create, like, you, the user, need to create the security groups ahead of time.
Fair.
We're
Yeah,
not
good
creating
point.
security groups for you. Think about the case where you have an existing VM-based deployment, right? You already have all these security groups defined for your applications.
So like the security group attached to your RDS instances.
Exactly. Like
Yeah.
the security group you assign to your applications that need access to RDS, you can just now bring that along with you to Kubernetes.
Perfect. All right, go ahead. Sorry about that.
So here's our security group policy. It'll look similar to a network policy. You can see it's the similar specification here, where we're saying I want to pick any pods with the labels, key, role, value, testing pod, and I'm going to apply this security group ID. And this is that test security group that I just showed. And I think I've already applied this to my cluster. And then I have a simple app that I'll show quickly here. It's written in Python. It's just going to connect to the database and print the version. So about as simple as an app you can write. So I push this to ECR, and then I have my pod specification here. I have two pods I'm going to deploy. One of them has the label. So this is going to be a match. And this is my connection info to RDS. And then I have another pod down here that I'm calling the failure pod, and this one doesn't have a label. So this one is not going to match the policy. So let's apply these to the cluster.
It's weird seeing failure created in the output. That's confusing. It makes my brain hurt.
I agree. For the next demo, we'll improve that. So let's take a look at the one that we think should be able to connect because it matched the policy. And sure enough, it printed out. If we actually describe the pod, you can see up here, we should have, you see this extra annotation that got added. And that's the control plane, the resource controller that's adding this annotation. It's saying this pod should get assigned to this ENI that has the right security group configured. And if we look at the logs of the other pod, we should see.
I think you want.
Sorry,
K
I
logs,
need
right?
K logs.
No problem.
One more try. Third time's a charm. There we go. So this one can't connect. So I have two pods running on the same node. One that connect to RDS, and the other that can't.
That's awesome. It's so simple, but at the same time, it's like it solves such a huge frustration. So this is awesome to see. Cool. There was another question that was earlier in the chat. Let me see if I can find it again. And it's unrelated, but again, we can talk about it real quick. Can we use these to create tunnels between clusters? And I'm guessing, and this was, by the way, whoever, I can't say it. I'm guessing maybe they don't mean tunnels specifically in the way we think of like VPN tunnels, but maybe they just mean access between clusters from one cluster to another. I think
the cool thing here that's different from Kubernetes network policies is the enforcement of those policies is happening on the node itself. And so that works within a cluster, but it doesn't necessarily work when you're like talking cluster to cluster. But in this case, the enforcement is actually happening by EC2 at the security group layer. So you can have security group rules defined outside the cluster that get enforced between clusters if you want to. So if that was the question, then yes, that is something you can do with this feature.
Awesome. So who's up next? Is it Yang?
It is Yang. Yeah, let me introduce quickly the next feature, and then I'll let Yang get into the demo because I know everybody wants to see that. Yeah, so the next feature we're going to jump into is the AWS load balancer controller, previously known as the ALB ingress controller. Recently went through a rebranding, and this wasn't just for the sake of it. We did this with good reason, and that's because we have a single controller that now supports both ALB and NLB. Previously, we only supported application load balancers, but now we support network load balancers. And I think the important thing to highlight here is we've taken a similar approach to what's going on with the CSI drivers, the storage drivers, for example, where that functionality used to live in the in-tree Kubernetes code. And the challenge with that is just the speed at which you can iterate. We're dependent on releases of Kubernetes to release new features, and that would really slow us down for, if ELB shipped a new feature, we have to wait for the next Kubernetes release train to release a new feature. So we're in the process of now migrating the load balancing functionality from the in-tree code to this external controller. And that really allows us to iterate faster. And, we have features that came out last month. We already have ones that are in the works for next month. And I think that's an important point to call out here. So I'll hand it over to Yang. He's going to demo some of the new features that were launched with the new controller.
Nice. Awesome. And Yang, do you have a screen share?
Let me share my screen. Okay. Yes. Is my screen sharing now?
Not yet.
Okay. Turn screen share. Sorry, it says my Chrome has no screen capture. Let's see.
Where's our doing it live banner?
We're getting there.
Awesome.
I was going to say we could maybe go to someone else, but I know Mike just gave this whole intro.
Okay, I think we have to re-log into this Chrome, so it will quit.
I think the exact same thing happened to me when I started. Just classic live demo.
Nice.
While Yang rejoins, I think maybe he's back already. But the two main features that were released with this new controller were grouping of ingress resources to a single application load balancer. So that allows you to save costs by sharing a single ALB. And then we also added the ability to do IP-based targeting for network load balancers, which, among other things, allows you to target pods running on Fargate with a network load balancer. And there were a whole host of other fixes and improvements, but those were the two to highlight, and I think the two that Yang is gonna show here.
Yeah. Cool. So in my demo application, I have two set of deployment. One is called Echo Red, which returns a web page with red color, and the ingress is when access /red, it will return red, and also if we access /color, it also returns the red application. Another one is Echo Blue. It's same as Echo Red instead, but the background color is changed to blue instead. And the ingress rules is if access /blue, it returns blue, and access /color, it returns the blue service as well. So we can deploy it into our cluster.
Can you make your font bigger, by the way?
Yeah, sure. Oops. Sorry. Yeah.
Cool.
For this one. Yeah, I think this one should be
better. Yeah, thank you.
Yeah, and we can check the ingresses in your cluster using curl. Sorry, hide this. The ingress is in the old version and also in the AWS on the back controller. By default, each ALB will result in a single load balancer. So I'm losing. Can we see the load balancer in the screen?
Yeah.
Yes.
Yeah, we can see it.
And also in the AWS console, we can see the two node balancer is created, and we can test the web page. So if we access /blue, it returns blue. And if we access the red ingress, we can access /red, it returns the red page. Also, we can access /color, it's the same thing. And customers has been painful with this stuff because ideally this two setup can be hosted by a single ALB to reduce cost. So we introduced a feature called ingress group, where, and the user is pretty simple. Inside your ingresses, you add a location called group.lane and specify the same group lane will cause the two ingresses be hosted by a single ALB. So let's modify our ingress to have the group name called my group, and then we redeploy our application. By redeploying, it will clean up the unnecessary ALBs and create new ones, which will host the both ingress. And then we can check our ingresses again. Cloud ingresses. We can see now both ingress is hosted by the same ALB. And we can, in our cluster, we can access the ALB. And with blue, it will return the blue page. And if we access /red, it will return the red page. And if we access /color, if we remember both ingresses use /color for its color application, it returns the blue because by default, the ingress rules is sorted by the name of your ingresses. And since blue ranks before red, blue will be appeared first. And we can also override the order using a location called group.order. So for example, if we want to red to appear first, we assign the red ingress is a lower order and the blue ingress is a higher order, and we can redeploy our application.
When you apply, how quickly do the rules get updated?
The rules should be updated, almost instantly. It should be updated within seconds. We can check the rules here. So refresh my node balancer page. Sorry, the web page has been pretty slow.
No problem. Your computer's doing a lot right now.
Yeah. Yeah, maybe we can just access this first. If we access color, it now is a red color because the red ingress is ranked first. And in the rules, node balancers. Yeah, the rules will be updated almost within 2 seconds. The rules will be updated.
That's awesome.
Yeah, and it totally depends on the latency from the controller to AWS Elastic Node Balancer API. And we can see the rules is actually effective. First red and the color from the red ingress. Also, a cool thing about this feature is you can add another ingresses into your existing application. For example, we can add a 2048 game into it. We assign the same group order. We assign the same group name and assign a group order with higher group order, since it has a catch word pass pattern. And we add it into our customized configuration and we apply. By applying, we will say that we created a new ingress And the new ingresses configuration will be added to this ALB. We can refresh this ALB page. It should be pretty clear. Yeah, you can see almost immediately the ingress for the 2048 game is added. And we can check these target groups created. And it should register the targets pretty quickly. Yeah, we can also access our web page if we remove the color. Oh, sorry. Yeah, we are now seeing the 2048 again. It takes some time for the ALB to propagate the rule changes to its data plan. So now we are seeing the 2048 game and also plus the old red and blue application on the same load balancer.
So we have some questions coming in from chat. Interrupt wants to know, do I have to delete the other ALB that's not used anymore, or is that automatic?
It's automatic. So in our AWS console, we can see there is only one ALB created for this node balancer. The other node balancer in my console is for NLB, which is for my next demo. So the control handle is automatic for you. So even if you can do things like change the group name. So for example, if I want my echo blow to be another group, I mean, it should be hosted by another ALB. I can just make it to be another group and apply. The controller will provision a separate ALB for echo blow, while the old ALB from game 2048 and echo red is kept.
Awesome. And then another question, I'm sure is pretty quick. Can you use this cross namespaces?
Yes, you can use this cross namespace. So far, the group name is cluster swap mechanism. So,
and then sorry, there's another question about what happens when you hit the rule limit per ALB of 100. And I think that's actually a really good point to illustrate the relationship that we're working with here. We're using ALB, which is something that we don't necessarily own or control as a service team. But this is a great opportunity for you to provide feedback to the ALB service team and try and get that limit raised up if it's affecting you. They're definitely going to want to hear about that.
Yeah, the rule limit can be raised if we cast support tickets to ELB team. And also this feature is here to allow the user to freely choose their group mechanism. So users should take the responsibility to make the rules for the ELB to be below the ELB limit for their account.
Yeah, that's a quota that can be raised. You submit a request to raise that service quota.
Perfect.
Okay, so I'll step into my next demo. So the next demo is called a service controller. So previously, the controller only supports ingresses. Now we added support for load balancer type service as well. So if you're on EKS from 118, you just need to apply a location called AWS load balancer type NLB IP to your service, and it will be supported by this controller, which uses IP targeting. So we can apply, and it supports Fargate as well. And that's the point we are making this controller. So, sorry. We can apply an Ninjax YAML, which handles the service and the Ninjax deployment. And we can get the service inside of the namespace. Sorry, my network kind of slow. And inside we can see the ALB is created for our service, and we can access it. And we can see it's the Ninjax deployment we are seeing. And also in the AWS console, we will see the load balancer created.
So cool. Awesome.
This is great. I think the one thing I wanted to call out, because I've seen some comments like, can I create the load balancer outside the cluster or use this for different clusters? And one of the features I didn't mention that we introduced along with this new controller is a new custom resource called a target group binding. The demo that Yang has here, the controller is automatically updating target group bindings for you. But if you happen to create your load balancers outside of Kubernetes, for example, using something like CloudFormation, but you still want to have the target groups managed within Kubernetes, you can take advantage of this new custom resource to do that. So you get the best of both worlds. You can manage your load balancers outside the cluster, but update the target groups using Kubernetes native controller.
Yeah, cool. So we have this target group binding CRD, which is responsible for binding the service targets into an ELB v2 target group. And with this implementation, we will solve a lot of scalability issues in the old controller. So previously, a pod update will result the whole ingress to be updated. But now, pod updates will only update in the target groups directly, instead of call a lot of AWS APIs to check for the settings for whole ingress. Yeah, awesome. I think that's it for my demo. Yeah, any questions?
There's one question that I think is an interesting one, just kind of high level. Can you speak to the pros and cons between the ingress controller versus other popular ones such as Nginx or Traffic?
Yeah.
And one of the things that I immediately that comes to my mind is just reducing the number of hops. I think the AWS VPC network mode gives us the ability to directly target pod IP addresses using those target groups. And so when we can pass the traffic directly from ALB straight to the pod without having to go through kubeproxy or an Nginx load balancer or any of that kind of stuff, then I feel like we've reduced the hops and therefore reduced the latency. What else might there be?
You're correct that it will reduce the hops, and that's one of the major benefits. Another benefit is for ALB ingress AWS load balancer control is the ALB or NLB is managed by AWS. So we manage the scaling for you, and you don't need to worry about the scaling. But using controllers like Nginx ingress controller, you have to manage the scaling for the nodes to handle the traffic spikes.
Awesome. Cool. Well, thank you, Yang. That was an awesome demo. And I think it did a good job at just crystallizing, how you can use one load balancer now to route, almost all of your traffic to whichever target group you need to hit.
Yeah.
All right. What are we going to talk about next?
Nice.
Nice. It's kind of an evolution in the discussion, isn't it? So let's see. I know that we have a quick talk, and then do we have a demo for AppMesh? And whose screen are we going to look at?
It's going to be me. Yeah.
Cool.
All right. Thanks for sharing the screen. I just put my contact information here. We'll also be sharing the slides and the demo code that Yang and I are doing. So to give you some brief background on what we're doing, we recently came out with a release of an AppMesh controller. And what AppMesh, for folks who are new to AppMesh or Service Mesh Land, a quick refresher, the idea behind Service Mesh is that we have services like ABC, and we co-locate sidecar proxies to every service instance. So that's something running local. So when app A wants to talk to app B, instead of figuring out how to talk to app B directly, it talks to the sidecar proxy, and the sidecar proxy will do things like service discovery, load balancing, rate limiting, health check, retries, etc. It will send the request to the other sidecar proxy on, let's say, app B, so that where they can link traces, logs, and metrics, and app B and app are only aware of the sidecar proxies that are running on the local host, and the network is basically fully abstracted from them, and the entire network topology and all the complexity on the things around discovery, retries, etc., is basically hidden from the application developers. And that's the value of service mesh. And AWS App Mesh is an implementation of a service mesh. It's a control plane which manages a mesh of envoys, which are co-located with your applications. A quick introduction. Next question is, how does App Mesh integrate with EKS? So let's say if you're running Elastic Kubernetes service, the way we do it, similar to how Yang showed you that the ALB load balancer controllers manage ingress and NLB, App Mesh controller is responsible for managing App Mesh resources. So you define your custom resources in Kubernetes, like mesh, virtual nodes, virtual gateways, or virtual services, etc. And what it does is that it basically reconciles or configures the resources onto your AWS App Mesh service, which basically comprises of three main components. There's a front end, there's a transformer, which takes your topology, converts it into the units which can be consumed by Envoy in this case. And then there's a service, Envoy management service, which configures these envoys or mesh of envoys. And this controller is responsible for providing seamless integration with App Mesh and Kubernetes, or specifically EKS in this case. And that's the flow of how you interact with managing resources, App Mesh resources. And it's also responsible for injecting sidecar proxies or any sidecar specific configuration that is outside the scope of EMS into your proxy, right next to your pods or deployments. So with the latest release, the thing that I'm going to talk about today is that we came up with, we introduced two new features. One of them was basically outlier detection. So just to give you some background, like what outlier detection is, or what is an outlier in the first place. So basically, outliers are extreme values that deviate from observations on data that may indicate variability in a measurement. So the same applies to traffic. While many of the issues are caused by bugs in code or applications, or in code, applications with thousands of hosts frequently run into like transient connectivity issues or flaky hosts for that reasons. And these issues have little to do with your application logic. How do you kind of take those out of your connectivity path or load balancing set so your traffic is not impacted? In this case, Envoy supports two types of health checks. One is active and passive. And quick refresher on active health checks, they are basically simple health checks that just ensure that your endpoint is available. And this approach, you can basically define some health endpoint, which shows that your up check is being checked, and that is part of your load balancing set or not. With outlier detection, it's sort of a passive health check, and it uses the responses from your real requests to determine whether an endpoint is healthy or not. And if it finds an unhealthy host, it will remove it from load balancing set in your cluster. Once an endpoint is removed, Envoy uses a time-based approach to reinsert. And when unhealthy hosts are re-added to the cluster, a configurable interval is enforced on them. So let's go over how that looks like. Let's say I have a user who is coming into my, let's say, EKS cluster using an ingress, which is managed by Envoy, which is talking to a front-end app, and I have a back-end app which has 4 instances. All of them are healthy. Things are working fine, no problem. But let's say there is a transient issue for whatever reason that connectivity from front-end to the back-end gets impacted. So let's say one of the hosts goes down, or it starts returning error responses. What will happen is that if you configure outlier detection, it will remove that unhealthy host. It will remove it for a certain period of time before reinserting it back into your load balancing set. And let's say if that host ends up becoming faulty again, let's say you removed it, it comes back in, and then it's faulty again, each subsequent removal increases the interval, which means you actually multiply your ejection time by the times it has been actually considered faulty. So basically, a persistently unhealthy endpoint does not do a lot of damage to your traffic in the end. So similarly, if you have another host which is unhealthy, that will also be removed, and your traffic will only be sent to your healthy host. I'm going to show you a quick demo of how this actually works. So the way the demo is going to be structured is that I have AppMesh resources you see at the bottom, and then I have Kubernetes resources. I have a virtual gateway, which is basically allows the resources that are outside of the mesh to communicate with resources that are inside your mesh, AppMesh mesh resource, which map to a service or deployment that I call ingress. And then that maps to virtual nodes, a front app, and a color app. And virtual node basically is just a logical pointer to a particular deployment or a pod. And that's where you have your listeners configured. And that's where your Envoy configuration maps one-to-one with your virtual node. So with that, this is the topology that I'm going to show you in the demo. I'm going to switch from slides to show you a few terminals. So what I have here is that on the left side, on the green terminal, I'm going to run a watch on the front app, which will show me how many backends I have. Let me run a few commands here, which will bring all the backends on the left side. And basically, I have 5 backends configured on the app. We can check it from looking at the Kubernetes deployment pod. So if you can see here, it's taking a bit of time. If you see, I have 5 instances of the color app pod. This is basically a deployment where it has a replica configured equal to 5. And those 5 instances you can see here are also showing up on my left window. What I'm doing in this dark window here is that I am doing a curl call over my ingress to the front app, which is just running me purple color from all the 5 backends. And as I'm making these curl call, you can see that the count of requests is incrementing. Just to define how it looks like, I have defined status, success, and error. They should add up to the total count here for each of those. So now I'm going to simulate fault injection in one of the hosts, and we should see Envoy in action ejecting that host, and we should see that we should stop sending requests to that specific faulty host. So let's go ahead and inject fault. So as I inject fault, this host, let me just add it here so we know which one is the faulty one. The host, which is BC52, which should be the first one here, will start responding with 500 error response whenever you make a get call to it. And now I'm going to run a traffic generator, which will send 200 requests over 4 seconds. And we should see what happens. So at this point, it sent. So let's see how we read this. If you look at it here, I have status code defined. On the left side, you have code. On the right side, you have count. So out of 200 requests were sent, 5 plus 195. Now 195 returned with 200 response, and 5 of them returned with 500 error code. And why? Because if you look at the outlier detection configuration that I have configured for this setup, I have configured that only maximum 5 server errors. As soon as an instance of my application returns 5 server errors within an interval of 10 seconds, I should eject it. So that's what happened with BC52. It was ejected. It was ejected for 5 seconds, which means any traffic sent to that host within 5 seconds will not be sent to it. It will be sent to the rest of the host in your load balancing set. So at this point, if we go on the left side, we can see all the requests were sent to rest of the 4 hosts. You can look at the counters increasing by a count of 40, but this one only got 5 requests. They were all errors and nothing else went here. But now that it has been more than, is there a question?
No, I was just saying that's awesome. And it's so practical. You did mention one thing that made me have a question. I think it was the interval, or was it it sounded like there was a time dimension where it would eject it, but for a limited amount of time, and then it would consider bringing it back in. Is there ever a case where you would just want it to stay ejected?
So the ejection, basically, the way it's configured is that, let's say your host BC52 is ejected once, and now it's been ejected for 5 seconds. Next time it's ejected, it'll be ejected for 10 seconds, and then 15 and 20, and then so on. So if it's a faulty host, the algorithm will try to keep it out for longer the more time it's actually being ejected. So that's how it handles it. So right now, let's go and try to run some traffic again, and let's see what happens. Since it's been more than 5 seconds, we should see the error happens again. But immediately now, if I run traffic again, I should see that all my responses are basically 200. So my application will not see any of those transient errors because of a host being faulty or otherwise. So that's that. Let me quickly show you how this looks like in on the dashboards.
I do have a quick question from the audience. How do you exit runaway conditions where your 500 error may be because of something like your database being down due to a failover or something like that?
Yeah.
I mean, time, obviously, I think that was probably one of the reasons to have that feature built in.
Exactly. Yeah. Like you have it configurable. In this case, basically, you can define whatever the tuning bounds you have. I mean, that's up to you. This is really up to the application that you have configured, and it may be like what I'm showing here is just within the bounds of a demo, and in practicality, it may be very different. Exactly. So yeah, you do have controls over all these parameters here. So basically, and you can also define what's my speaking of practical use cases. You don't want to set ejection percentage to be like 100. So you want to have a certain reasonable. I think the default in some cases is like 10%. In this case, I've set it up to be 20%, which means only 1 out of the 5 hosts that I have is getting ejected. And we can see it here, actually, if you look at some of the default dashboards, which are Grafana dashboards, which are shipped with AppMesh. You can see the number of ejected hosts are 1 here. The ejections over it shows you a rate here. It's like 2 because if something is being ejected twice, of 1 host can get ejected twice as well. So that shows you that. Let's go and quickly try something else as well. I want to go and my virtual node, and let's go and change my percentage to 100%. Actually, let's change it to 50%, but make all of my hosts faulty. So in this case, I will not be able to enforce ejection. Let's deploy this. And by the way, I'll share this. I'll put them on my GitHub so you guys can play with it.
Perfect.
So I'm updating my max ejection percentage to 50%. Once that gets deployed, I should be able to see that effect. And then I'm going to make most of the hosts faulty, and then see the detected ejections versus enforced will be different. And that, Envoy emits those metrics. They are picked up by Prometheus scrapers that you can configure in your production environment and expose them in Grafana or whatever dashboards that you use. So I've configured that, and now I'm going to go and eject faults onto some more hosts. So basically, I'm going all out and saying, all hosts are not going to work. So let's go and try to run traffic again. And I should see 5. So it's as you can see, everything is saying 500 response because no hosts are healthy right now, and I run it a few more times. But the fact that my max ejection percentage is 50, let me just change it here as well, is 50. The enforced ejections are going to be different than what the actual answer are going to be. So as you can see here, the enforced ejections are here is basically the detected ones are different, and then my number of ejected hosts are 3 because I've set it to be 50% in this case. So that was the demo about outlier detection.
That's awesome.
I'll go back to my slides here, and then I think we'll open the floor for questions. Shubha.
Yeah, why don't we do the next hybrid app mesh demo and then come back for questions?
Yeah, let's do that. So our next demo is actually from Michael Hasenblas. Some of you in the audience might recognize him. And he got together with, I can't think of his name off the top of my head, HashiCorp DA. They'll introduce themselves in the video, and that's where I was going with this. It's midnight or 1 a.m. wherever they live right now, so they sent us a video for demonstration, and I'm going to go ahead and share that now. And then we'll come back and we'll address any questions that come up. All right, let me see if I can get this working. There we go. And
hello and welcome to a little demo that Nick and myself have put together. My name is Michael Hasenblas. I'm an open source product developer advocate in the AWS Container Service team. And
I'm Nick Jackson. I'm a developer advocate at HashiCorp.
Cool. So what we put together is we wanted to show how you can set up a monolith with console and app mesh and containerized microservices together in 2 different accounts and have some kind of cross environment service discovery at play. And yeah, I guess I'm gonna hand over to Nick to walk us through his part.
All right. So let's take a look at the architecture. So what we have are 2 VPCs. In one VPC, it's where our monolithic application lives. The other VPC is where our greenfield application lives. So what we want to be able to do is we want to be able to expose the backend monolith to the new greenfield application. So how do we go about doing that when the backend monolith doesn't have a fixed IP address? We can do that because we're already using console inside of the monolithic VPC to be able to provide dynamic service discovery for our EC2 instances. Now, to expose that to Kubernetes in the greenfield environment, what we can do is we can synchronize the catalog from console to CloudMap, and the Kubernetes application is going to be able to consume the data inside of CloudMap and be able to then resolve to the backend VPC. To kind of connect the 2 VPCs together, what we're doing is we're just using VPC peering. So we've got a trusted route that allows traffic from the containerized microservice VPC into the monolithic VPC. So let's just take a quick look at this. So if we look at the console UI, you can see here there are just 3 simple services. So we're just paring this down to make it nice and easy. Now, backend is the instance that we're interested in. So this is an EC2 instance with a simple monolithic application running on it. Now, this is registered with console in the standard way, and console registers it, and it has an IP address here. So we can see the private IP for the VPC is 172.16.10.207 on port 1990. Now, for the Kubernetes environment to be able to access this, it needs to know what that IP address is. So what we do is we're going to use AWS Sync, which is a sort of a sub-process for console to be able to sync all of this service catalog with AWS CloudMap. So let's just log into CloudMap and take a look at the values, and you'll be able to compare and see that the 2 are exactly the same. So here's the CloudMap view. What you can see is we have console, backend, and Postgres. So exactly the same as what we have inside of console. So any change that's made to console in the monolithic environment is automatically replicated into CloudMap here. If we just drill in, let's have a look at backend. You can see here we've got a single service instance, and the single service instance is an IP address 172.16.10.207 on port 1990, which is exactly the same as the IP address which is registered in console. And just running that simple process as a background will automatically keep those 2 things up to date. And Michael's going to now show us how you can consume that.
All right. Thanks a lot, Nick. So I'm going to grab the screen share. All right. So we're now going to have a look at how in this EKS or Kubernetes-based application, we're going to consume what Nick published here in backend as a recap, the service discovery is done by a cloud map from my point of view, from the application point of view. Simply the name dot and the cloud map namespace. DNS-based service discovery, no big magic there. And then what I'm going to show you is when the user hits the /front end, which is behind or served through an NLB, then you will see how we call the backend and deliver the result to the end user. All right. So as I said, in the application, the EKS-based application, we have a number of things there. Some of these custom resources that you see here, they are for the custom controller that manages AppMesh for us. So we just declaratively say, hey, we want to have a mesh and virtual gateway that exposes that to the outside world and the gateway route. As mentioned, we want to be able to access this under /front end, a virtual node and virtual service, and then our actual deployment and service here. So let's have a quick look at what's going on if we say a kubectl get all, so list all the resources in this front end namespace. We see the respective AppMesh resources, the custom resources there, and also our front end service. Right? That is what we're interested in. And if we have a look at the configuration, so we created a Kubernetes and EKS cluster using EKS and also gave it full cloud map access. It's technically not necessary. It would be sufficient to for service discovery, because from my end, I'm only reading. It would read only cloud map would be all that is needed. But if we also want to expose services from our EKS-based environment to the backend environment to Nix monoliths, then we obviously need full access in order to write into cloud map. Okay, so that is all we have here. And as a kind of proof that it actually works, the URL here is essentially just the, let me show you where I got that from the ingress. So I'm just picking out the NLB FQDN, and then if I actually curl it, you should see, let me run that through JQ, what the backend produces, this JSON that comes from the backend. All right.
Well, thanks to Michael and Nick for working through that. And yeah, I'm glad you could join us on video, though not in person like here.
Very true. Next time we'll try and come up with a more European-friendly time for him to join, because it's awesome, valuable stuff for sure. I noticed there were a bunch of questions that you were answering in chat, Shuba. Are there any that you'd like to kind of call out and maybe, expound upon or anything like that?
Yeah, the few top things that I remember, somebody asked about MTLS. We are launching in preview in the next week or two before the end of the month. So, and we'll be in GA pretty soon after. So we are bringing in the capability to use either Spire certificates or bring your own certificate, mount it through a file path, expose it to AppMesh, and we'll be able to use that. So you can not just use end-to-end encryption, you can do client-based authentication as well. And we are really excited about this feature. So try it out. We have a lot of examples that will be published on GitHub. We already have that on GitHub in the AppMesh examples repo. And we'll share the link with you here. And whatever we demoed here today as well will be available. Yeah, the second question I wanted to address is it production ready? Yes, the team has put in a lot of effort to actually make sure that it's integrated well, it scales well with EKS, and we are really confident it will work well for you. So give it a try.
Awesome.
And I think Shuba, the important call out there, not only is it production ready, but we manage the control plane for you. That's not something you have to do yourself.
Yeah, so you're not really thinking, tracking all the versions of different control plane components, doing the integration testing, doing the upgrades. We are doing all of that for you. You have just the Kubernetes controller. You have the same, YAML spec, whether you like it or not. And you'll be able to think through a very service-centric model to get these capabilities. And the App Mesh controller, which is managed by Amazon, is going to do the computation of Envoy config, distribution of the Envoy config, and you don't have to do any additional heavy lifting to get these capabilities. So
nice. And McCulver has asked, I think a couple times, any plans for single control plane that spans across clusters? And it already is. Like, this is a shared control plane that is multi-tenant and massively scalable, and you can actually bridge EKS across clusters. You can bridge EKS to ECS, everything to EC2. So this can really help a lot with your migration story if you're trying to migrate from EC2 into a container orchestrator. You can do it with the help of AppMesh. So, and that's fantastic.
We also have a blog post on containers, AWS containers blog. The demo that you saw from Michael is going to be converted into another blog post as well. So this is not just cross-cluster, but also cross-environment, integrating with other things like console service discovery. And we have a cross-account support as well, which is really unique, I would say, because a lot of enterprises have multiple accounts, each service is in different accounts. So, but you can use AppMesh to bridge and route and get the same features across all of them.
Awesome. All right. So,
Brent, I was going to say before you kick us off, real quick, I always want to highlight that all our roadmaps are public. I know you probably hear us repeating this over and over, but the AppMesh roadmap, the EKS roadmap, it's on GitHub, and the features we build really does come from your feedback. So, we can post links to that, but definitely go check that out. We have a lot of exciting stuff coming next year.
Awesome, for sure. Well, thanks to everyone for joining. We have one more session coming up, and we're going to have a little bit of fun. We're going to make a couple of Boston cocktails, and then we're going to recap everything that we've gone over today and talk a little bit about what's coming up over the next couple of days. So hang out. We're going to take one quick break, and then when we come back, we will dig into this stuff. So see you in a minute.
Hello, I'm Junaid, a cloud support engineer here at the AWS office in Cape Town. Today, I'll be showing you a few of the methods to use AKCTL to create multiple node groups of Amazon EKS worker nodes. AKCTL is the official CLI for EKS. Let's get started. To add one worker node groups in addition to the initial node groups created along with the Amazon EKS cluster, we can use one of the two options. Add a node group with default parameters. By default, new node groups inherit the version from the control plane using version equal to auto, but you can specify a different version. For example, version 1.10. You can also use version equal to latest to force use of whichever is the latest version. Adding a node group with custom parameters using config file. Here is a sample config file to create additional customized worker nodes. I will show you an example for both the default parameters as well as for the custom parameters using a config file. As you can see, I'm already logged into the terminal. Check that AKCTL is already configured on the terminal with IAM permissions. Let's create an additional worker node group with default parameters. Now I will switch to the AWS Management Console. As you can see, I'm already logged in. I will navigate to the CloudFormation console. Check the events of newly deployed CloudFormation stack. As you can see, the CloudFormation stack is getting deployed and it's currently in progress. The CloudFormation stack has been completely deployed. Let's move to the terminal and confirm from the terminal as well. We are back on the terminal. We can see that all node configurations has been up to date. We can run this command to confirm the node groups attached to the cluster. As you can see, there are two node groups now. The first one was created by EKS cluster, and the second one we added additionally using default parameters. Now we'll create additional worker node groups using config map file. Let me type in the command. From the CloudFormation console, check the events of the newly deployed CloudFormation stack. You can see both the node groups are being created. We are waiting till the node groups become ready. As you can see, all the worker node groups are ready and up-to-date configuration. From the terminal, check whether the new worker node groups are attached to the cluster. ekctl get node groups cluster name. As you can see, we have default node group which was created using ekctl default parameters, and we have node group 1 and node group 2 which was created using config map file. Thanks for watching and happy cloud computing from all of us here at AWS.
All right. Guess what, everyone? Time to get down to business. All right, we have Kevin with us.
Hello, everybody.
Welcome, Kevin.
Happy Tuesday. It's like an alien.
And can you introduce yourself?
Yes, I would love to, Brett. It's like an alien speaking to another world. Having been online, excited to present you a couple of quick things very quickly. After the longest day in history for some of you probably, it's been a long day. It's been an enjoyable day. I don't know how you do it. So that's why I'm here to help. This is a hard position to be in, or maybe it's the best position to be in, because after a long day like everybody at Kubernetes and AWS has had today, it's time for a drink. Just one quick one right now. You can have more later once we're officially done, but I'm going to set you up on how to have a great evening. It's been a crazy year. We're doing so much of our drinking, our socializing, our eating, our living in this new fashion. I'm going to say this is the only bar in town, and it's my bar. My name is Kevin Brosh. I am the thirsty traveler. I have traveled around the world learning about cocktails, about culture, about language, about food, about society, and I'm happy to hear that I'm allowed to be in your presence. I'm honored to be in your presence, and we're going to make a couple of cocktails for you that you may want to try later tonight, be it in your home, in your hotel room, on your next trip around the world. Let's just get to it, shall we? And we're going to take our inspiration from Boston, and we're going to start with the Irish Buzz. And this is a really good, this is kind of like a Mad Men after work cocktail, okay? So we're going to take our Boston Shaker. Boston Shaker consists of an icy cold stainless and a glass. Into our glass goes what normally would be Irish whiskey because of the Boston influence, but because of some of the autumnal flavors and the time of year and the time and place, I'm going to use Maker's Mark bourbon. So I'm going to free pour 2 ounces of the good stuff from Louisiana, from Louisville, Kentucky. Sorry, Louisiana. What am I thinking about? I'm a bit nervous here, guys. We're going to take.
Don't be nervous. We're friendly.
I don't know your language, guys. It sounds like 1001001 to me.
You're speaking my language.
We all speak whiskey. We all speak whiskey. You're doing great.
Thank goodness. Okay, now I can relax. Thank you, guys. I love you, family. Hey, do you know what the word for family is in Hawaiian?
Ohana.
Ohana. Oh, look at that. Points to Brent, I think. That was Brent, right?
Yep.
Points to Brent. Ohana. So we have our Maker's Mark bourbon. You can use any bourbon you like. I'm not brand specific. Bourbon in the Boston Shaker. Then we're going to do a 1-to-1 ratio of water and sugar into the shaker. Then we're going to take some freshly squeezed orange juice, because I don't have time to squeeze lemons for you. Although I think I said oranges. See that? This is the way it goes. It's very easy. This is a bit more complex. This is a honey herbal liqueur, and you can buy it. And you can think of certain brands that make anything honey on the label with a bumblebee. I made it myself, and I'm using basically a lot of mulled spices with a bit of honey, and that's going to go in there as well. And we're going to add a bit of triple sec at the end. Some people know it as Cointreau, but the generic name is triple sec. And this is really, like I said before, I never really thought about it. It's a Madman cocktail, and it's really good for one strong drink after work, and it sort of sets you right. It's a bit like yoga. You know, it just sets you right. It's a bit like taking a 5-minute time out, whether you're given one or you take one on your own. You just kind of go, ah. That's what this drink is going to do for you, and that's why it's called the Irish Buzz. This shaker is nice and cold. You should be able to see some of the condensation on the outside of the stainless. You can buy these. These are really simple. If you don't have one, you can buy them from places like Amazon or a store or anywhere really.
Mainly Amazon.
Pretty much Amazon, but I wasn't too sure. All right, into the hand, okay? You can see that my hand is steady. We've been good all day. We haven't been partaking. And in goes the liquid over ice. And then we're going to sit it down very quickly. We're going to give it a pop. And now we can either shake it violently, which I don't like to do, but if it's your choice, you can. If you've had a really bad day, you get it a good shake.
Depends on the day, for sure.
If you've had an okay day, you just kind of like play with it. You go like, hey, how are you? I'm fine. You could give it what's called a roll. And you can just see what I'm doing. What I'm doing is I'm integrating all of the ingredients. I don't know if there's a Kubernetes term for integration of all the ingredients in the set pieces, but I think even though I don't know what I'm talking about.
EKS.
That's just the Kubernetes project.
Uh-oh.
I can also with the Boston shaker, I can see how the cocktail is doing. And I think that looks fabulous. What I'm going to do right now is I'm going to take my chilled glass. You can see how I've pre-chilled my glass. A cold drink tastes better, longer when it's chilled. I'm going to dump my ice because I happen to be in Canada right now. I'm sequestered in Canada. And ice is cheap up here. So I have a lovely cocktail glass. Sometimes the pressure, the vacuum seal that happens in these shakers, you really have to give it a tap, and you tap it on the side to release it. And I can already smell all of that goodness, all of the mulled spices, the Cointreau. I'm getting apple. I'm getting definitely bourbon. I'm getting cinnamon and nutmeg. And then all I'm going to do is simply strain it into the glass. Like so. And I know there's a few people playing along from home. And then I'm going to take, and this is where I cheat, and this is where I win, because what I did was I actually cut some apples and I candied them earlier. And I had this beautiful edible apple garnish. So you're not only getting the liquid, you're getting some dinner with this, or at least an appetizer. Let me just taste it. We nose it. Oh my goodness. OMG. That
looks
is
amazing.
a fabulous cocktail, if I do say so myself.
It's better than the one that I made.
Oh, no way. Come on. Come on. No way. They're all good. The best place to agree to disagree is in a bar. Okay? Life happens. As I've traveled around the world, life happens in the pub. It happens in the bar. It happens in the club.
Well,
and the best place.
Oh, sorry. I didn't mean to interrupt. I completely agree. I love the way that looks. That is so awesome. And I want to thank you, Kevin, for joining us and showing us the Boston. What was it called again? What was the name of the cocktail?
The Irish Buzz.
Irish Buzz. Yes, thank
I
you.
know we're running out of time. Do I have 2 minutes or not?
2 minutes. Yes.
2 minutes.
Granted.
Napoleon used to ride around. He was a short guy, right? And when he would get up on his horse, it was kind of embarrassing because he'd have to try and get that short little leg. I'm short too, so I can say this. I interviewed Napoleon shortly before he died. Once he got up on the horse, he liked being there. And Napoleon is the one that is credited largely for the fact he said, in victory, one deserves champagne. In defeat, one requires it. If you think about that for 5 seconds, guys, and take that to your next Monday morning meeting. Victory deserves, defeat requires. I'm going to show you how to open up a bottle of sparkling wine or champagne with a knife. I was going to make you a cocktail. We don't have it next time. We're going to do it now because life is short. You put your finger into the bottom of the bottle. It's called the punt, P-U-N-T. The bottle has to be nice and chilled. I'm going to back over here. For dramatic effect. Okay. No, I'm going to back over here for dramatic effect. And we're going to dip down the bottle. And we're going to slide the back of the knife or the blade or the sword or Napoleon's sword up the neck, and we're going to hit the Achilles heel. Okay? And this would make a great cocktail. If you want to follow me online, look for kevinbrox.com or The Thirsty Traveler. I'm not about advertising myself. I just want to do this for you guys as a celebration. Oh, now it's not going to work. And I'm going to feel so failed.
Yes.
Hang on.
We did it.
Let me show you so quickly. 5, 4, 3. You guys do so much good work for me. Let me do so for you. So we took the bottle off right at the neck. Look at that. A perfect strike. Just like Napoleon apparently used to do it when he claimed victory over Europe.
Oh, that's so cool.
And you can drink from it, but just watch out because it's extremely sharp around the edges.
Nice.
I'm so impressed with you guys and what you do.
Thank you, Kevin.
The best thing about 2020, I learned what this pocket in the apron is for. It's for your mask. So I'm gonna put my mask on and go drink some champagne. I don't know how that's gonna work.
But that's good advice.
Speaking of work, go back to work, guys.
Kevin, thank you very much. I love that this was the end of our day. It was awesome. Love it.
I love you guys.
Awesome. See ya.
I definitely want to demo that bottle trick with my kids, and I'm pretty sure my wife is going to object to the stunt. So.
Well, I've definitely done it before. It works for sure.
That is awesome.
I feel like there was a funny little joke in there about exponential retries, though.
Or a back off, maybe.
Yeah, exactly.
He didn't back off. He just kept going.
That's right.
Yeah. More brute force than anything.
Brent, have you ever broken the bottle off the bottom off a bottle?
Can you do that?
Oh, that one's fun too. Yeah, you can fill it. You can fill it like almost to the top, and as long as you hit it and keep it safe,
everything inside.
I think you need to demo that for next Container Day.
You do it after you drink. You fill it with something else. You don't want to do it with
like, oh, that sounds like it could be sad.
Not seeing the value here, Justin.
It's the total opposite of what Kevin just showed us. No, you're not muted.
Am I muted? Someone says I'm muted.
You're good.
Turn up your speakers.
It's the one for Justin.
Yeah, really?
Selective listening.
All right, so today was a big day, but you know what? What?
Wait. Did we?
Did you
I have my
shake it?
mixed drink. It's 23 flavors.
Cheers.
Is that like? Yeah. Watch, I'm gonna break off the top. Hold on.
Did the three of us make old fashions? Do we have like old fashions on the top?
I made a Manhattan. I'm being a little bit. You're drinking Lagavulin. I can tell.
Correct.
Yeah. I made a Manhattan. I'm being a little bit anti-Boston maybe because there's a little bit of a rivalry there, but it's what I had. So, cheers.
Cheers. Huh? Cheers.
It's I'm just gonna make a Shirley Temple. I'm over here. It's cool.
It's cool. Yeah.
I tried
I'm
to
gonna
follow
have-
him.
I'm having tea in honor of the Boston Tea Party.
Oh, that's brilliant.
That's the
Yes.
most Boston drink of the whole night, right?
It totally is. 100%. So
I actually busted out the I don't know if you can see it. This was an ECS launch glass from DockerCon.
Nice.
20 what year was that? 2014? 2015? Yeah. ECS, I still got it. It's
that is a collector's item.
Right.
Yeah, Deepak was handing him out at DockerCon. It was like first time I met him. It was great.
That's really cool. Dark Can wants to know, is that Zima? I'm thinking maybe Topo Chico or some other sparkling water. So we went over a ton of stuff today. Adam, do you wanna like try and remember everything? It's quiz time, right?
Oh, I mean, it was a lot. It was a lot. Like, we go back. We talked about security. We talked about best practices, right? Security best practices. And I think Micah did a really great job of just giving us that one, going over special interest groups and security, but then ending with that one page of, if you're going to do anything, do this, I thought that was really powerful. And then, obviously Bob kicked us off with the keynote. We had some really great announcements. We talked about MTLS. We talked about Carpenter, which still, I feel like we have to end with I still saw some questions in the chat around Carpenter, really trying to understand the value add of Carpenter versus cluster auto scaling. So maybe before we finish this, we can maybe have some parting words there. But then, then there was the roadmap, right? Nate Tabor went over the roadmap, gave us some really great stuff. And then GitOps, a lot of good conversation around CDKs, GitOps, progressive deliveries, progressive deployments. And I think, the GitOps is just going to continue to just snowball, right?
Yep.
I mean, as we talk about it more, does anyone want to add any color to any of those things I just talked about?
I think I'm sorry, I'm just going to jump in, but feel free to interrupt me in 30 seconds. No, I think the panel was one of my favorite sections because we talked about, all of these things individually throughout the day, but in the panel, we really tried to talk about how it all works together. And it's really a mind shift and a change in not just the technology that you use, but it's a change in the way you work, and it might be a change in the way that your engineering team is organized and the way your leadership thinks about how they work and how product gets rolled out. It's such a transformational set of technologies, and we're used to diving in and being this one thing solves that one problem, but really it's a whole ecosystem of things that do a whole lot of powerful stuff.
Mm-hmm. Well, we didn't even have to interrupt you.
For me, the highlight was having both Liz and Cornelia in the panel earlier today.
Mm-hmm.
Getting a chance to have Liz and Micah, who are both some of the top security people in Kubernetes, talking about security is pretty awesome.
Yeah, 100%.
Yeah, that was a great panel, and they touched on GitOps. I think it was Micah actually what he said. One thing that resonated with me quite a lot, having sort of come up, as DevOps as a methodology was coming online, and over the last decade, and looking at all of the tools that have been built around it, he made the observation that GitOps is really just sort of the next level. It's the next, so I sometimes say it's the next abstraction, but he's really right. It's just a progression of the same stuff. It's I think the best tools have opinionated best practices built into them, and that's how I look at the GitOps tool chain. It's fairly opinionated, and it does some really some things for you that you don't have to even fully understand. It's better if you do, but there's some good stuff baked in if you don't.
Yep, 100%. That's awesome.
Well, and Jesse, you've been around long enough, right?
Thanks.
Jenkins early on had I'm just saying some of us have been doing this for a long time, and Jenkins is intimidating up front, right? There's so many plugins and knobs and everything, and we've learned a lot about, hey, if you just do it this way, it works a little better. And some of that GitOps basically boils down like, hey, guess what? You don't need all of the bells and whistles. You need someone needs to give you an opinion to say, okay, go this route, and that's going to work for you. And then it just continuously does that. I mean, we learn from Kubernetes controllers to do it continuously. We learn from, how to do like, blue-green deploys and canary and all that stuff. Like those are just baked into the system, and you can say, okay, I just want this thing. Versus, something that's homegrown or more complex. You can do a lot with those other tools, and they still have a purpose in a lot of areas. But for, hopefully a majority of people can find that the GitOps workflows, those opinions, they can use those methodologies and just adopt them, and don't have to spend time setting up, Jenkins files or these other things. It's just like, oh, it's just git push and everything worked.
Awesome. So this is just day 0 of KubeCon. What's coming up? What's coming up day 1 and day 2? What should people be on the lookout to see at KubeCon?
So there's this thing called Kubernetes. If this is their first KubeCon, definitely jump into the CNCF Slack. There's a lot of channels. Anything that starts with a 4- something is with KubeCon. There's a hallway track that has a regular like Zoom call that you can just join, meet some people, go outside of your comfort zone. There's a lot that happens on Twitter and in Slack, I'd say. And those are kind of the areas that the Kubernetes community has kind of like focused on, is like, hey, the best thing about the Kubernetes project is the community. Like that's really where I like to hang out and meet people and see what they're doing and talk to people. So I would focus on those areas. The keynote, and I mean, there's tons of great talks. Like, definitely jump in on them. They are on demand. You can come see them when you need to. I think they go live at certain times, but then you can see them after the fact. And I know in the chat they were asking about recordings afterwards. CNCF has always posted them on YouTube afterwards. It usually takes a little bit of time to get them out there, but if you miss something, bookmark it for later. You can come back to it for sure.
Totally. And I know there have also been questions about seeing this replayed, and it's definitely going to be available, or already is available at youtube.com/containersfromthecouch. So you'll be able to see our whole thing. We'll go back and we'll add in chapters so that it's easy to hop around between sections and stuff like that. But for now, it's already out there. So definitely, if you missed the beginning of this, it's worth going back and rewatching when you have some time.
And by the way, so Justin, you have a talk at KubeCon. Do you want to plug that really quick?
Yeah, sure. My talk's tomorrow. I pasted I made a trailer for it because I'm just a nerd.
It's amazing.
It really is. I pasted it again. I tried to tell a story, be entertaining. There's so much great technical information out there that anyone can dive in and learn from these technical talks. I really wanted to kind of swing the other way. I've been going to a lot of, virtual conferences, and sometimes I can't focus on a technical talk for too long. And so I like to make things entertaining. This format, I think, is great for telling a story. So I made a movie. It just so happens to be the last 7 years of my career of what it was like to run infrastructure for entertainment industries, for making movies and for streaming movies. And again, it's somewhat light on the technical details, but I definitely wanted to use it as a starting point for doing more talks, doing more blog posts. If anyone wants to hit me up on Twitter, like I love to dive deep into kind of like decisions we made in these areas. And so I'm absolutely, open to having those conversations that further, figure out where people want to focus. But really the talk for me was, I just had so much fun learning a lot. And I, trust me, there's a lot else of other things I built along with the talk. You'll see it tomorrow. I think it's noon Pacific. 3 Eastern is when it airs, and so I'll be there on the Q&A as well. And I'm also the keynote on Thursday. I'll be doing a pre-show and post-keynote commentary on the CNCF Twitch. So come over to that too. We just have early morning, at least early morning for me, kind of pre-show about what's going to come up in the keynote, and then after the keynote happens, kind of dissect it and talk about it a little more.
Amazing.
Nice.
Jesse, what are you hoping to catch in the upcoming days?
I was thinking of a couple of sessions I was going to call up, but you know what? I want to make a more of an observation because we might get short on time. So related to what Justin was saying, it's not super technical. It's not super in depth. You're not going to have screens of YAML you're going to cut and paste. And to me, as someone senior who's been going to conferences for forever, these conferences get really useful to me personally when a story is told that resonates with me. So my advice for KubeCon goers is to just look around for things that are interesting to you, right? You will always find the tutorials with the YAML that you can cut and paste. There's going to be a lot of content that will help you when you get back to your day job desk and just sit down and say, how do I solve that problem? But look for stuff that resonates, because I think we best express the power and the immense just reach of this ecosystem through stories that resonate, right? So, and I think there's just going to be tons of them at this conference. It's one of the reasons I love this one.
Awesome.
It's a great conference for that.
Well, Bob, you want to bring us home?
I can try to do that. I think my first thought is that I love the format today, and the job the Containers from the Couch folks here did for us today, getting everybody kind of assembled and keeping conversation going and asking great questions on behalf of the viewers was super awesome. I believe I'm sure we'll get feedback about this from the viewers, but as this one viewer says, "Awesome job, thanks so much." That was great.
Thank you.
When it comes to KubeCon, I missed a couple of the European KubeCons, but I've been to all the KubeCons since the beginning. And so I'm definitely a little bit more regretful here about this KubeCon, because normally I don't go to many sessions. I'm entirely on the hallway track, just catching up with lots of Kubernetes community people that I've known since the early days. And what I end up doing is I'm gonna try the hallway track Zoom out this time, but I actually do the hallway track on Slack. I end up just using the week as an opportunity to touch base with folks that maybe I haven't talked to in a while. So I'll definitely be doing that. And the things that resonate with me are the customer stories, and I'm always keeping an ear out for the sessions that have the cool customer story in it, from previous KubeCons. Running Kubernetes on the F-16 was one that I thought was particularly awesome. So I really enjoyed discovering those nuggets at KubeCon.
Nice, awesome. All right. Well, for everyone out there, thank you, and thank you for joining throughout the day. That was a nice surprise, and we loved having you. And thanks to Jesse and Adam and Justin and everyone else that joined us. This was a lot. This was a lot of time that people dedicated, and I hope that it worked out for everyone that was watching. And so, like I said, we'll have the videos available very soon. And if you missed anything and you want to go back and rewatch, definitely do that. Definitely check out KubeCon. Find, like Jesse said, things that are interesting. Like Rothgar said, things that push you out of your comfort zone. And like Bob said, the hallway track and just trying to sort of absorb how people think about things and get into those conversations, I think is going to be super valuable. So until next time, definitely if you liked this and you want to know more about containers on AWS, join us for our regular Containers from the Couch sessions, Monday through Thursday, 12 to 1 p.m. Pacific time. And it'll be Adam and me sometimes. It'll be others sometimes. We have all of our DA team joining in, and then we also have partners, and we have specialist solution architects, and we have customers we're hoping to find and get them pulled in. So I think it's going to be a fun year, and there's going to be a ton of stuff to go over. So subscribe now and find the content that you identify with most. So I thank everyone. And with that, we're going to go ahead and call it a wrap. See ya.